that happens like in water, right? But an aerosol can is different because it's a pressure going out, right? So I think that would be nullified by the vacuum of space, the minus 17 torr. So
No, it expands inside.
I don't think it get nullified,
the
man.
nozzle.
I don't think it get nullified because there is like a chamber or a nozzle it's going through,
Right.
which does create the scenario very reminiscent of throwing a bowling ball on the ice rink or whatever. I get what you're saying about it going in all directions afterwards or whatever, right? But I don't think it's actually completely nullified.
But it would be less than an Earth's atmosphere because there's no atmosphere to push off of, right? So what's the?
Well, it'd definitely be less. Yeah, rockets, just like a speedboat turbine, right? Like the underwater like boat engine propellers, right? They work better underwater than they do in the air, right? So yeah, like the thicker the medium, the better, the more thrust is going to be created. But still, like it even a boat propeller could move a floating, like if you strapped a balloon to the bottom side of a blimp, the boat turbine still would be able to propel the blimp forward, just not as efficiently as if the boat had turbine had a thicker medium to work with.
There are jet boats. There are large jet propelled ferries that actually run on hydrofoils that lift the boats out of the water, and they actually run better on the foils than they do in the water.
No, the engine is still underwater. It's just that the bottom, there's less like friction of the bottom of the boat. You know, it's more like water dynamic. But the propeller, the turbine is still underneath the water.
Yes, but it's thrusting the mass of the water. It's actually taking that water and moving that water. It's not a rocket underwater. A rocket underwater would work shittier than a rocket in the air.
So you think a propeller will propel you in space?
Do what?
A rocket
propel you in a vacuum, in a negative 17 torr vacuum, like it does underwater and it does in the air.
If you could disregard, if you can toss to the side wind resistance or aerodynamics, a rocket would work better with something to push off of than nothing to push off of.
I disagree.
Disregarding
you have nothing to push off. No.
Okay.
Aerodynamics aside, and I could be wrong on this one. I'm not going to die on this hill, but as far as I'm concerned, when you having 0 psi pushing back on that rocket fuel will have your exhaust velocities come out higher. Your mass will be accelerating quicker as you get up into space.
If I can propel myself through a vacuum then I should be able to vacuum myself through an atmosphere. I should be able to vacuum myself straight forward. If I can propel it through a vacuum, then I could vacuum through fucking matter, through an atmosphere.
How do you think that's
what a plane is?
Well, think about this, Moyak. If there were two people floating in outer space and they weigh the same amount and they're like face to face and they push and they have their hands like palm to palm, right?
Yeah.
And they push off each other. Say they push at 100 miles per hour away from each other. That means both of them are going to move 50 miles per hour away from each other, right?
Now, if they're both equal in weight, yes.
Yeah. Now imagine one person has a wall behind their back. The person without the wall on their back is going to, go 60, and the person with the wall behind their back is going to go 40. So
I think it'd be more equivalent to blowing onto a wall, like taking a big breath, like 50 times your breath, and blowing onto a wall and see if you can propel like that in a vacuum. They always like to compare guns instead of gases.
It's really hard to do the analysis on this because, when a rocket takes off at launch day, when it's closest to the ground, it's got the most mass. So you can't say that it accelerates really slow when it's close to the launch pad. What you would have to do is launch 2 rockets as you're going up. Launch one at sea level and then launch another one 1,000 feet and see which one goes further. Same type of rocket.
Yeah, but don't forget you're analogizing a gas and a solid object when you use the bowling ball. So let's stick to the gases.
What's the difference?
What's different? Yeah, I am dumping with the Atlas V rocket. I'm dumping like a couple of 1,000 pounds of fuel every single second has to get out of that tank and go away from that rocket.
Wonderful. You know, so you should be able to show us. Wonderful. Yeah.
How much is pulling again? You're talking about propelling with a gas, though. Like Montreal said, let's stick to a gas. So how much of the vacuum is sucking? Like a gajillion, countless amount of times that gas it's sucking compared to the little amount you're blowing. Everything is sucking.
It doesn't suck at all.
Well, for lack of better terms, how about that?
The pressure pushes out. It's the same difference. Pressure pushes out. Vacuum sucks the pressure out.
Yeah, the
it's
gas
like a vacuum
flows.
chamber. It sucks the pressure
The
out.
action of flowing creates momentum transfer.
In other words, if I had a capsule in space with a bowling ball sitting in it in a regular atmosphere, if the bowling ball was in the corner and I opened the door, then all that air is going to go rushing out, and the bowling ball ain't going to go nowhere. It's just going to sit there in the corner. So don't use bowling balls to explain propulsion in space, because you might be able to sputter if you constantly launch bowling balls, but you're not going to do it with fumes or gases.
Because if you have the bowling balls, you can just get your way from the Earth to the Moon. It's really important. Global logic.
Regarding pushing off the atmosphere, imagine I have a high pressure chamber, and let's say my rocket only is able to expel 100 psi. So I put it in a 10 bar, 140 psi. I have a 10 bar pressure chamber. If I launch that rocket, how vigorous will that rocket launch?
It'll launch, but I'm going to tell you right now, you're going to have to expand the nozzle the higher you get. The less atmosphere, the more you're going to have to expand the nozzle to basically until there's no atmosphere and there's no amount you can expand it to get any more push.
True.
You're sort of right. That's why vacuum nozzles are larger. Engines optimized for vacuum have larger nozzles.
Because you want the exhaust. What do they say? They want the exhaust pressure to be near as close to zero as possible.
That's right.
You want to use all that energy to make it into forward thrust.
Right.
So you want every
pressure.
Yeah.
But the engines that have to battle with the atmosphere, you want them to be expanding into one atmosphere.
That doesn't make sense. If you're working with something to push off of, you're gonna want it. Or if you're working with like something to push off that's getting thinner and thinner, you're gonna want it to get wider and wider to compensate. But there's a reason that it's not as wide at sea level as it is the higher you get. But I feel like that resets once you get into space. Why would you want things not in alignment with the direction you're heading? Like once you get to space, it should revert back to a narrow nozzle, because you don't want to waste any momentum going off to the sides when all you're trying to do is go forward.
Well, the whole thing
nozzles don't go off to the side at all.
Yeah, that hydrofoil jet boat, I just posted the image. You can see the jet is actually up out of the water. The intake is below the water, but the jet is above the water.
So I haven't looked at it, but you're saying it's not like a water propeller, like a water turbine?
Yeah, it is a water jet, but it picks the water up below the surface, but it pushes it out of the back of the boat rather than being below the surface.
This sounds like not a conventional boat engine. Then I'll have to look at this.
No, it's a jet.
Yeah,
Jets have nozzles on them.
But if they're going to use guns to compare it, they should use like a CO2 gun, so without the BB. If they're going to compare rockets to guns, they should so you think if you took a CO2 cartridge and pumped it up, like just 10 pumps, you think blasting it off into a vacuum would propel you? I don't
Absolutely.
Because I don't think it would for a second, because the suction, for lack of better terms, again, the suction is going to be way more enormous and way more massive than the damn little tiny bit coming out. I mean, it's going to be insignificant compared to the void that it's entering into. It's ridiculous to think it would propel you.
Brian, I don't think very little to do with it.
I don't think those are the properties that work in this scenario. That's sort of like a more like earthly, like mundane sort of way of thinking about it, but I don't think those are the operating factors at work and what they're talking about. Like it's not about anything outside of the nozzle, right? Once it's left the nozzle, it has nothing to do with the propulsion anymore. All the propulsion happens like within the chamber.
And the bell, the last contact with the bell.
Yep.
Basically, what you have is a bunch of molecules bouncing all over the place. One direction they can go, they don't bounce off of something. So they push against the rocket when they bounce off of the rocket. Yeah, the bells, the combustion chamber, the whatever.
So volcano.
And then
so
the last one, as it gets.
Sorry, I thought you was done. Sorry.
Yeah, no. And as the last interaction with my rocket happens, that results in forward thrust. It bounces off of the bell and pushes.
That's what you just said, dude. Look, so a good volcano would blast the Earth out of orbit, then, right? Or a nice solar flare, or a nice solar flare might knock the sun around, so things can propel themselves in nothingness now, I guess. So a big old solar flare, a big massive solar mass ejection. So the next solar mass ejection, let's measure the sun because it's going to go soaring off into another fucking orbit.
Sure.
Yeah,
What fraction of the sun of magnitude?
Hey, that's fun though. That's a fun thought. That's really interesting to think about. Yeah, really, you gotta admit.
That would be awesome.
If you get a 25,000 mile an hour volcano erupting and ejecting mass off of the Earth at sufficient amounts to make the planet move, then yes, you're right.
Well, yeah. So a solar mass ejection is like 1,000 Earths, right? We got 1,000 Earths ejected. What do you mean no?
Oh, okay. As far as the sun moving, you said the sun moved.
Yeah, so a solar mass ejection, and it's literally ejecting mass, right? So it's going to propel it.
Tiny amounts. It's sort of like trying to move a battleship with an aerosol can.
Dude, they got solar mass ejections like giant in size compared to the sun. You see them big old arcs. I mean, dude, you're talking about a lot of mass, man.
It's not the size that matters, it's the mass that matters.
Proportional. I mean, and they're going to have an excuse for everything, man. It's just
it'd be cool. It'd be cool if we did some experiment to make the Earth rotate faster. Like we got a bunch of things to like blow air in eastward, or whichever would be west, probably eastward, right? We got a bunch of that, and we could like shorten the day. Days are not 23 hours long because we got a whole bunch of planes to fly in the same direction or something like that. That'd be cool. Sounds like something we could do.
Yeah, theoretically, that would be possible. Yeah,
that's funny, man.
Yeah,
but how about, dude? They act like all the air in the atmosphere could just sit here up against Earth in this giant void, and all this pressure, and then a rocket just sputtering out a little something's going to make it haul butt. It's almost like just saying you could take a tube,
it's like it's called physics.
You could take a 1 mile, you could take a half-mile diameter tube and raise it up to like 100 miles. And you'd start propelling the Earth somewhere or something, man. They got a vivid imagination, man.
Well, if you can get enough mass to leave, sure.
Imagine a nice huge solar flare. Wouldn't that set your sun a moving according to your?
No, not really.
Yeah, like a solar mass ejection, right? I see a solar mass ejection.
Yeah, it's only what hits the Earth. How much mass of that coronal ejection hits the Earth, and how much is that mass compared to the Earth?
I'm not talking about.
You're just talking about the sun moving again.
Displacement of the sun, yeah.
Okay, so displacement of the sun. You've got an ejection happening at I guess it is above the velocity of the sun. But when you look at a rocket, how much of its mass is it ejecting in the acceleration of that rocket? It's using 96% or 98 or 90% of the rocket.
Yeah, but you said no resistance in space, though. There's no resistance, right?
There's the resistance of the inertia of the sun. The sun weighs trillions and quadrillions of tons, and it's ejecting a couple of thousand tons, a couple of million tons.
How do you weigh the sun in outer space? What do you mean it weighs? I thought it's free falling. I thought it's free falling around the.
Not the weight. Yeah, just mass.
Are you guys adjusting your answers?
No.
No.
Right? I said it wrong. I used weight. I'm sorry. I'm a colloquial speaker. And you guys by now should understand the relationship of weight and mass and that they're relatively synonymous.
Yeah, but you said no resistance in space, though, right?
And there's the resistance of inertia of the sun. The sun weighs a fuck ton, and what it ejects is much less than a fuck ton.
But it would be something, right? According to your own theory, according to your own model, it would have to be something, right?
He just invoked weight again, also, right after saying I shouldn't invoke weight.
And then why do you quibble over stupid things like that? Why, at this point in this conversation, do you quibble over?
You said a vacuum doesn't suck, dude. So I'm gonna get technical with you, bro. You gonna get technical with me?
Okay, fair enough. I'll give you that.
So you have to admit that, according to your own theory of displacement, a coronal mass ejection, which is a massive amount of force, right? Power, creates a solar wind. According to your own thing, it would have to displace the sun, right? Even by a tiny fraction, right?
Tiny fraction, yeah.
Yep. So what? Who says
so
it
now
doesn't?
you're saying, yep. Okay.
Well, who says it doesn't?
Yeah, it'd be like immeasurable, though.
Yeah. Okay.
It does,
moved a whole
but it would
micron.
be immeasurable. Got it.
It moved. No, not measurable.
Yeah.
Immeasurable. Yeah.
Immeasurable. Right. Okay. Yeah. So as if it didn't happen, right?
Yes.
It's a little different.
As if it didn't happen.
Different term.
I love it.
Impossible to measure with current methods.
Yeah, it's amazing how you guys do this, man.
It's like in theory, like if you jump, does the whole Earth move?
Yeah.
Yeah.
It does. A tiny amount.
A little bit.
The other stat that I really like is the gravity assist for the probes. You know, like things that have used the Earth gravity assist. They robbed a little bit of kinetic energy from the Earth, and the net effect of that is like a micron over 1 trillion years or something.
A trillion years. Wow.
Yeah.
I'm sure that could be tested, huh?
Nope,
No, it can't because we won't be here. But you know, the ordinary physics can be used to calculate the net effect, and that's what it comes out to. That's just a way of describing the magnitude.
See, that's how they get you guys, man. You guys love math, right? And I could understand why.
Useful.
They get you. Of course it is. We use it every day, but that's how they get you to think. They get you into the fantasy by just thinking of it mathematically and not logically.
Putting you on paper, they get your head looking up, adding shit up on papers. The great scale negator.
Yeah, that's why really smart people do all the math, while all of us just sit around here arguing about it.
It's like, and I can move an aircraft carrier. Assuming that there's no wind, no nothing, I can take a whole aircraft carrier and I can move it with my one arm. It's going to take me a week to get it moving, even perceivably, maybe.
Only if you utilize mechanical advantage.
No, I can do it with my hand, just pushing it. I mean, I've done it up to like
you'd never overcome the friction. You'd never overcome the friction in the wheels or the service. What are you talking about, man?
There's no wheels in an aircraft carrier.
Are you claiming you're going to overcome the inertia of an aircraft carrier? You're going to push it, let's say, from where it's moored, and you're going to push an aircraft carrier? Is that what you're saying?
If you're floating on outer space and you jumped off of it, sure.
No, if I tie a rope to the bow, if I tie a rope to the bow of the aircraft carrier, and I hook up a winch to it, and I put 200 pounds of force on that.
Oh,
will that aircraft carrier eventually
use a winch?
Stop. That's so I can do an even amount. I put 200 pounds of force on that winch. Will that aircraft carrier eventually begin to move? Whether it takes a week, 10 days, 20 days?
It won't. It wouldn't come down to time because you wouldn't be able to overcome the friction with that amount of force.
What friction?
The water will move out of the way.
The friction of the ball bearings.
What's ball bearings?
That's why you see people. Isn't that why you see people pulling like tractor trailers?
Yeah.
Like a 200-pound man pulling a tractor trailer.
Yeah, that's not an aircraft carrier. And if he said, and of course those strongmen have a lot more than 200 pounds of force.
But he still wasn't able enough to put enough force to move it, though.
Yeah, but
might not be a lot.
Even a tractor trailer, an empty tractor trailer, you're going to need more than these people. They can lift like 700 pounds with their squat force. Okay, so 200 was just lowballing it. I'm not saying what you're saying is like inconceivable, but just you need a little bit more than 200 pounds. I'm just saying, 200 pounds isn't going to overcome the friction.
What friction? This is what I can't understand. Okay, now
in the ball bearings. Are you using wheels?
Bearings. What the fuck are you talking about? Ball bearings? What ball bearings? It's an aircraft carrier sitting in water. There's no ball bearings, no wheels. What are you talking about?
Oh, okay, so it's in water then.
That's what aircraft carriers do. I don't pull them on land.
Do you know what an aircraft carrier is?
Sure, but it doesn't have to be in water.
Yes, it does. In order for this test to happen. No, I'm not going to drag it across the sand. You're right. I'm not going to drag it across broken glass or potato chips.
No, it's in the water.
Aircraft carrier on a trailer never happened. Doesn't exist.
Yeah, I don't think so.
Could you up the intensity a little bit? Is it possible?
Well, he said like 10 times ball bearings, and I question him every time on that. What he's talking about?
Oh, be more specific. Of course, you're going to have to overcome the air resistance too.
How many
tractor trailers out of the way?
Okay. How many tractor trailers would it take to hold an aircraft carrier?
I don't know.
How long would that road have to be? How would you make a turn?
That's why they pay B-ball the big bucks.
You're saying to tow it?
Why don't you just sail it?
I thought that was funny.
Yeah, I mean, as far as the medium that you're in a fluid. So I said, assuming no wind. So we got a big shed we built over this thing. It's got no wind, and it's just floating inside of this little room that we put in. We built a tent over it, and I want to move it 10 feet. You could do that with 200 pounds of force.
No, because you'd have to. You got the water displacement to think about. But
yes.
But I guess
part of the weight.
Water and air displacement, I guess, would be the only factors that work. But because they're fluids, I suppose you're right. I take back what I said. You're right. Over a certain amount of time, I guess time would be the factor after the displacement factors in. Yeah. Okay.
Right.
I apologize.
No problem. It's just the ball bearings is killing me, man.
I was just imagining you moving it like how else are you going to move something over land but by wheels, right? That's what I was thinking.
Oh yeah, no wheels at all. Aircraft carriers never touch the land unless their captain's really bad.
Yeah, hopefully not.
You gotta admit that's funny, guys. Come on, Gambino. Even you gotta admit this is funny, man. Moyak pushing an aircraft carrier. If that ain't funny, I don't know what is.
I mean, what I've done, I've done it with boats, up to like probably 50,000 pounds. You're coming in, you're going a little bit awry. You get out the boat pole and you apply, 50, 60 pounds of force, and you're slowing down that 20 tons of boat or 10 tons of boat. And it just takes longer. It just takes a really long time. You just got to absorb it over a long distance.
You can move a car. Push us.
Well, there was one guy who pulled an airplane. What was it?
747 like thing? Commercial?
Yeah, there was one guy. Yeah, this monster dude. Yeah.
And those you have to overcome. There's some weird things in that I don't fully understand. Like you have to overcome the initial moment of inertia when you're dealing with like wheels and stuff like that, and rolling resistance and all that shit. So it's a bear to move a tractor trailer. It'd be harder to move that than equivalent weight on water, obviously.
Yeah, there's static friction in that situation.
My alternator broke in my car, like in the middle of nowhere, right? So the battery, my alternator broke, and of course the battery had a certain amount of charge, but I got about like 2 blocks after it just totally went kaput, right? And the battery was drained, and even if I jumped the battery, it would only have enough charge to carry on for like 10 feet before the car just completely died again. So I got in neutral, and I parked on the side of the road, and I learned a very real lesson that pushing a car on level roads is actually not that hard. But even if there's like a half a degree of tilt, I mean, like 1 degree, it's almost impossible for one person to push a car up like a 1 degree tilt. It's actually crazy how much harder it is pushing a car uphill versus flat land, even if it's just a slight uphill. It's pretty crazy.
I got stuck the other day on my driveway, and my driveway is relatively level.
Yeah.
I got pushing that thing, and I found out it's not quite as level as I thought. It's like, okay, it's rolling.
Yeah.
What the hell?
Yeah.
And then you let go and it rolls back. It's like, shit.
Yeah. Yeah, it's crazy, man. Pushing a car even up the slightest gradient is impossible for one person. It's ridiculous. Those strongman competitions must be done on a very even road where they're like pulling the big wheel trailers. It must be very level what they do that on, or else it'd just be unfair.
And the competitors are tossing like pea or little tiny gravel in front of the tires to see if they can stop the truck.
Oh, that's dirty. I was thinking, I was having a conversation I think 3 days ago with Jesse, and we agreed on a lot of points, but I still wasn't satisfied by the end of the conversation about the main point. We both agreed that if you're already going 100 miles per hour and there's no wind, so like say you're on a frictionless surface with frictionless ball bearings, frictionless car, and you're like standing on the bed of a truck, right? And so no aerodynamics to be involved, just propulsion physics. If you're already going 100 miles per hour and you have some heavy weight in your arms and you're able to throw that weight at 100 miles per hour, we were discussing, well, is it similar to going down a hill that you go down this hill at 30 miles per hour, like on your bicycle, right? And then you start to pedal, but the maximum speed you're able to get to by pedaling is 30 miles per hour. You know that feeling, right? When you're going downhill on a bicycle and you pedal, but it doesn't do anything because you can't pedal faster to accelerate.
Right.
So we were talking about if you're just coasting, right? Just coasting on a frictionless surface and you have a weight and you're already going 100 miles per hour and you have a heavy object in your hands and you have the ability to throw this weight at 100 miles per hour. Does it make you go any faster, or is it similar to pedaling a bike that's already going maximum speed?
Are you throwing it in front of you or behind you?
Well, to speed yourself up, right? And he convinced me.
So throwing behind you, right?
Yeah, throwing behind you to propel yourself. And he convinced me that yes, even though you can only throw it at 100 miles per hour, it will make you travel faster. If you're already going 100 miles per hour, you will go 101 or 102 or whatever. You will speed up.
That's right.
Right.
Yeah.
That goes to my example of rockets, like in space. If you're going 1,000 miles an hour and you only have you're going 20,000 miles per hour, and your exhaust gases are only coming out at 1,000 miles per hour, you still will accelerate. Any force in that opposite direction, or in the direction of travel, will make you accelerate. Whether it be an aerosol can leaking out or you throwing BBs out of the back of the aircraft.
Right. So I was. The conversation didn't reach a conclusion because we were talking about something else, and at least that was established. Like he had me convinced there, and it only seems right that that's set in stone. It's that's good. That's good physics. That's good math. But then I was wondering if you have the ability to throw any sort of weight at 100 miles per hour, and you're trying to get to 100 miles per hour, could you ever get there from scratch, from zero? And so I started thinking about it. I told him I'd get back to him on this. And I was thinking, okay, so if you have, you weigh 200 pounds, well, the highest speed you could ever achieve if you are 200 pounds and the total weight, including the fuel, is 400, the highest speed is only going to be half the ability of half the speed of your propulsion, because if you weigh 100 pounds and you have a 100-pound weight and you throw it at 100 miles per hour, you're only ever going to achieve 50 miles per hour because you're going to have to push that thing, right? If you can throw it at 100 miles per hour, it's going to achieve 50 miles per hour from that sort of center point, and you're going to go 50 in the opposite direction, right? Whatever, like you can throw something at 100 miles per hour, which is going to result if two things of equal weight. It goes away at 50 miles per hour, and you go the opposite direction at 50 miles per hour, right?
I think it varies a little bit because the way that you're doing it with the rocket or throwing things, like you're doing this all with one impulse. Yeah, when you're talking about throwing 100 pounds, one.
Well, just
so
that
it works
I mean,
a little bit different because I've got the same amount of thrust, but I've got much less weight as time progresses.
But was what I said correct? That it just from one impulse, right? Just from one impulse.
Yeah.
If you weigh 100 pounds and you have an object in your hands, a bowling ball of 100 pounds, and you throw it at 100 miles per hour, you will travel 50 miles per hour in one direction, and the bowling ball will travel 50 miles per hour in the other direction. Now, the thing about the rocket, though, is that it has stages, right? And so if the thing that's set into motion, you're actually the left side, like it's crazy to put into like human terms with bowling balls, but it was actually like there's no good way to say it, but I'm just saying that was half the weight. Half the weight goes right, half the weight goes left, right? But now if the weight on the left could divide in half once again with 100 miles per hour throw, right? And like your torso could detach from your hips, right? Your torso could throw your hips or your legs and below, right? You split in half again. Well, then you would go now you would reach 100 miles per hour because you could do the same thing a second time. And so it's all about like dividing yourself from what's already been thrown away. And I imagine that's why rockets come in stages, because it's just more efficient that way.
Right, you get to get rid of a lot of weight, just throw it away. It's no longer necessary, and you're not going to refuel it or anything, so you can just discard it and keep going.
So like there's three factors involved in like rocket propulsion. There's like the weight of the fuel that's being thrown compared to the weight of the object that's going to like be on the opposite side of the throw. And then there's ultimately the final mass that you're trying to get up to speed, because it can come in stages. And so the maximum velocity achievable is in relationship to whatever fraction of the total weight in the first place is. Like if you're just trying to get the tip of something,
log of the ratio. You need the exhaust velocity times the natural log of the mass ratio, and that's your delta V.
Unfortunately, the fuel needs like a capsule that's going to be detached, so that goes to its detriment. But probably not by too much. This is not a big deal. Like you expend all the gas out of container, and you have to throw that container away as well, and it's not as useful as the fuel was, but that's probably minimal. I mean, the fuel obviously weighs more than the fuel container, right? And that's just.
I think that's true.
So it's 90, so the fuel container
90,
kind of net.
If I'm not mistaken, 96% of the rocket, something on that order, 90 to 96% of the rocket is fuel.
I think that's true. I think the best payload fraction is less than 5%.
So then the other factor is how fast the molecules are being expelled. And if you're saying 96% of the total weight is the fuel, and then you multiply or whatever to figure out this equation. Like I was saying earlier, I want to do some math with this, but the factor I couldn't find from Google is how fast is the fuel being at what speed is the molecules leaving the ass end of the rocket? Because that's the third factor in the equation. There's
it's the like 4 kilometers a second.
What's that?
It's like 4 kilometers a second for LOX hydrogen.
That just doesn't seem enough to get to, let's say, 25,000
It's
miles per
not. You
hour.
need at least 7, I think, to reach orbit.
No, we're talking about the exhaust velocity, not speed of the rocket. That's different.
The exhaust velocity, any propulsion that you give will give you acceleration. Whether your exhaust is coming out at 1 mile per hour or at 4,000 meters or 40, what do you say, 40 kilometers per second, 4 kilometers per second.
Well, here's a good question.
4 thrust per second, but it still is the same amount of energy added to the equation.
Yeah, I understand it can like be cumulative, but I think I'm on the right page. Like, and I haven't done the math yet, but I want to. But you understand how a key factor of it is like over what amount of time, how much does the fuel weigh compared to the thing that's trying to get up to speed, and how fast is the fuel being expelled? Those would be like the three factors involved in determining like the top speed or like something is able to reach, right? And yeah, I mean, it just doesn't seem like it seems like that you'd need the molecules to leave the rocket nozzle at some sort of large speed to get to these ridiculous speeds of like 25,000 miles per hour, right? Or a good question, I'll look this up if none of you know, but like what's the fastest space traveling object? Like what's the top speed humans have been able to put something in to travel in reference to the Earth?
With or without gravity assists?
Josh, that's a good question.
I'd say without. Like, how fast can we make a rocket go in any direction we want?
New Horizons had a solid rocket motor, and it reached the fastest speed of any satellite.
What was the name of that?
New Horizons.
New Horizons. And what kind of trajectory is that going on? Is it just like a probe going out into deep space?
Yeah, that's the one that flew past Pluto.
Oh, okay, yeah. Okay, so you think that's the fastest man-made object?
Yes.
No. Well,
okay.
there's gravity assist ones.
Yeah, gravity assist would be the Parker Solar Probe because it fell real close to the sun.
Are you talking about some sort of like slingshot effect?
Yes.
Well, yeah, just falling towards the sun sped it up.
Oh, okay, but then once it gets shot out the other side, it slows down because it's still being tugged upon as it's like leaving.
Yeah.
Okay. Okay. So yeah, good question, because I would consider that like an unfair. That's not necessarily like man-made and like man-propelled, I guess is how I would strictly define it.
That's right. It's robbing energy from the sun to speed it up.
Okay. So yeah, I'll check out the New Horizons one and try to do the math with that.
Yeah, I got a link for you.
Now they have these other things, these ion drives and stuff like that. Those are examples of just sending out tiny amounts of mass really fast. They have no thrust at all. Right? They get the thrust of a couple pieces of paper. Sitting on your hand on Earth. That's the kind of thrust you're talking about. But given that they can do that for days on end or months on end, allows them to reach theoretically outrageous speeds.
Do you guys buy into the whole like sort of solar sail sort of technology?
Yeah. I think conceptually it works. I don't know whether anybody's going to be able to use it usefully.
Does that involve little explosions happening, or is it literally just pushing things with light because of the momentum of a photon?
And
this
particles.
Guy is not a flat earther.
Yeah, and particles. I mean, there's more than just photons hitting in the solar wind.
I mean the the light like humans would put something out into space in orbit, and then they would push it out of orbit with like a laser or something like that.
Oh, that. Yeah. Okay. Yeah, I've seen those. Those would be almost strictly photons. And I don't know how that works. There was and I've seen that in two different flavors. You're right. There's one that actually is like little explosions where they're actually burning a media with the laser, and then there's just using the light pressure, I guess, for lack of a better term. And I think that only works once you're in space.
I can hardly imagine, a flashlight pushing something. It seems pretty ridiculous for shining a light on something to actually push it, because we considered a photon a massless particle. How does it have any physical momentum to impart on this object? Like, how can light push something?
That's for somebody else to answer. That's for somebody else to answer. I don't know what the.
It's weird,
the word that they. I forget the word that they use for what the type of mass a photon has is.
There's rest mass, and then there's
just momentum.
Non-rest mass.
So the answer to your question of the fastest traveling human object, I was researching that just the other day. It's the Voyager 1, they claim, and the speed reached is 95,000 miles an hour. That also happens to be the speed you need if you want to leave solar orbit, according to the fantasy model. So maybe that'll help you.
What about to the real physics?
Thank you.
You're welcome.
But that one went against what we were talking about, which was propulsion without any other kind of assist.
Oh, did that use a gravitational slingshot?
Several.
Sure did. Lots of
Whichever way you get it to go that speed, it has to go that speed according to the fantasy model to leave solar orbit.
Cool.
To go into vast space.
At what altitude is that speed specified at, though? Because that matters.
What do you mean that? What do you mean at what altitude?
Here, if you're close to the sun, the speed needed at that proximity to the sun is different than if you're far away from the sun. So you have to specify escape velocity at a certain distance from the sun.
Right.
Well, we're talking related to the Earth. If you're on Earth, according to the fantasy, and you want to escape the Earth's gravitational pull, it's 25,000. If you want to escape
leave the
solar
system,
gravitational
so you're talking about solar
let me
orbit.
finish. Don't interrupt me. It's rude. If you want to escape the solar escape velocity according to your fantasy model, it's 95,000 miles an hour.
Right, but if you were on Pluto, it wouldn't need to be that high.
Yeah.
I'm not talking about Pluto. I'm talking about.
You understand though that that's what he's saying.
Yes, I understand exactly what he's saying. Do you understand what I'm saying?
No, because you haven't completed your thought. At what altitude does that specify?
Listen, dude, according to NASA, we know your game. According to NASA, I'm going to say it one more time. According to NASA, in order to leave the solar...
Let me read it.
This is what he does. He's going to do it. It's not going to work, bro. It's not going to work what you're trying to do.
What's not going to work?
What you're trying to do right now.
What am I trying to do? Trying to get you to state a fact or link your source?
No, you're playing games. That's what you do.
You linking your source? You not linking your source.
No, you didn't ask me once to link a source.
I sure did.
Not
you
once.
just kept talking.
No, you didn't. No, you didn't.
Yep.
No, I said according to now. I'll link it right now. You ready?
Link it, please.
Thank you.
You ready?
Don't just recite it. I want to read it myself. Make sure you have the source and not just an excerpt.
Listen, dude, you don't get to tell me what to do. I'm gonna post something for you. Okay. You can take it or you can leave it. Okay.
Okay. Well, if it's not the source,
and you know something, I might not even do it for you.
Okay.
Might just not even do it.
You might not even have anything to back up what you're saying. That's fine.
So just understand, your games don't play here. Read what I just posted. This is NASA. Okay. Read it.
Let's see here. First, to escape solar orbit, velocity equals 95. So where does this specify escape velocity on this graphic? I don't see it specified.
95,000 miles an hour in order to reach. Read what it says there. This is the fastest traveling thing now in order to leave. Now, and if you don't understand that, just do the research on your own. I don't care what you think, and I don't care what you say, bro. I just stated a fact from NASA. Now you either like it or you don't.
NASA didn't say this, the image doesn't say this.
Yeah, I don't know how you would. I don't know how you would. God damn it! I don't know how you would quantify that 95,000 miles an hour unless you give a reference. Because, like, how fast is it traveling right now? Well, the Earth has moved. So, in relationship to where the Earth is now,
call NASA tomorrow and tell them how did you achieve that? This is from your fantasy.
No, where are they measuring it from? I'm guessing that they measure it from
Ask NASA. Ask NASA. You don't have to like
It'd be
this.
nice,
You don't
since
have
you
to
like to
like
bring
it.
it up.
You just have to accept it. You know why? Because it's coming from NASA.
Right, but you bring it up, but you don't know what NASA said. All you know is this little graphic here, which doesn't tell you much.
No, I'm
It's
showing you a
cool.
graphic. I watched the whole video on this, a whole lecture from a NASA guy.
So you don't
That's
remember
what I
what they
did.
said?
That's what
You
I
don't
did
remember
to
what they
learn this. Yeah.
So you don't
that's
remember?
exact-
Yeah, but you learned it, but you didn't learn it. What is that reference to? That 95,000 miles an hour?
I said it 3 times. I'm not going to say it again. If you didn't
so
understand it, that's on you. That's your
you've
problem.
seen it. You've seen the whole video. You know all about it, and you're not going to tell us, or you don't remember.
I'm not going to tell you. Yeah, that's right.
You don't. Okay, so you don't remember, or you don't.
I told you 3 times.
Obstructionist.
3 times. I'm going to say it one more time. According to NASA, a spacecraft to leave the gravitational well of the sun has to be traveling, sweetheart, at 95,000 miles an hour. Now, you don't have to accept that or like that. That's your model. I'm educating you on your model right now.
But what distance from the sun does that velocity apply to?
He does. He's
If
not
you
going to
wish
answer.
to find out more
I don't want to hear him
information,
again.
look it up.
Okay, so you don't know.
Yeah.
That's fine.
Yeah, he
Just
doesn't
say I don't
know, and
know.
he doesn't. That's the problem. Is he won't say he doesn't know.
No. I'm just showing everybody what you guys do. I just educated you. You asked
No, you
a
didn't
certain
educate
person
us.
asked for escape velocity. I gave it, and you guys are just trying to play games.
Well, escape
That's what you're
velocity
doing.
is as stated. Escape velocity, as
You
stated
asked me to
before.
post something, and I
Escape
posted for
velocity.
you.
Escape velocity, as stated before, has to do with where you're starting from. Like I said, if you were out
And
of
I
Pluto,
told you 5 times
I
from
said,
Earth. I
said
very triggered, guys.
like I said
All of you
5
guys
times, and
are
you're
very,
talking
very
over
triggered.
me. Is talking over me the way that we're supposed to work things around here?
No, go ahead.
Oh, good.
Ask me the same question
Good.
for the
I'm
6th
so
time.
glad that. No, I'm now speaking about something, and it's not necessarily have to do with what you're saying. So shut up.
Stay right here.
You're hot, Mike,
Jeremy.
That was Jeremy, by the way. You told to shut up, just for the record.
No, yes, I did, and
it's so beautiful to see how triggered you guys get when I
when you
repeat
talk
the
over them?
fantasy from your space agency. I
When
just
you talk
love it.
like
Go ahead.
boo-boo.
Ask me the 6th time.
when you talk over me, and you talk like boo boo, and you're talking long-winded statements to say the same thing over and over and over again, it's annoying. And yes, I do get triggered by that. I would like to try and have a conversation.
There's the trigger
and
right there.
At this point, necessarily, yes, triggering is rude behavior. For me, if you're rude to me, it's very triggering. Yes.
I wasn't
so
rude. I was very calm, very collective. I showed you. You asked me to show you. I showed you a thing of it, and you guys are very triggered. Every time I say something, you want to see more proof. You want to see more proof. Just Google escape velocity of the sun from NASA, and you will see your own agency will agree with me.
I don't disagree with that.
And do it.
Moya,
I dare you.
Actually looked it up, and he's half right here, only by accident. But what he doesn't know is that escape velocity. Don't interrupt me. That escape velocity applies to the Earth's orbit, 93 million miles. That's the answer to the question.
Okay.
You see that? I'm half right by accident. That's what these guys do. That's all they do. They know nothing. They have nothing.
Don't be triggered.
Come on. Why are you triggered, bro? You got to admit I was right. But you couldn't even say that. You have to say I was half right by accident. That's what you guys do, man. And I love exposing you on a daily basis, bro. I love it.
How could you be right when you never answer my question about what distance from the sun that applies to?
That's all you do, bro. That's all you do. You're just a person that has nothing, that knows nothing, that talks about nothing, and I had to educate you what the escape velocity of the sun is.
Which one of us?
And still, after you looked it up, you're still on it. That's what you guys do. You're pathetic, miserable human beings that have nothing. That's all you do.
Gio, is that
let's not get crazy.
I apologize for that. I apologize for that.
Okay.
Yeah, you got to just keep on talking.
Tell me, Gambino, where did I go wrong? Tell me, educate us. Everybody's waiting to hear you.
The little toxic little statements that you have to
go
keep
ahead,
on saying
Moya,
on top of everybody.
Explain to us this
I think you can shut up.
Okay, guys.
That's so funny. I'm rude. I'm so rude. That's so funny.
Gentlemen, please.
I love it, man. I love it.
SE, stop. You're taunting the shit out of him. Just stop. Let Moyak say his piece, please.
No, mute SE. Fuck this. Goodbye.
Yeah, didn't I get muted yesterday for like what Geo thought was an ad hom? I mean, how is that not happening right now with SE? I mean, I was just asking him for a simple number, and he goes on to call me stupid, saying I know nothing, and he has to educate me, and blah blah blah.
Yeah, don't.
It's not gonna work,
insult.
Gambino.
Please.
It's not gonna
You
work,
heard
bro.
me say
Everybody
something.
knows you.
Okay, knows me? No, I mean, you call me stupid, so obviously you don't know me.
Call me stupid back if you.
No, don't do that.
You're
No, we don't
ignorant.
want that. Nobody call names, please. Unless you have like a good rapport with someone and it's like a joking thing, it's like, haha, then all right, maybe. But don't like, if you ain't cool with heads like that, don't be calling them names and shit or whatever. Please, guys.
That's right. Suck it, SE.
You see that? No, you're gonna suck it, bro. Because 95,000 miles an hour is the number now. Whether you like it or not, Gambino, it's not gonna change, bro. You can squirm for me all
I
night
like that number.
long.
But it just applies to Earth's orbit. Doesn't apply to
Yeah,
something
that's
else.
exactly what I told you. From Earth, I told you that 100 times, and you have nothing. You just try to play your game. Keep it up, bro.
So what's
It's
the problem
not
with
gonna
95?
work.
What's wrong with 95,000 miles an hour?
It's not gonna work, bro.
Answer the question.
I posted a thing from NASA. There's nothing for you to ask me. That's your model. You're gonna have to live with it. Anything else you say is null and void.
This is accurate. Now what?
Absolutely. Exactly. Now what?
Now what? So what's the purpose of posting this?
Now what, Gambino? Now, why'd you come in into the conversation?
You came into this conversation. I was talking.
No,
to
you
Moyak
came
and the
in.
other
I
guy.
said NASA's escape velocity is 95,000 miles an hour. When the gentleman asked me, and you and Moya got triggered and came in, what do you think you achieved?
Getting you to
the number
actually post
didn't change.
something
It's still
and showing that you don't know what it
95,000 miles
applies
an
to.
hour. You achieved nothing, Gambino.
So why are you posting this at all?
Because somebody asked me, and you guys asked me to post it. That's why.
Okay, yeah, but you brought it up when that wasn't the topic, because we were
No,
talking about
you
the
brought
fastest
it up.
object.
No, you brought it up,
No.
and you're still gonna try to do what you're gonna do, and you're not gonna succeed, bro. I can
Stop
do this
talking.
all
Stop
night.
interrupting. We were
Stop
talking about the
interrupting
fastest.
me.
We were talking about the fastest object. So what
Yeah,
does this
and
have to do with
I told them what it was, and I posted. You asked me to post the picture, and I posted for you. According to NASA, according to your agency, that's the fastest object. Nothing you say or do will change that, Gambino.
No, it's a Parker Solar Probe.
No, it's the
You're
one I
wrong.
just posted right there,
Nope.
according to
You got it.
NASA. Right
It's not
there.
recent. It's not recent.
You're wrong.
You're out of date. You're wrong.
You're wrong. You're out of date. You're wrong.
No. Sorry. Voyager was in the 70s. Parker Solar Probe was in the last few years. So you just looked up an old source. You're 100% wrong.
So this is according to NASA. You're disagreeing with NASA?
I don't see the source.
We'll do this all night, bro. Your games ain't gonna work.
Okay.
Why you
he's
interrupt
saying
me
your
after you ask me
citation's old.
something?
Hold on. He's saying your citation's old. Who's got the newest, most up-to-date
Bring me
NASA
the newest
bullshit
citation. Show me a date, Gambino. Let's go.
Okay, sure. You go find it for your side, and I'll go find it for mine.
No, I already posted something from my side. Now, if you're saying that's
You
wrong,
didn't
show me
post
the
the
proof
source.
and I'll stand corrected. Very simple.
Where does it say fastest object? Show me where that says that.
Cite it out.
It doesn't. Oh, you're quiet now. What happened?
Hold on. It says first
for him.
escape solar orbit 95,000 miles an hour. Okay, maybe there is a faster one. Go ahead, show it.
Oh, snap. So
But we
you're
weren't
wrong?
talking about the fastest. We were talking
we were.
about what it takes to reach escape velocity of the sun. That's what we were talking about, if I'm not mistaken.
That's not what Fundy asked. Sorry, but that's fine. We can talk about
Okay,
this.
if you can find a faster one, I'll stand corrected. I mean, I got no ego. I don't play games like you guys do.
I got no ego. That's the funniest thing I've ever heard you say.
Yeah, Gambino, your games don't work, bro. We know what you do. We know what you do. You just come in to cause trouble.
It was a lot faster than your submission. I mean, it was welcome because it was like 3 times faster than your submission, which is cool.
Yeah, they just can't. Anything I say, bro, they're gonna go against. That's the way it works. If I say it, they're just gonna have to go against it, no matter what. And he's searching now. He just assumed. He just assumed this. Just because I said it, it's wrong.
But you are wrong because I happen to know this stuff.
You see, yeah. So
Solar
okay,
Probe is
post
faster.
it. Post what you said. Show us.
You're too slow. Look in the chat, you dumbass. Jesus, how slow are you?
And not cool, man. Not cool, man.
Yeah,
How fast
please
is it?
don't
What
call
does it
names.
say?
dude.
He called me dumb. I
Don't
call him
call
dumb
me.
back. If he can't dish it out, if he can dish
Okay,
it
so
out.
are
why
you
we don't want name
disputing that
calling.
it has
We're
to
not
reach
here for
95,000
name
miles an hour
calling.
in order
Shit.
to reach the solar, in order to escape solar orbit? Like I said, are you disputing that fact? That was the original claim.
If it's 93 million miles from the sun when it has that speed, yes, then that's accurate. But you didn't include that
Okay,
part.
there you go. Thank you.
Yeah, I had to look
You
that one
stand
up because you
corrected.
didn't know it.
You stand
No,
corrected.
I didn't. I never claimed otherwise. I asked you to
Sure you
clarify, and
did.
you couldn't
You were
because you didn't know.
disputing the escape velocity that I said that NASA said.
No, I didn't.
So you're
Just asked for
saying
the
the same
source.
exact thing. You're just disputing a speed of a probe now, right? That's all you're doing.
The Parker Solar Probe is faster than Voyager, and you didn't know that, and you're wrong.
Okay,
so suck
fine.
it.
Okay, fine. No problem. But I was right about the escape velocity that you need to escape the solar orbit, right? That's the original thing we were talking about, correct?
Well, you didn't specify the altitude, so
Yeah, right. So what you think you got here now, Gambino? What do you think you achieved?
I proved you wrong.
Wow. That was a great feat.
Oh,
You
wrecked,
proved me wrong
wrecked.
about what? About what?
Wrecked.
What did you prove me wrong
It doesn't
about?
matter. It doesn't matter. You got wrecked.
As long you see, this is what they do, bro. They have one mission and one mission only, right? They don't
Prove
want
you
to talk
wrong?
about facts. They don't want to talk about what we were talking about. They only have one mission. They stay behind like little rats and they wait. Maybe you said something that's off by a little bit or a little thing like that. That's what these guys do.
Do you come in here just to
That's
whine? Is
Gambino's
that all you
only
do?
purpose in life. He's not here to learn. He's not here to add to the conversation. He just wants to prove me wrong or Witsit wrong or New Perspective wrong or somebody wrong. That's their game.
You come in here just to whine and then say that you don't want to talk. That's great.
Bro, that's all you do.
Okay, so
What
anyway,
constructive
Fundy.
did you add to the conversation tonight? What do you think you added constructively?
Fundy, here's the answer. The fastest spacecraft is Parker Solar Probe.
So it's not the Voyager?
No, it's not Voyager anymore. It used to be, probably.
Congratulations,
Parker?
bro. Congratulations.
Be quiet, SE.
Said Parker?
Yeah, the Parker Solar Probe.
And Solar Probe. But that's utilizing the sun's attraction, is it not?
Yeah, it is.
Yeah, you and I had an understanding that we weren't gonna allow like acceleration towards a body, right?
Yeah, did you miss that part? Did you miss that part, bro? Oh boy, seems that you were wrong, huh? Wow.
Okay,
Sit down and be
talking
quiet.
about
Let
just
me
straight
talk.
up rocket propulsion, then it's the New Horizons.
Yeah, you were wrong,
That
bro.
didn't have
How
any
does it feel
gravity
to be
assist.
wrong? You were wrong.
All right, yeah. Then that's what I'm looking for. Then New Horizons. That one's the one. Say, heading away from the sun.
Yeah, straight out the solar system.
Yeah.
Don't ask him much because he doesn't really know that much.
Because I'm looking for like feats of accomplishment of like propulsion, right?
Here.
Yeah, that would be the
I linked it
Voyager.
earlier.
That would be the
and
Voyager.
I'm gonna tag you this time.
Was it New Horizons or Voyager that's faster?
New Horizons.
And do you really think it's like its speed is due to just propulsion alone?
Yes, that quoted speed is after the third stage burned out. Yep. It was a
But are
solid
either
rocket
of them
building.
real, or are we talking Hollywood studio?
Oh, we're talking NASA stuff, so like real. I'm not talking about any movies.
New Horizon. Wow. Okay, so this thing it has stages, right? And it's got rocket fuel propulsion systems.
Yeah, this was launched on Atlas V with the Star 48 solid rocket third stage.
And
he just read that, by the way. He just read that.
Sure, but I mean, I'll definitely look into this because I have some math to do for myself. But just off the top of your head, do you know the speed it's going? Top speed?
Right now, or when it was?
Well, just it's top. Just its top speed, just like its maximum velocity.
36,000 miles per hour.
He just looked it up.
It's not as fast as I thought it'd be going, but okay, yeah, cool. That's good info.
That's the highest launch velocity for any any artificial object, but it gets faster when it does gravity assists.
What's
tell
a
them how
launch
fast it has
velocity?
to go to escape the orbit of the sun again, Gambino. Because you said it's traveling at 36,000 miles. Tell them how fast it has to go to escape the sun orbit.
At the orbit of the Earth, it would be about 94,000 miles an hour.
Thank you very much.
What?
Yep.
The Earth?
Yep.
Yeah.
Wait, what?
From the sun. Yeah.
The
Why do you ask that?
probe has to be traveling. This is not what he's telling you. The probe has to be traveling 95,000 miles an hour in order to escape the gravitational tug of the solar system in their fantasy model.
Right. So what?
Holy cow!
So what's your point?
Yes, sir. That's exactly the point.
What's the point?
Well, like,
sit down, Gambino. Sit down.
Like fuel expenditure and propulsion, like has to like achieve that. That just
yes.
I mean, that's really
gravity
something.
Assists. Gravity assists around Jupiter.
No, I was looking for the fastest thing just by propulsion alone.
That's New Horizons, 36,000 miles an hour.
Okay, 36 propulsion alone.
That's right. That alone isn't enough to
now
escape
how does
the solar
that reach?
system.
Now the magic is they're going to tell you the slingshot things they do to reach the escape velocity, which is 95,000 miles an hour.
At the orbit of Jupiter, it's not that high, but yeah, it gets a lot more velocity from the orbit of Jupiter.
Could you explain that slingshot? Because you know how like the perpetual motion devices people try to scam us with on YouTube, like the magnet pulls, but then it neglects the magnet's tug once it crosses over, right? Like any amount of magnet would speed up like a spinning wheel, right, with like a magnetic ball bearing on the edge of it, right? Like it would speed it up, sure, but as it passes by the magnet, well, it would be slowed down to the same degree, like a ball being thrown up in the air and then falling back down on the ground.
Bro. Don't think magnets. Think plates. Think soup bowl plates. That's how they think space-time curves. It's a fantastical story.
How does the slingshot effect speed something up but not slow it down to the same degree?
That's an excellent
afterwards.
question. I had the same confusion myself. So imagine that the situation you just described. Imagine if the magnet is moving perpendicular to the path of the incoming ball bearing. Well, then it would impart some of that velocity into the new direction of the ball bearing.
No. It's not a magnet. Nice try. No.
Be quiet. Don't interrupt me. I'm talking to this guy. Stop interrupting me. So it robs a little bit of the energy from the movement of the magnet. So technically, Jupiter slowed down a tiny bit as New Horizons passed it and gained some velocity.
He has no clue what he's talking about. If he's using magnetism, he has absolutely zero clue what he's. Don't listen to him, bro.
You're funny.
I kind of get it that you're saying that Jupiter was also moved by the satellite or the probe or whatever, and so there's an even trade in a sense.
It's like a collision.
What? No. Don't be understanding anything this guy says, bro, and put it in your head as fact. You'll be.
Hey, I understand where you're coming from. I understand where you're coming from, SC. Don't worry, I'm not like fully convinced or anything, and I have lots more questions and skepticisms about all of this. But I do want to just like fully lay out any of the ideas that are understood by this guy, just to see how far he can take it, so that I can come up with questions that really address the limits of the envelope that he's pushing.
I hear you are just trying to warn you. He's using magnetism, which has nothing to do with their fantasy.
It's an analogous small-scale demo. I mean, he brought it up. He brought up the magnetism, and I was just explaining if the magnet's actually moving, then you have to account for that, and that's the same physical effect that you have to account for when you have gravitational collisions.
So besides the robbing of Jupiter's inertia, like how does something enter an attractive field and accelerate when it enters, but then exit it without experiencing equal loss to what's gained?
It does gain no net velocity in that axis, in that axis of its velocity, but it can gain velocity in a perpendicular axis, and that's what it does. Yeah.
Explain that.
So if you have a ball bearing flying past a magnet and the magnet's stationary, the ball bearing will speed up and then slow down as it passes. But if the magnet is moving, then the component of the vector of its speed in the direction of travel will remain unchanged, but it will be added a component in the perpendicular direction, the direction that the magnet's moving.
Okay, now take away the magnets and replace that with a fish bowl and a ball bearing, and try to explain the same thing. Go.
I wouldn't, because that makes no sense, and it has
Exactly.
absolutely
Thank
no
you very much. You heard it. He said it himself. He said it.
Yeah.
I made him say it himself. It
Say
makes
what?
no sense. Thank you. That's all I need from you. Thank you.
Your idea makes no sense, but the magnet and gravity makes perfect sense. And vectors, which you don't understand orthogonal vectors, I guess. Maybe.
No. We were talking about you replacing your magical magnets, which it's not, it's a depression of space-time, and I asked you to use it using a fish, like a soup bowl, and a ball bearing, and you said it's ridiculous, it doesn't work. Exactly. Thank you very much, Gambino.
Gravity that way.
Thank you.
No one explains gravity that way, the way you simplified it, so I can't use your overly simplified, non-analogous idea. I'm sorry.
No, it's not an overly simplified, non-analogous. It's how you guys explain your depression. You use a trampoline using a bowling ball with your fantasy, and you said it doesn't work. I made you say it. Thank you. I'm done with you.
Okay, bye-bye.
It is kind of funny that, like, I've always heard this expression, like, it's not rocket science, you know. You all know the expression.
Yeah, exactly.
And
that's funny, because rocket science isn't even like the pinnacle of intelligence anymore. It probably was back in the 50s and 60s when it first came into existence, but there's actually a lot of people that can do it now.
A lot of science going on in bottle rockets. Hey, listen, what is it that still convinces people we're living on a spinning ball in an impossible medium covered in waters? Who really still believes it? Because I know people come here and defend it. Y'all aren't stupid enough to still believe that.
Gambino does.
Enough to think it's flat.
Ask Gambino.
No, I know he does. Well, he acts like it. And Gambino, you do a great job, by the way, acting like you still believe this shit. But listen, you're smart enough to know better.
You're smart enough
it
to
works
know
just fine. It works just fine.
Is that the entirety of your argument?
Round and round we go. They'll never give it up. Never give up the ghost, kids.
I can say the same about you, even though we have like reality that proves you're wrong.
do you think the solar system was like intelligently designed?
No.
No, you think it's sort of like random happenstance the way it worked out?
Everything we can observe about it shows it following ordinary laws of physics without any intervention.
Yeah, and laws of physics just exist in a sort of like random happenstance overall scenario, right?
Yeah. Now we're talking about metaphysical things. I don't know why laws of physics exist the way they do. That's
no. I'm not asking this. I'm just saying the guiding forces are just physics and chemistry, right? Nothing really going on apart from that. Just like you got a room full of stuff, and it's gonna move according to physics and interact according to chemistry, right?
Yes, as far as we can tell, every single observation follows laws of physics.
Right. So like, and without any sort of, I don't want to prescribe like intention to raw matter. So we would just say like, you would propose that, it all kind of just happens, like I said, it's just happenstance. There's a set of rules, and there's things that will follow those rules, and the result of what we have now is just random happenstance of things with a set of rules to follow in motion.
Yeah, I guess so. That's as far as we can tell. That's what's happening.
You ever just look around though?
Yeah.
You ever just look around and you say, "This is random happenstance"?
Well, I guess it depends.
Bro, he's not here for conversation, bro.
Hey, Essie, was the question to me or to you?
It is kind of mind-blowing, but it is what it is.
This is more about theism.
Yeah, that's called
nothing to do with that, man. I haven't taken it that direction. You are, but I haven't.
You're saying
Yo,
doesn't this look like a creation?
No, I don't even believe in creation. Let's just stay where we're at, like, let's not jump the gun here. I was only asking a certain question. He said, wow, that's an interesting way to look at it. I'm happy that he even said that alone. Like, I guess you could put it that way. That's very interesting. I feel pretty satisfied with even just that response. And left lane too, saying, yeah, it's freaking mind blowing, dude. It sure is.
It's mind blowing, but yet they won't admit the slightest thing. They'll fight it to the end.
I mean, really, guys, when we all look around, it's like, this is how it is. And someone said, it is what it is. And you're right. It is what it is. But what it is what it is. And that's according to all logic, like an absolutely true statement. There is no argument against that. It is what it is. But what is it? I would say it's a goddamn miracle what it is.
If what it is what they say it is. Yeah.
Well, a miracle from God.
Well, I never said that.
I would say that.
Well, sure. I can totally understand where you're coming from. I mean, yeah, it's totally appropriate. I see why someone would feel that way. Like, wow. Like, I'm impressed. Color me impressed. Like, look at all this shit. Look at all this shit, guys. Like, wow. Like, fucking wow. Accident? I mean, it isn't even appropriate, right? Like, even atheists don't even feel it's appropriate to describe the machinations of the universal mechanics. We don't even like to call it an accident because that ascribes like consciousness behind it, right? To personify it in those ways, like accident or intentional, words like these, right? Accidental or intentional, like that's involving a human or conscious element to it. And somehow the universe seems to be outside of those qualities of being either accidental or intentional. It's something in and of itself, almost all people would say. And that might lead you to say, well, it's it has a higher intention or a higher accident sort of level to it. But I don't know. I mean, that's beyond us, I'd really say. But I can't help but be impressed by the order of it all, balanced with the chaos of it all. It's a beautiful marriage. It's what the hermits would call it, like a coincidentia positorum, and it's really beyond. I would say it's beyond explanation as far as any of us can achieve. And I wouldn't really encourage anyone to make their mind up on it at all. Even till the day you die, I would encourage no one to really make their mind up in totality about what this place is or why it's here. Yeah, I'd say it's the eternal mystery that it's just fun to talk about, really.
I'm sure, brother, once you stop talking, Gambino's going to set you straight and explain to you exactly how this all came to be.
Oh, it's just just multiverse valleys and troughs of energetic flow collapsing into a universal paradigm. There's got to be somewhere for the energy to interact and expand, and the multiverse creates pocket universes, and it's all just meaningless flows of pressure mediation and chemical reactions that ultimately result in nothing for no reason, nowhere really. Where are any of us gonna go in this conversation? We're just gonna have a little chit chat about the mystery of it all. It is mind blowing, and I think it's a little bit beyond us to get to the bottom of it all. But if anyone thinks they got it all figured out, I mean, that's sick. Lay it on me. Like, hell yeah.
It makes absolute perfect sense. That's my whole point now. These guys will tell you the opposite. How dumb you are, how you don't understand the Big Bang, how you don't understand evolution, how you don't understand this or that, how you don't understand escape velocity, That's all they do, bro. They have no answer. Instead of being humble and saying, you know what? I don't know, man. They won't do it. Of course, they won't do it now because I said it, but that's what they usually do.
I would say that there's certain like patterns that seem to be like consistent everywhere you look, and that's why math is such a powerful tool, and that's why I can't blame any of the ancients for considering, like Pythagoras says, all is number. And it's like, well, I think that's a little bit like too simplistic, but I see where he's coming from. Because if the universe was a simulation, everything would be defined by numerical code in like an artificial computerized simulation, right? Like, someone in the Sims game, they could say all is a number, and they'd be correct in a sense, right? Because it'd all just be a bunch of binary code or computer code or whatever. But I do think that our version of reality is one step above being just binary code. Even though it's similar to what we can create in these simulations, I don't think it's a simulation to the same degree. I don't think we're in a matrix, but something similar to it. I don't know. God's imagination. Who knows? All I can do is fantasize, really. But what the fuck is this place, guys? Computer simulation? I think not.
And that's the imaginations of an honest man, the way you just talked right now, right? At the end, you said, what the hell? I don't know, right? Yeah, exactly, man. Exactly.
There's one Hermetic expression that says, no water can ever reach higher than its source. So like nothing's ever going to make nothing is ever going to create something like greater than itself. So if we ever could invent like a pocket universe, right, it would never be as fully developed of a universe as the one we're in. We can only make a shadow of a imitation of what we're currently in. The same as like we're conscious living beings. I don't think we could ever make like a more conscious being than ourselves. Just some sort of lesser version. Well, to an overall degree, I guess. I don't know. It's crazy because computers sure can think faster than us and tackle different problems more efficiently than us. But there's still a loss to it all in some areas.
You see, even Gambino had to admit at the end that the model that they subscribe to makes no sense. Double, like you live in a fishbowl, not a fishbowl, a soup bowl, and I'm in one soup bowl, and the moon is in another soup bowl, and the sun is in another soup bowl. I mean, even they have to say at the end, look, this is ridiculous.
I see Montreal. Would you agree that you can see further from higher?
I guess so, yeah.
Well, you can't do that on a flat Earth.
That doesn't make any sense, man. Of course you could.
Why not?
Done. You got pwned. It's over.
Are you trolling?
No, that's it. That's it. Why would you be able to see further on a flat Earth from higher?
Oh, you know the answer to that. Don't play us, man.
I know why on a ball.
You should know as well on a flat plane.
Tell me why.
You're trolling, man.
It would just be, imagine looking. Use your chessboard analogy. All you would see is a silhouette on a horizon. You'd see like a tree on the horizon, like silhouetted. So if you got higher, it wouldn't matter.
So, okay.
Mm-hmm.
So, if there was like a mile long pane of glass, you know what I'm saying? Like a rectangular prism of glass, right?
Yeah, I'm following.
If you were looking through a mile long rectangular prism of glass, do you think looking straight through it, you'd be able to see out the other side?
No, it'd be all diffracted and.
Okay, so then do you think if you elevated your sight above that plane of glass and looked in the same direction, you'd be able to see further than looking through the plane of glass and actually resolve some images? Looking at, say, a 45-degree angle, you know.
It obviously depends on how blurry it gets, right?
Have you ever seen any examples of underwater photography? The horizon's about 30 feet in front of the camera.
Sure.
Right. So surface level observations looking out into the distance are analogous to being underwater compared to a higher altitude. So yeah, the thicker the medium, the less fur you're going to be able to see. And that's not even mentioning another factor at play, but just that one factor alone would demonstrate that you'll see further in a less dense medium. Higher you are, less dense medium, right?
Yeah, but
is the air thinner at the top of a mountain?
Mm.
Yeah, so that's one factor at play. That's not the only factor at play. There's also like angle of attack of sight to add on to that. But I mean, you know this. I mean, you're just messing around. Of course, you'd see further on a flat Earth the higher you get. So you're just messing around. It's okay. You're forgiven.
I'm not messing around.
Of course, you're messing around. You can demonstrate this on a freaking long flat floor in a warehouse. You know this, man. You don't need to mess around with us, man. This has been gone over plenty of times. You've been around long enough. That's a nonsense question you asked.
Well, I mean, there's one observation that I do a lot as I'm driving across the desert every week, that I see mountains that just show me their peak at like 80 miles away. And I know they're probably 6,000 or 7,000 feet higher than my elevation. And as I get closer, they grow out of the horizon. And I don't think that would be what I would see on a flat Earth.
Are they ever tilted? Lane, are they
a little
ever
bit
tilted?
Yeah, good question. Not noticeably, I'd imagine. Even on a globe, I don't think you'd notice any sort of like observation of them seeming to be tilted away, or like pulling up on a city driving the highway. It's like, oh, those skyscrapers sure do seem tilted, and they sort of square up with me the closer I get. Yeah.
Funny how they always look perpendicular, right? Always look.
Yeah, they sure do.
Well, they're only 1 degree at 70 miles, so I don't think you would see that.
Yeah, it's not. It wouldn't even be noticeable on a globe, so it's not even worth bringing up, really.
Right.
That was kind of like a side joke, because they say like if you take two plumb bobs and you hold your arms out and you have one on your left arm and one in your right arm, they say that those plumb bobs are not parallel. Yeah.
Yeah, they're angled to the center of the Earth, disregarding any sort of gravitational fluctuations in the latitude difference of your arms or whatever. But yeah.
Yeah.
Yeah, so they wouldn't be parallel.
Yeah, totally. Yeah, absolutely not, man.
Because
they're totally converging.
The meter or whatever between your arm span.
Yeah, they got a 0.0003 degree difference in angle heading towards the center of the Earth. You're right.
Right. Yeah. So they're not parallel.
Yeah, not
close.
at all.
Very close.
Yeah.
So that's almost how parallel the sun rays are, like if you want to consider that.
You guys know the history of like the sort of like strongly supported at their times distances to the sun? I only saw a couple of videos on this, and I can't pull them up, but you guys know the story, right? Where it's like, oh, the sun is 1,000 miles altitude, right? And then it goes to like 50, and then 200, eventually 93 million miles, right? But you know the story of that? If you do, I'd like to hear it because I'm a little rusty on it. But it's a fun story, is it not? How it went from like 1,000 to 93 million.
I don't think it's a story. I just think it's different time periods and different people doing different measurements and getting different results.
Well, the story of history of how those all, unfold onto each other. I don't know. Like maybe I can find a video on it. I saw it once, but I mean, it's just such a fun. I imagine it just to be such a funny story. How it like slowly grows and grows. It's like, what were they even thinking? And a lot of these people who said, "Oh, the sun is 5,000 miles," a lot of these people are some of the respected historical figures in the globe theology. So it's just funny how they were right about some things and then so wrong about others, and just that whole story of history of how it developed and gained distance over time. Like, what a hilarious story! I'd love for someone to make a video on that.
Yeah, you can just read up on Kingsley Throne. It gives a brief description and it's quite shortcut and it's worth reading. So there you will get a historical summary of those considerations of the distances to those celestial bodies. It's a quite interesting book, kind of.
Oh, cool, man.
20 pages. I can send it to you.
Oh yeah, please. You sound just a little bit muffled. I still heard mostly everything you said. You sound a little muffled, just so you know. But I didn't catch the name of exactly where that story is. But if you could send it to me, I'd love that, man. I really appreciate
it. I just sent it to you.
Thank you so much, because I mean that's something that really fascinates me. The changing distances that were imagined over time. Thank you so much.
Just for the record, there is no measurements to the sun.
Sounds right to me.
Just fake mainstream bullshit.
Yes, sir. Calculations.
What's wrong with that?
Is that you, Gambino? Man.
What's wrong with calculations? You use them to measure speed and to measure weight.
Yeah, things that you can't reach out and touch. There are ways of figuring things out, right?
I think Aristotle measured the sun. It was 190 stadia.
Yeah, that's right.
Stadia,
yeah. Aristotle's a badass, though, right?
Aristotle? Yeah, he's pretty respected.
SE, do you think you can ever measure the radius of a basketball? Is that measurable?
He was the one who first coined the expression of boats going over the horizon, I believe. Aristotle, what a genius.
Yeah. What a genius, bro.
I don't think that was Aristotle.
The word is that Aristotle was the last man. He was the last man on Earth there was to know.
I think Aristarchus was the first to suggest Earth as a sphere.
What about Pythagoras? I thought he was the first one.
Pythagoras was the first Freemason.
I thought Pythagoras was the first globe proponent. Aristarchus, he's not until 1,000 years later, I thought.
Pythagoras had this theory about music. Was like, I don't know.
I think Aristarchus might be the first heliocentric but not the first globalist. Could be wrong though. We better defer to Dodo, whatever his name.
But hang on, but
You
it
know the
was
guy.
it was Al Gore who invented the internet, though. So
Al Gore, the algorithm.
he also invented global warming.
Yeah,
Well,
I think if you
think
look up the history of heliocentrism, it'll take you back to Aristarchus, like 500 BC or something like that.
Oh, is he that ancient? No, my bad. I thought Aristarchus was way more not like modern, but I thought he was a little more modern. I don't know though. What Jesuit Dodo? What's that guy's name? What's his real name?
Jesuit Dodo.
Yeah,
5th
what's that
century
guy's?
BC. You say
Pete
5th
Shea.
century BC, but it was funny
Oh
how
yeah,
they
Pete Shea. Yeah, Pete Shea's always bringing up Aristarchus like he was the root of like all this like globe stuff. So yeah, you might be right. Dodo, Pete Shea, he's always bringing up that Aristarchus guy.
You said 5 BC, 500 BC, but it's funny how they weren't able to make a physical globe model until 1500 AD. That's kind of strange, huh? Took 2,000 years.
I don't know what significance that is, though. I mean,
it took them 2,000 years to make a model of what we live on. That's kind of strange. Maybe it didn't happen in 500 BC. Maybe it happened in 19th century.
Okay.
Maybe they knew it was flat. What all the pictures, all the art pictures of the ancient civilizations tell us.
What about Copernicus?
310 BC was Aristarchus. That's way more ancient than I thought he was. Yeah, fair enough, guy. Whoever said that. Yeah, Aristarchus 310 BC to 230 BC. But of course, my views on history and these figures, I would think is more of like a fictional narrative than true history. But still, that's where he's placed in the official story. That's not what I thought. But yeah, pretty ancient. 230 BC.
And all the maps were flat, so it took 2,000 years flat a round map. Is that right?
Yeah, I don't know. Like, why do you guys think that? Like, as far as like archaeological artifacts, like why do like this is just speculation at this point, but why do you think that there's like no like ancient globes dug up or anything, or like painted on walls or anything like that? Like,
let me answer that briefly. Before you go on about that, there was a globus by the Roman Empire, the globe, but it was a snow globe. It was a globe where you live in the inside, and there's colorful art depicting a sphere, and he lived on the inside, and it was flat like a snow globe. So that's the Roman globus. So there was an ancient globe. There was a flat snow globe.
Sure. But as far as like the Earth as depicted on the like outside surface of a ball, like what's the oldest artifact of like a globe as we would depict it now? Like what's the oldest globe we're aware of, and why do you think it doesn't stretch further back into antiquity when it comes to depicting the Earth as a globe, as far as like discovered artifacts by archaeologists? If it's such an ancient concept from Aristarchus of 310 BC.
We have one that's 1492, and that globe was confirmed by NASA in 1968.
It was found by NASA? Oh wow!
It was confirmed. It was confirmed by NASA. And the first,
I would imagine. I don't know. I'm just speculating, right?
Mm-hmm.
I mean, they were probably, they see these observations that indicate maybe the shape or whatever, but they're still limited to their local area as far as their terrestrial ground that they're on. And maybe it was not until they actually did some exploring and did some travel that maybe the concept of the spherical Earth came into mind to even come up with a model.
Well, just in simple observations of the sky, if you were already going upon the presupposition of living on a globe, I mean, you could place yourself at a certain latitude, and like with the measurements of your country or your land, like you could place yourself, some longitude position above the equator, some latitude position. I mean, that'd be arbitrary, really, because I'm not saying they had to set up some sort of prime, but they could give themselves the credit of like the center of the country. They could just declare that because it's arbitrary of the prime meridian. But still, it's like why wouldn't they? Like, why aren't there? Like, I don't know. It just seems like it would be expected to, with your limited knowledge of the topography of the globe, at least like fill in the area that you can describe. Like, sure, you don't have a complete globe, but why not? Yeah. Why not create a partial globe, at least with the area of land that you're aware of to that point? It's a little weird. That's what I would do if that was my belief and the way I envisioned cosmology and the globe and all of that. It's just weird. Like, what was that? Gregory, is what Gregory said true, that the earliest historical artifact of a globe is from the 1400s? Is that correct?
1492.
Is that correct, guys? I mean, I just want to know this regardless.
Let me see if I can get the article.
Do you guys think that's true? That the earliest globe is from the 1400s, 1492?
I don't know personally.
Crickets.
No, I don't know.
Yeah, why would you? That's not important, right?
I mean, if it's been envisioned to be this way since, maybe like 500, 300, BC, that's a good, that's a good 1700, 1800 years before anyone actually artistically depicts it. Just feel like it's a lot of time to not just visually create, sculpt, what you think is going on. And maybe that, the artifact's been lost to time, but still, I just want to see if any of the Globers agree with what Gregory's saying, that the first globe the first globe artifact we've discovered in archaeology is from the 1400s. It could go further back than that. Maybe, it broke apart or whatever, but still, is that the truth, what he's saying? Does anyone disagree?
The earliest globe that survived. So there was obviously millions of globes that just perished in time, right? Was made at 1492 by March Bayham, a German navigator and geographer employed of the King João II of Portugal.
Fantastic, man. I'm gonna go with what you're saying until someone speaks up and says anything to the contrary. Sounds like good information.
In the globe's defense, the facts of the globe are all mixed up in school. My second grade teacher told me Christopher Columbus discovered the Earth wasn't flat. Because
and there's even
didn't fall off.
Go ahead. Yeah, I was taught that too, and I've seen videos made by like PBS or SciShow or whatever, some of these like mainstream publications, right? I've seen them address this, and it's the most interesting thing ever, that even in a lot of these mainstream publications addressing this topic about like Columbus or globe flat Earth debate or whatever, a lot of them admit, they say, just to address all the people out there, globers, flat earthers, especially globers, a lot of us were taught in school that Columbus was the first person to demonstrate that the Earth was a globe and that he had his doubters. And I want to tell you guys that even though so many of you were taught this in school, and they even say that, taught this in school, we just want to be here to tell you that your teachers didn't know what they were talking about, and they were wrong, and they were part of some sort of rumor where they had no idea what they were saying. They're just idiots who are repeating a rumor of a lie. And I mean, that's just fascinating that even like some sort of mainstream publication will admit that almost the majority of this, for some reason, we're told this by our teachers. It's like, how does that happen? How does a rumor of just complete inauthenticity become that widespread within the school systems? Like that's incredible. That so many teachers would repeat a lie, somehow not by what's written in the books, because that's the excuse, right? Oh, it wasn't written in the books because it's just a rumor, it's just hearsay, not any sort of official information. But yeah, all of our teachers decided to tell us this for some reason or another. Like what? that doesn't make any sense. That's a reality breakdown.
My take on it is that there wasn't real facts about the curvature of the Earth, about proven curvature, about the first discover. So that's why you got all these rumors. The closest thing to a fact is a rumor. You don't have the fact.
So, because I mean, I taught that it wouldn't be such a meme if it weren't so like widespread. But I mean, when Neil deGrasse Tyson says the popular flat Earth is a clear demonstration of the failings of our educational system, well, I'd say a even more potent example of the failings of our educational system is that there's more people believing that Columbus proved the Earth was a globe when people thought it was flat. There's more people believing that than think the Earth is flat. There's more people who believe Columbus proved the Earth was a globe than there are people believing the Earth is flat, which is an even greater failing of the educational system by his standards. And so, like that's just crazy. But here we are. We enough of us heard that like there's no question about it. So it's just strange. It's just strange. Maybe call it Mandela effect, call it a feeling of that. I don't call it whatever you want, but that's my story. I was there. I was told that. You know, it's also weird. It seems like the internet came out. And I grew up. I grew up without the internet for I don't know the first third of my life, and then it's there, but it's not much, right? It's just some travel blogs and chat rooms and whatever. It's not what it was today, and eventually it evolves into what it is today. But throughout my entire schooling process, I never heard about the concept of phi. The mathematical concept of phi. I heard about pi, but not phi. And then it takes till like I'm out of college and I'm delving into some of the weird corners of the internet for me to come across this concept, and it's amazing. It's awesome, and it's everywhere, and it's in nature. Everything that moves and grows exemplifies it. And I learned about this from some weird corner of the internet, and I go to my parents and I go to my grandparents. I'm like, hey, like, anyone ever bring this up as like a big deal? Like it's like a kind of cool and amazing, and all the ancient megaliths and structures and temples like have this proportion encoded in their design, and credit cards are designed with this proportion. Cigarette packs are designed to this proportion. Your body, your fingers, all aspects of your like body parts are designed to this proportion. Like anyone, and even deeper than that, like anyone ever bring this up? And it's like, no. What are you talking about? When I bring it up, they're like, no. What is phi? You talking about pi? And I say, no, not pi, phi. And I say, no, I never heard about it. And then, all of a sudden, after my parents and my grandparents never heard anything about this their entire lives, and I also in my educational schooling never heard about this in my entire previous life at this point, go to some weird part of the internet, learn about it, and I start to notice a lot of people else are hearing about this mathematical concept that all the ancients designed their temples to a large degree factoring in. And then, it gets popular enough that you get like hundreds of TED Ed lectures on it. It's like, oh yeah, TED Ed, some sort of official educational franchise, right? They're like, yeah, let's talk about phi. We weren't hiding this from you. We weren't hiding this mathematical beauty from you. We're totally comfortable teaching about it and lecturing about it and talking about it. It's like, well, it's one of the most amazing things ever. It's something that no one should be able to get past the age of 15 without understanding the beauty of it. And the fact that like generation upon generations don't even know what I'm talking about. I mean, this seems to me to be sort of hidden knowledge to a degree. Not to say that it wasn't always being involved, because you can't hide it completely. I'm sure like in higher levels of education, sort of collegiate levels, university levels, like, yeah, the math majors are going to learn about this. But that's really messed up when you gotta, I don't know, go into serious debt, take 4 years of higher education to even be introduced to a concept that a 5-year-old could understand. I don't know. It just seems to be one of these things that was hidden as long as it could have been. Now the internet has created such a free flow of information that they're just pretending like they never did try to hide it. It's like, that's we're willing to talk about it. We're not hiding anything. I don't know. I feel like that's an extreme example, but it applies to a lot of things where it's all about the empowerment of the individual. I imagine that like the controlling systems at play do what they can with the options available to them to not withdraw, but prevent access to certain sets of information that they deem you to not be necessarily needing of access to the information. Like, yeah, all we need to know is enough to do our jobs, right? We don't need to know about any of the philosophy or beauty of the world around us. All we need to be educated on is the STEM system of science and engineering in order to just push the buttons and pull the levers and fulfill the equations and goddamn the background science. But it's annoying. Sorry, guys. Well, no, I'd like to see a complete restructuring of the educational system. I don't know about you guys, but I just feel like the important things take too long to be taught, and a lot of important things aren't even addressed. I'm kind of grossed out by the focus and direction of it all. I think that the first 18 years of a student's life, I guess minus the first 5 years before you're in school, so 13, the 13 years of schooling, I think there's a way to make a much better efficient use of time to put better information into the kids' heads and delivered more properly and digestibly, not such a waste of time. It's like imagine you tell someone, I'm going to give you 13 years of my life. I want you to make me as smart as you can. It's like what a joke. What a joke. I'm going to give you 13 years of my developmental life. My 13 years of development where I can soak in information the greatest, and let's see what you make of me. I'll do all the assignments, I'll do all the work, I'll read all the books you assign me, and what do I come out with it as? Is like, has anyone ever graduated high school? You graduate high school and you say, I have graduated high school with straight A's, therefore I am prepared for life in the real world. I'm a high school graduate who got straight A's. Therefore, I am prepared for life in the real world. I have real world practical knowledge to apply. I'm set. I know what to do. Never reveals the beauty of it all to you or prepare you for the most important things, the hardest obstacles that are inevitable to come across. It's weird. It's weird. I'd like to see a complete restructuring of all this stuff. It's actually kind of gross and evil, in my opinion, the way I've come across to view it. Higher education can do a good job, but it shouldn't take that much. It shouldn't take some sort of giant debt wall to learn anything of value. Really, it seems like all you learn is some simple chemistry, physics, reading and writing, and addition and subtraction, and some algebra and calculus or something, to a small degree. Not meaning to rant. I don't know. I'll take a back seat. I know I've been talking for a while. Well, if no one's going to talk, I'll just address what we're involved in right now. I'm sure all of us would have liked to be taught on the proofs and ways to investigate yourself for the shape of the world you're in. Anyone ever get a class on cosmology in their lower education? I don't think so. If so, you wouldn't be here now.
Funny you mentioned cosmology. I just made a new meme. Tell me, what do you think of it?
Let's see. Jupiter, Mars, Moon, Earth, Sun. Soup bowl cosmology. I don't get it.
You don't get it? That's how they envision the gravity. That's how they envision. Yeah.
Okay, sure. Yeah, gravitation, the gravity wells. Yeah. Yeah, that's right. I don't think it strikes hard enough. Like, yeah, that's how, like, I'd say that's more value to them than it is to you.
Yeah, it's reinforcing the model, of course. Good point, but I'm just making fun tonight. I'm in a funny mood.
Well, I remember my second grade teacher told us about gravity. She said, one day she said, kids, it's a good thing for gravity. Without gravity, we just go floating off into space. And I believed it, but she said that with no proof. So I believe I just go floating off into space without gravity. This is what they teach the kids.
That's what everybody's been taught. That's why they believe this stuff. And when we make fun of it or when we ask questions, they get triggered to high hell. They just can't accept it.
I've not heard a good alternative to the explanation of what gravity is.
The thing is, you can never float off into space. It's not going to happen. Oh, why? Because gravity.
It's perfectly well explained within the realm of modern physics of what gravity is and how it works and everything. And I've not heard an alternative to that. I mean, y'all
As you go
dispute
through
it.
high school, they don't teach you orbital mechanics or gravity or anything. And then,
just
and then
general physics, yeah.
And then you get to university, and if you don't take a science paper in university, you're still not going to learn it.
That's right. You unless your degree requires physics, like in biology, you may or may not get around to physics. Physics 101.
So you've been to a skating board park, right? There's a lot of them in the States, right?
Hell yeah.
Where they have those up ramps and then you go straight and then you go down again, right?
Yep.
That's what they tell us the universe is. A bunch of on ramps, off ramps, gravitational wells. That's the model, bro.
Yeah, and in between, they call them a spine.
Is that what it's called? Wow, I didn't know that.
Yeah, like say you got flat ground, right? You just got flat ground, and you're approaching a quarter pipe, which is just like a 90-degree, a quarter of a pipe, right? 3/4 make a full pipe, right? And like a half pipe is a pipe cut in half, sort of like a bowl, right? But 2-dimensional. If you take a quarter pipe and put it up against another quarter pipe, so that it's sort of in the shape of like a mountain, but with like concave sides, they call that a spine. Like one quarter pipe up against the back of another quarter pipe, and that would be that transition point from one gravity well to another, right?
Exactly,
the spine of
brother.
the two.
Yes, exactly. Now now listen to the model. They want you to believe that you start from the spine, or actually in the bottom it would be in this case. So you gotta reach 25,000 miles an hour to get to that spine, but by the time you reach that spine, you're traveling at 0. Then you hit the spine, you cross the spine, and then you start going down the other pipe, the quarter pipe you called it, right? That's what they'll have you believe, bro. Did we lose him or did we lose me?
No, you're there.
I think we lost you a long time ago, man.
Yeah. It's the model, bro. Don't blame me. It's your model that plays these crazy tricks on your head, not me. I'm just pointing them out.
I don't ever consider all these wavy, bendy space-time concepts that y'all talk about. I just think about in terms of you let go of something, it drops, and I can throw something, and I can gauge how hard I need to throw it to get it to go, how far I want it to go, and things like that, or how strong I need to build a structure. Like if I was going to build a bridge, I need to build it out of a certain, size of material so that it doesn't sag or break. Things like that. Just practical concepts. I don't think about bendy space-time and dark matter and all that crap. I just think about it within the realm of what I need to think about.
Yeah, I don't blame you because otherwise it would be ridiculous to think of stuff that way. But irregardless of how you think about it, and I'm with you, I think about reality too. But that is your model, bro. That is your model.
Yeah.
I mean, it's not my fault.
I'd like to see a static representation in the form of some type of graphic illustration of how the planets are all acting with this gravity. Like there's never been an illustration of because I always imagine some type of a tether. At least someone should be able to draw to give you a visual representation of what gravity looks like.
What gravity looks like.
It really should be easy.
I told you, a Subo.
Color coordinated, just some like a topographical map with some colors and some lines and some arrows.
Yeah, does
bro,
it look
they
like
tell you, bro. Clearly, they tell you.
You could just draw a circle, and you can draw arrows all going towards the circle, towards the center of the circle. I mean, is that what you're asking for?
Yeah. An absolute, very descriptive model of gravity of all the forces involved in our solar system.
So if that was done for you, would you finally understand it, or would you have further questions?
I'd be able to analyze, at least I'd be able to analyze what I'm visually seeing as the representation, because I don't know if it's supposed to be a matrix or a grid or tethers or what the fuck does it look like?
I think it'd just be a circle with lines drawing, going towards the center of the circle. That's what a representation of what gravity's. That's what a representation of what it's doing.
Sounds simple. Let's see it. Someone's made it, right? Or no?
You could get yourself paper, right? Draw a circle.
No, not me. It shouldn't be up to me. Someone's done this, right? I mean, if no one's done this, then that sounds kind of stupid. Like no one's done this.
Well, grab yourself a piece of paper.
No, I can do this.
Pretty simple.
I know how, but is it up to me to do this for the first time ever?
I mean,
it's on my shoulders.
Extremely, really simple to do. I mean, I could find a picture for you. I could do that.
That'd be great.
I mean, what's that going to do for you?
Yeah, well, it's part of the heliocentric model, and it's, I think, the most fundamental part of the model. Where's the illustration?
Yeah, I would be left to Google it. That's what I would do.
Oh, let's
well, one thing about the solar system is that if you're going to depict it from Pluto to the sun, that the distances and the size of the objects, they're not even going to show up on a regular like say my phone screen is like a 8K resolution screen, right? The sizes even on an 8K screen resolution, the sizes of even the sun isn't going to take up a single pixel. So that's one of the issues with the globe model, the heliocentric model that's proposed, is that all of the planets always have to be extremely enlarged to even show up on a display. Like for you to, you could even have like a theater, right? You could have a theater projection size screen, but to even resolve visually this, something to the proportions to be shown visually at size. I mean, you guys know that the distance between the Earth and the sun is 108 moon. I'm sorry, the distance between the Earth and the moon, the closest celestial object, is 108 moon diameters between the Earth and the moon.
Yeah,
and
space is really big.
Yeah, that's what. So that's the problem. We don't even have
space is really big.
No, I'm saying there is a problem. It doesn't have to do anything with space being big or anything. The problem that we have is the ability to even show the entire solar system at proper proportions and ratios and distances of each other on any screen that exists. We don't even have the resolution or a screen big enough. We would need
why do we have to have a screen big enough to be able to show the correct distance between the sun and the Earth, or the sun? What does that mean?
Because you can't take into account the proportional sizes of the objects.
Since it's science, and why don't you show us a drawing or a map or a paper drawing where the sun and the Earth and the moon are in correct distance proportions? Okay, go. We're waiting.
Space is really big.
Show us on a paper.
If I show it to you, what's it going to do for you? Are you going to agree with it?
You can't show it to us. You can't show the entire solar system to us.
On a screen. So what's the problem? So why is that a problem?
You won't be able to see the moon from the Earth, for example. You won't be able to see the sun from the Earth, for example. That's what it'll show you.
Okay, like I've been saying, space is really big. I'm sorry you don't. I'm sorry you can't comprehend that, but that's just.
I was actually explaining how I can comprehend it, but that there's not a screen big enough to even say, okay, so
I agree.
We're gonna get a giant movie theater, right? We're gonna get the largest IMAX theater possible, and we're gonna make the sun 1 inch in diameter, project on the screen, right? We're gonna make the sun represented as 1 inch. We don't have a theater screen large enough to show people even if we shrink the sun down to a centimeter, right, so that you can barely see it, we can't show the actual proportions of distances and sizes of an object, keeping it legitimate, where everything is in correct ratio and proportion to each other. If we shrink the sun down to a centimeter, we don't have a movie projector theater screen large enough to portray the entire solar system on it. So that's not an issue with the theory. That's an issue with anyone's ability to show what they believe visually. You can't show what you believe in. Not to say I can't comprehend it, but you'd need a theater screen a mile long, maybe even larger.
I think we understand the scale of it. Yeah, you can't show it on a screen visually. You can't draw on a piece of paper. Okay, what is that? What does that? How does that disprove that what the distance is measured?
Doesn't disprove anything. Doesn't disprove anything. All I'm saying, and maybe we can. This is somewhere I think we agree. That just blows. That sucks, man. Like that. It absolutely sucks.
It is what it is.
Not really. It's just what it is.
No, you have to ask someone to imagine it because you can never visually show it, and that's not your fault. That's not NASA's fault. No human's fault. But
that's
it
just
sucks.
The nature. I know it does. That's just the nature of our existence.
Yeah, fucking blows,
we are very
dude.
small, and the Earth is very big, and space is even bigger. And I mean, there's things out there that are so far away that the light that travels to us has been traveling for millions of years, and they're probably already gone by now.
Even if you exaggerated the sizes, so you could put it on an A4 piece of paper, right? Even if you exaggerated the sizes,
yeah.
How do you explain how gravity is interrelated with all of the planets in all of the solar system, and describe exactly what gravity looks like in graphic form?
You mean drawing it? I mean, you just like I said before, you just have to draw a circle.
It's hard to imagine how you would draw something you can't see.
If it's something that's true, you can't see radio waves either, but you can draw them, can't you?
Sure. I mean, you can't see wind either, but you can draw wind, right?
Yeah, there are visual depictions of gravity wells and things like that. It's just to visualize it in the 3 dimensions is the difficult part. Yeah, the 3 dimension of it is what's hard to actually represent visually in something that we can see and look at.
I mean, I don't disagree that it would be kind of difficult to draw all that out visually. I mean, it probably could be done, but it would probably take a long time to map out all the forces involved in the solar system and how they're all working together.
If you're sending rockets to Mars, you'd have to know.
Yeah, I think that part they have that pretty well established.
Yeah, just by approximation and velocities.
And that's why it works. That's why when they send things to Mars, it works, and and they always get there. Sometimes they fail, of course. There have been failed missions, but sometimes they actually achieve it.
How are you so sure of that? You talk with such certainty. How are you so sure of that?
The difficulty of sending a rocket to Mars is like having a 100-mile gun range and trying to aim at the bullseye.
Yeah, exactly. It takes very precise mathematics.
And those mathematics need to be transferred onto that mechanical spaceship.
Mm-hmm. That's why they get paid a lot of money to do it, and we don't.
And in the root of those mathematics, the radius is a fundamental part of it. And then when you go to reality, there's no radius to be found anywhere. No radius of the globe.
I mean, that's just bullcrap. Yeah, that's bullcrap.
Yeah,
I mean, everybody says you have no radius. You can't do anything. You have no radius.
It is bullcrap coming out of your mouth. Yeah, it is.
Yeah, that's a claim you'd have to substantiate that there's no radius.
You claim a radius, but you cannot demonstrate it anywhere in reality.
Yeah, we can. How? You just deny it. That's all.
How can we not?
Yeah, you just put yourself in a character role inside of a cartoon and speak from the cartoon and say, "Hey, this cartoon is real because my character says so."
Okay, so when people have said that they have measured the radius, are they lying? Where are they getting this number from? Have you tried measuring the radius?
The radius has been falsified. The radius of the globe Earth that you are claiming has been falsified.
By who?
By many different ways of doing it. Observations, laser tests, radar tests.
Eratosthenes, you can measure the radius.
Mm-hmm.
At a test.
That's one way.
He measured. Yeah, he calculated the radius of a cartoon The cartoon that you are protecting.
No. And I wonder why a bunch of flat earthers haven't gotten together and actually tried to measure the radius.
Well, tell them to do it.
You're one of them, right? You can get a bunch of your buddies together.
No,
you get together and you can do it.
You are.
You know, like when you're shooting a gun, you're looking at the target through your scope, so you have something to aim at. When they're firing a rocket to Mars, they do not have something to aim at. There's no scope. There's no target. It's a remote control toy. How the fuck are they supposed to be aiming at Mars and getting there?
They know precisely where it is in its orbit.
It's like going to Narnia.
But how do you transfer that to the rocket?
You just make a cartoon. You just make a cartoon about going to Narnia and say, "Hey, you see, I made it to Narnia." That's what these guys claim.
It's because for one, they know exactly where it's at in its orbit, right? And they know exactly when to fire the rockets in its orbit around the Earth.
They put the radius into that equation. That radius that doesn't exist in reality.
Hold on.
It's only a fantasy.
They know precisely when to fire the rocket during its orbit around the Earth to have it leave the Earth's gravitational pull in order to get to Mars. There's a window. There's a window in which they have to do that, and if that window is incorrect, then they're going to miss by a long shot.
Yeah, it works in a cartoon, right? If you put it on paper, piece of paper, and write it down.
I don't know, man. You've never actually tried it.
It works in a cartoon.
You can sit here and spout off all you want, but since
that's exactly what you're doing.
Involved, then you can't. You have nowhere to say that this is correct.
Yeah, Superman works in a cartoon. Superman works
to hand wave it and say cartoon. That's not a refutation.
That's exactly what you're doing. You're claiming cartoon equals reality. You're saying, hey, I'm drawing
that's what you're saying.
I'm drawing a cartoon.
That's what you're saying.
This is reality. That's what you're doing.
That's what you're saying. That's not
what you're saying.
No. That's not what I'm saying. You're misrepresenting what I'm saying.
You are saying that you are saying that a cartoon that you made up in your imagination equals reality.
Is it a cartoon though? Or are these things actually happening in reality? Is it a cartoon?
Yeah, the cartoon that you made up, the globe Earth and then spinning through the vacuum of space and sending things from that cartoon to a different position of the cartoon. That's exactly what you're saying.
Now let me be specific. What I'm saying is the technology does exist for these things to happen, and they do it. That's what I'm saying. I'm not saying anything about a cartoon or any bullshit that you're saying that I'm saying. I've said what I just said.
Yeah, he was talking about the mathematics of the cartoon, which is the radius, right? Because to be able to put the information into the technology that you're claiming, to be able to leave the Earth and make it to Mars like a slingshot, I mean, you're using calculations of a movie, of a cartoon, like Superman.
Calculations of a movie or a cartoon.
You're using the calculations of how much power and speed Superman has to put into his force to be able to jump from.
This is ridiculous.
It is ridiculous. Yeah, it is. I'm glad you noticed. It is ridiculous. It is ridiculous.
Okay, first of all, you said the radius was falsified. How exactly? Give me an example of the radius being falsified.
Well, let's say the first transatlantic communication between a direct message between New England, United States, and Scotland, over 3,000 miles. They connected from point A to point B through the Atlantic Ocean. That's one.
Atmospheric skip.
Yeah.
No,
bounce off the ionosphere. Okay, next.
Yeah, keep dreaming. Why didn't they claim that in the application of the construct of the towers?
That's one thing,
it
right?
as a direct message, two-way communication.
Was it direct
between
message
transmitter and receiver?
Do you know exactly how that happened though? Or is that something that you just heard?
You're claiming that if the signal is being bounced out of something, therefore the ground is a spinning globe through the vacuum of space. That's a big reason.
Or did you just hear this from another flat earther and you kind of just latched onto it because it sounded like a good?
Did you hear this from a flat earther and that's what you claim? Is that what you did?
Yes, that's what I'm claiming. You heard this from another flat earther.
You claim this from another flat earther.
I'm saying
out of the ionosphere.
You're claiming. No, I'm saying that you're claiming, right, that this radio transmission didn't bounce off the ionosphere and make it across the Atlantic, right?
Oh, you're claiming that these people that did it are
because
flat earthers. You're saying that Marconi was a flat earther. Wow, that's news for me.
no, I didn't say that. Now you're putting.
You said that I heard
words
this from another flat earther, Marconi.
Yes, you
right?
heard this.
Marconi
You heard this argument from another flat earther, and you're running
Marconi.
with.
So you're claiming that Marconi is a flat earther because the
No,
documentation
I'm
that is
saying
written,
that your
it was
claim.
Marconi doing this.
No, your claim that this debunks the
it was
globe
Marconi.
is something that you heard from another flat earther. That's what I'm saying.
You're claiming that.
No, you're claiming that.
You're claiming that.
Okay.
I hear a hint of Nathan Oakley in this. I don't know.
Pretty much.
I get that feel out of it.
Who's that?
Yeah.
Nathan
Okay.
Oakley?
What's the next? What's your next claim? What's your next
who is this
falsification
Nathan
of the
Oakley?
radius?
Is he a globe earther?
What's your next
don't have
falsification of the
R.
radius? Okay.
So, okay, the transatlantic communication. Let's talk about the communication between the radio communication between England and Australia, right? Over 10,000 miles, direct message. Are you saying that one went from one side of the globe to the other side of the globe? Are you claiming bouncing
I've
out
never
of
heard of that one.
What are you
Of
talking
course you
about?
haven't. You haven't, right?
No, I haven't
You
heard
mean
of
how
that.
the signal bounced off the ionosphere?
No, you're the one claiming that in the transatlantic communication, but I'm giving you another one that is over 10,000
So you're saying
miles
it didn't?
from
You're saying it
England.
didn't bounce off the ionosphere?
It was a direct message from point A to point B.
Okay, so why? Okay, how do you know it's a direct message?
Because that's what they say. That's what they claim.
That's what they say.
So,
Okay.
so if we looked up the information on that particular information, that they would describe it as not bouncing off the atmosphere, right?
I mean, let's say it's bouncing out of the air, up in the air. Does that prove a globe?
It wouldn't have. I mean, wouldn't it be? Why would they have to bounce it off the ionosphere? Why not just send it straight
That's
across?
your claim. You're saying they're saying that. Well, how does that prove the globe that they're bouncing it out?
Let's look this up real quick. Let's look this up. What exactly are you talking about? Some kind of transatlantic? Which one are you talking about now?
Put the first transatlantic communication, Marconi.
Yeah, we know that was presented as skipping off the atmosphere.
Uh-huh.
Mm-hmm.
So they devised the tower from New England in the United States, the East Coast, and they put another tower in Scotland, and they devised those two devices to be bouncing off the ionosphere and bouncing back towards the receiver. That's the way they did it.
That was their report. That was how it was depicted in their report.
Depicted in their report, okay.
I haven't heard of the one from England to Australia. That's an interesting one. Okay.
Hold on a second. And just to be clear, nobody knew about the ionosphere until this happened. Is that how it went down, or did they already know there was an ionosphere there?
I don't think they knew. I'm not sure. I don't think they knew.
So in other words, they made it from here to there and was like, "Oh shit, we better come up with something quick."
I don't know if that's
that
how
might
it
have
went.
been.
No.
That might have been.
Well, they didn't know about the ionosphere before this, so.
Okay, December 12th, 1901. First radio transmission sent across the Atlantic Ocean.
No, frequency has something to do with that too.
The first two-way transatlantic radio telegraphy transmission took place the 10th of January 1906 between Frinton Station at Brent Rock, Massachusetts, and Machine Hanish, Scotland. Repeatedly regular exchange of messages across the Atlantic Ocean took place on most days during winter, spring, and into early summer.
So radio wave propagation is the behavior of radio waves as they travel. In many explanations, flat earthers invented, they assumed all radio waves behave the same way. In reality, different frequencies of waves have different behavior. Right? So a ground wave travels straight across the ground. A sky wave bounces off the ionosphere. Tropos scattered by the turbulence of the atmosphere, the troposphere, and in line of sight travels directly travels directly and privately in a straight line.
In a straight line.
So Marconi's transatlantic was a sky wave, which in turn bounced off the ionosphere.
Oh, he did that. What year did he do that in?
1906 is one of the documents.
No, I don't think they knew about it. I don't think they knew it was bouncing off the ionosphere.
Oh, but you were claiming, this other guy was claiming that they devised it to bounce off the ionosphere,
Yeah,
but
but
now
they
they
didn't
discover
know.
it.
They didn't know that it was
They
going to do
didn't
that.
know, huh?
No.
Ooh, they didn't know. And they claim it was a direct two-way communication. And you're saying now they're bouncing, so it's not a direct one.
Well, no, you said it was direct.
First, let's see this one. The first direct wireless message from England to Australia sent under the direction of the Marquis Marconi from the Marconi wireless station, Carnarvon, Wales, was received by E.T. Fisk, Esquire, F. Institution RE, AMIE, Australia. In the experimental wireless station attached to this residence, Lucania, here in the 22nd of September 1918. That's from England to Australia, 10,000 miles.
That's cool as hell. Is there more about that transmission?
There
must have been using a lot of damn power to pump that all the way to Australia.
Anytime you look up radio wave propagation online, they always show a curved surface, right? And there's also a thing called what is it called? The shadow, or is that radar? I could be wrong.
Maybe radar.
Yeah, radar shadow, which is, because of the curve of the Earth, doesn't reach all the way. That's, the term flying under the radar. That's where that comes from. All right. Well, so your claim that this radio transmission debunks the globe is kind of wishy-washy at best. Do you have anything else?
Wishy-washy for the globe, right? Wishy-washy that you're bouncing the transmission out of your imaginary bouncing spot.
So you're claiming that things don't. Go ahead.
I believe
wishy-washy.
The way that you present is what I have trouble with. That there is no proof, there is no radius, there is no measurement. That's just not true, man. There are measurements. You can deny them, or you can you can deny them, but they exist.
The radius definitely a lie.
But
I mean, the radius of the globe, because you can make a circle on top of a level horizontal plane, and that circle can have a radius, right? If you make a circle over a distance, sure. But the radius of this globe, that globe that you've never experienced, you only see it in cartoons, and you claim, hey, those cartoons must be real, therefore everything works on the globe. But you're just speaking like a character in a cartoon. You don't have any direct experience with this globe.
When you take that flat disk Earth that you guys like to call a straw man, and then you try and use distances on that flat disk Earth that you guys like to call a straw man, then
You
that's
guys,
when
who's you guys?
that's
Who
when
you
it
talking
becomes a
about?
straw man. When we demonstrate how the distances don't work on that flat disk Earth that you call a straw man.
Who is you guys? Who's that?
Flat earthers.
Who's that? Is that like a individual?
Okay,
or
now
something?
we're gonna play dumb. All right.
Is that like an individual that you're talking about?
People who believe the Earth is not a globe, like you.
Wait, people who believe the Earth is not a globe are immediately flat earthers?
Yes, because you believe the Earth is not a globe. Can we stay away from the pedantics, please, and get on?
So you are
topic?
a globe head because you believe in a globe. You are a globe head, right?
God, can we get back to the actual topic instead of trying to be pedantic?
To the wishy-washy claim of the direct message being bounced out of the ionosphere.
Yeah, because that one didn't work for you.
Remember when you were back in his line of thinking lots of steps ago? Yeah, you got to be a little nicer to him. He's just
a little nicer,
so
but
far behind. He can catch up and understand.
Yeah, he said that I was being wishy-washy, and therefore he was hand-waving the
he's got to
direct
say
message.
stuff like that. He's got to defend his narrative.
So go ahead and go. The radio bounce didn't work for you. So what's your next thing that says it debunks the radius?
The next, so the radio communication towers debunk the radius. You don't like you approved that one already.
No,
you want
that
another
didn't
one.
work for you because we know they bounce off they bounce off the ionosphere.
The radio doesn't work. I mean, come
they
on.
Bounce
bro.
off. No, that didn't work for you because they bounce off the ionosphere. And if they didn't, why we could just send them straight across the ground.
Yeah, it doesn't work on your cartoon.
They wouldn't have to bounce off of anything, right? We wouldn't.
So you're
they wouldn't have to bounce
reality.
off of anything. So next, let's go to the next one.
You're wishing-washing the actual thing that happened in reality, and you're saying, hey, that doesn't work in my globe, in my imagination. Therefore, hand wave it.
No, I didn't say that. So that didn't work for you. So what's your next claim that
did
debunked
work
the radius?
Because it did work because the communications were accomplished.
Yes, so because they bounced off the ionosphere.
That's your wishy-washy claim.
I can present evidence showing that that's what happens. Can you present evidence that shows that doesn't happen? Anytime you look up radio wave propagation, it shows that it bounces off the ionosphere.
Yeah, it's showing the cartoon.
So
that
go ahead and Google that, and you can look that up for yourself.
It describes a globe, right? The globe of your imagination, and it will kind of depict it in the globe.
Yep. So let's go to your neck. What else debunks the radius? Because
isn't that like confirmation bias? You say, oh, look, this depiction, this wishy-washy depiction depicts a globe. Therefore, it must work on a globe because that's what you want to believe.
For some reason, that's the way it's depicted. So, and you don't have any evidence showing that's not what's happening. All you're saying is, it's a cartoon in your brain. That's your only defense.
Evidence.
That's your only defense, and you can't present any.
Yeah, the evidence is right there.
Where?
The first two-way transatlantic radio telegraphy. It doesn't sound
that bounce off the ionosphere.
Bounce off the ionosphere message towards the receiver. It doesn't say that. It says the first two-way transatlantic radio telegraphy transmission.
Yes,
and they describe it as a direct message from transmitter to receiver. Direct message.
Okay.
So
you think it traveled?
Your explanation is wishy-washy about bouncing it out of the ionosphere.
So you think it traveled across the ground and didn't?
Even if we can devise a device that can shoot signals up to the sky and it will bounce out of the ceiling and it will turn down onto the receiver, that doesn't prove a globe.
Why would they have to do that then? Why would they have to do that then?
I mean,
why not just send it straight across the ground?
I'm not claiming they did that on the transatlantic communication, but you're claiming that if they did that, that means a globe, but it doesn't.
I mean, anywhere you look up radio propagation 101, it shows that it always bounces off the ionosphere. If it didn't,
where 101
would be in the way.
Like 101 on a globe. Yeah, 101 on a cartoon globe, it will claim that for sure, but in reality, it doesn't.
So I think anybody that you talk to in this field of expertise would tell you the same thing. So you can call that appeal to authority all you want, but I mean, I'm going to have to go with people who know what they're talking about,
That's
right?
your claim. That's your claim.
All right. So let's move on. Right. So what else debunks the radius?
Okay. How about the radar test done in what was it? Peru? Was it Brazil? I have it here somewhere.
Radar
The
test?
radar from 14 kilometers. It was like 2 meters from the ground. They connected from one side of the lake to the other side. It was a radar transmission, and it has to be from transmitter to receiver. And they completely came to the conclusion that there was no curvature in between the two devices.
All right. Who came to that conclusion?
The researchers that did the test.
Who are the researchers?
Yeah. Can we see the document on that?
Because I mean, there is a thing called radar shadow. Do you not know what that is?
What is it?
I mean, it's a phenomenon on weather radar when the radar energy is unable to penetrate when there's something in the way.
So
normally when they're shooting radar over water, right? The horizon gets in the way. That's why the term, they heard the term flying under the radar. That's because the radar is blocked by the horizon.
This test was specifically set up to from the transmitter to the receiver, point A to point B, to see, and it was the only way these two towers would connect was by a direct line of sight message.
Okay, can you show me?
How tall were the towers and how far away were they?
14 kilometers.
Which is what?
14 kilometers.
Yeah, that's depending on how tall the towers are. That's doable on a sphere.
That's only 8 miles. That's only 8 miles.
Yeah.
Really?
So what?
You don't think the radar could travel that far?
It did. It sure did.
Yeah.
Who's saying it doesn't? It connected.
That's not far enough. Try like 50 miles.
Never.
But there should be water between the devices. If there was any obstruction, there will be no connect. There will be no device connecting.
You said it earlier.
What height was it again?
Says that it's worthless.
Wait, at what height was it at?
Let me find it.
Because that is 8 miles. I mean, come on.
There's no curvature between 8 miles. Nothing.
Not enough to block a radar, depending on how high it is.
8 miles has 45 feet of physical curvature.
At what height, Godric?
No
at what height?
Surface of the globe, physical curve.
Okay, so we're not. The radar thing wasn't sitting on the ground, Godric. Come on.
So if the towers were like 20 foot tall a piece.
So wait, but we can't see the curvature no matter how high we
the
go.
height of antennas, it was 1.5 meters from the water level.
Is that right? The horizon is blocking these radio signals, but we can't see the Earth curve no matter how high we go. Which one is it?
So from the water level, they were 1.5 meters.
Okay, can you post? What are you looking at?
The point of the observation, it was 14 kilometers away.
Dang, I can't imagine an apparatus only being 4 feet off the surface.
I know,
me
neither.
That doesn't make sense.
Doesn't make sense?
How tall are radar towers?
This is radar towers that they had themselves, and they set it up between the two spots.
Yeah, but you're saying they're like 4 feet off the surface. If they're on a boat,
meters.
If they're on a boat, they're like probably 10
They're not
meters.
on a boat. They're at the shore, near the water.
Yeah, but I mean, you're talking about the radar. You're talking about the radar head being closer to the ground than you are standing up. That doesn't sound right.
And can you post whatever source you're going to for this information? Can you post it, please?
Yeah, I'll give you the screenshots.
Because I mean, 8 miles is like nothing.
8 miles is nothing.
Yeah.
That's a great claim.
Yeah.
Amazing claim.
I
8
mean, when's
miles
the
is
last time?
nothing.
Let me ask you a question. When's the last time you've actually been out to a body of water?
Maybe today was the last time I did
Okay.
it. Yeah.
Okay.
Today.
Have you have you gone to see like something is like really far away over water?
Oh yeah, very far away. Yes.
Okay, and
You got it right.
How far exactly?
Over 15 miles away from me. Yeah.
Okay, 15 miles. How high were you above the water?
Maybe my eyes were probably 5 feet above the water.
Okay.
You mean
Wherever you were looking at that was 15 miles away, could you see the bottom of it?
Could I see the bottom of it with
Mm-hmm.
my eyes?
Yeah.
I mean, it was level to my eyes, right? Like
Would
if I
I would
went further into the water and
So
put my chin on top of the water, because my feet were inside the water.
What object were you looking at that far away?
Land, sea, shore that was away from me, up the shore, north.
Yeah, but were you seeing the beach? Do you see the bottom?
Yeah, you can see the
the
beach. You can see the lights from the street.
So there was no
the
angular
shore.
compression. There was no angular compression to your limit of that they talk about, that everybody talks about, that hides boats. You didn't see that.
You didn't see the angular compression?
You know what? There was the observation was being done earlier, and then during the day, that's funny because it got blurrier and blurrier, and after a while, you couldn't see that anymore. You couldn't see the shore far away anymore. So earlier in the morning was visible, and then later during noon, afternoon, it wasn't visible.
So I tell you what you should do. Go out there tomorrow and take some pictures of the farthest thing you can see over water. If you have a decent enough camera. And then let's see if you can see the bottom of it.
Well, I think at this point I would like to address a couple of things that he acts like that we just believe what we're told, and all, we believe in the scientist and everything. Personally,
Godric,
somebody's hot mic.
You're hot micing, man.
Wait, who said that you believe in the scientists? Because I don't think anybody said that.
Well,
can somebody mute Godric, please?
Okay, there we go. No, I mean it's kind of like you gave the impression that I just.
Wait, Godric. Yeah, there you go.
That I just believe, and I don't have any opinion of it based on my observation. Like one example that I like to give is, like, if you point at the sun at sunrise, and you point at it at noon, and then you point at it at sunset, you've drawn a half a circle there. Now point to where you think the sun is at midnight, and where should it be? And naturally, I point straight down at the ground. I mean, that just only makes sense to me to close that loop with the other half of the loop pointing straight down at the ground at midnight. Right. So that's one example of why I believe that it's spherical, you know. And then there are other observations that go with that too, you know.
Yeah. Whereas on flat Earth, you'd have to point, I don't know, north.
North. Yeah. So that just doesn't make sense to me to draw that half circle, and then at midnight I'd have to point due north. That just doesn't make sense to me.
At some point after it goes below the horizon, it would have to take a sharp right turn.
So that's just one, just really basic thing that I can talk about that makes me understand that I'm on a rotating sphere.
Sorry, guys. Was I hot micing?
Yeah, you were, man.
Thanks for covering me. Yeah, I'm good now.
Where'd he go?
Oh, no, he's busy.
maybe. I didn't know. I'd like to hear what he thinks, if that's a legitimate observation or maybe some other idea about it.
I mean, something simple like that should be enough. Well, I wouldn't say enough, but along with all the other evidence, should kind of tell you just couldn't be a flat disk Earth, or maybe not a flat disk Earth, because they don't really believe in the flat disk Earth.
No, these two cartoons that you're trying to present, you know, the Glober cartoon and the flat disc flying through space, those cartoons are not reality. You got it right. It's not that.
Oh, these are the guys that they were paid to do this, right? And lie about it. Isn't that what I heard?
Who got paid and lied about it?
The ones from this thing you're telling me. I know what this is from.
Oh,
yeah.
These guys were paid to do this and lie about it.
Yeah, he's not even gonna wait. He's just gonna.
I know. I've looked at this many times. I've been presented this so many times.
That's what he wants the audience to do. See, folks.
I've been presented this so many times.
Right? Hey, how much did they go paid? And
don't even take it seriously. For instance, folks, don't listen to the flatties.
Yeah,
no.
I've seen this before.
Because this has been debunked. These guys are liars. Oh, you've colored it now. No one's even going to take it seriously now, brother. Good job.
So you just took it at face value, right? When you seen it, you just took it at face value.
This is, you asked for one test, right? I give you the Marconi.
So this is called being skeptical.
Then I give you the antenna radar test, right? You asked for multiple, right? I give you the first one, Marconi, 3,000 miles. I give you the second one, Marconi over 10,000 miles. You hand wave those. Now I'm giving you the antenna.
Oh,
and
who are these people? Who are these people? Do you know these people?
Who are these people? Let's see. They are
trying to help you understand,
they are researchers.
Real world shit.
They do this for a living for decades and decades.
Unbelievable.
They do all these type of tests. They experts in these fields. Yeah.
Are you sure about
Who
that?
are these people? Are you not sure about it? You're not sure
taking it at are you taking it at face value that these people are who they say they are? Even though I heard that these people were paid to do this and to lie about it.
Imagine researchers getting paid to do something, huh?
Are they real researchers though?
What a surprise.
How do you know?
What a surprise.
How do you know they're real researchers?
People getting paid to do a job. Wow, amazing. That's news for
It seems like you kind of just took this at face value.
That you're the one taking your imagination as face value or imaginary value.
No, actually,
yeah.
I take my own observations at face value that I've gone out and made myself. Have you done that?
You just hand waving the actual field experts that conducted this test, this radio signal, this radar test, right? And they wanted to do this test, and they set up the whole test to see if there was any obstruction from the two antennas. They set up the altitude, the technology, everything they used, the two teams, and they did the test. The two antennas connected. They said there is no obstruction between the two objects. That's the end of the text. And you're saying, no, hand wave.
Well, because my observations tell me something different.
Like a wishy-washy thing that you're doing way too often.
No. My actual observations, like I've gone out with a camera myself to the beach, and they tell me something different. So I can't take the word of something I found on YouTube of some people I don't know and telling me that, oh, they did this test, therefore the Earth is flat.
I'm not claiming it.
I don't know how.
There is no 3,159 miles circumference that is being tested. In this test, they were testing for the curve of drop over distance value, right? With the radius, and they were testing for the radius, looking for it, and they came to the conclusion. They didn't claim. Okay, this proves this shape of the Earth or whatever, but it falsifies the claim of the radius. It does that. So there is no radius that is the radius that you're claiming for the imaginary globe is nowhere to find in reality, and that's being tested so many times. This is the third one I gave you, and you just hand wave it, just like the first
I'm not
two.
hand waving it. I'm just saying you don't know. You're just kind of taking what they're doing at face value.
I'm doing something, right? It's me that I'm wrong. Their
No,
test
you're
doesn't
taking
say
what they're
anything.
doing at face value.
Forget about the radio. Forget about the radio test, the
Let me see if I can
transatlantic
find this.
communication.
I'm gonna go on mute
Forget
real quick,
about
and I'm
the
gonna
radar
find.
test.
I'm
It's
gonna find
me
this.
that there's something wrong with me.
No. Give me a second. I'm gonna go on mute, and I'm gonna research this. I'm gonna find it.
Yeah, find it. They did, I think it was 11 different tests, and you're gonna just discard all of them because you know the globe, the imaginary globe it has to be, because it just has to be. If there's any test that disprove, falsifies the claims of your globe, you're just gonna discard it. I'm gonna give you a fourth one, laser test. So I already gave you transatlantic Marconi, 10,000 miles. That was over 3,000 miles, done multiple times. There's another one from England to Australia, over 10,000 miles. I gave you the radio wave that this guy did at the test to check for the radius, for the curvature. The two laser beams, the two antennas connected. Therefore, there was no obstruction between the antennas, no curvature in the way. You're gonna hand wave that. Laser test, that's the fourth example, because you asked me. So laser tests have falsified the radius many, many times. It has been done by many people, many different groups. Even the military does this by line of sight. So laser tests debunk the claim radius.
Well, talking about the military, I pick up loads out of Douglas, Arizona. It's down on the Mexican border, and there's a military base down there, and they do they practice out there with their equipment. And they've got these trucks they park on the side of the road, and big tall booms that they put their sensors, like 30, 40 feet up in the air. And I stopped one day and was talking to him, and I was like, why you got it all up on the way up in the sky? He says, well, some of these distances we shoot across, the curvature of the earth gets in the way. That's what they told me.
Yeah, he was projecting into the cartoon that you have in your mind, and that's he's projecting this cartoon idea that you believed in, just like him, and saying, "Hey, it makes sense. The globe that we live in, everything is being done on a globe. Everything, even when I'm eating food on my table, the gravity is holding the food on the table. So thank you, gravity, for the food."
Or maybe because when they did it at a lower elevation, it didn't get as far as it did until they put it up higher.
Wow, yeah, maybe there might be hills obstructing, right? But that doesn't mean curvature of the earth traveling across the globe signals.
Yeah, or maybe when they do it over water, they have to put it up on top of the mast because the horizon gets in the way.
Yeah, they did build the towers pretty powerful and kind of high, right? Yes. That doesn't mean globe by any means.
Well, I mean, if it was flat, they wouldn't have to build it up on a tower, now would they?
So you're saying that people don't put towers on top of mountains, on top of high hills? There should be a reason for that, right? Because they don't want things to get in the way, like topography, right?
Well, buildings. See that radar thing that you presented, it contradicts that. It's like if they're shooting 14 miles from 4 feet above the water, you know, that there's something up with that. If they were able to actually do that, yeah, that's interesting.
That is very interesting, right? That if there was a curvature of 8 inches per mile, if there was a horizon, the curve of the Earth between those two antennas, there will be no connection of the antennas. But because in reality, there is no curvature between the antennas connected. It's pretty simple. Good that you figure it out.
Can you post the actual link to that thing you posted, and not just screenshots, please?
Those are screenshots. And
okay, can you post the actual link?
There is most likely a video, and then there is a Portuguese website that has the information as well.
Yeah, I recognize those images. I don't know if it was Jim Pandas or where else I saw it. And I do recall there was a big controversy about it.
Yeah, the big controversy. Yeah, forget about the tests. Just throw everything, throw the baby with the bath water, because there's controversy.
But if it's not legitimate, but if it's not legitimate, that would be of interest to you, wouldn't it? I mean, you'd be interested to know if they were faking it, right?
You're claiming that if someone does a test and then there is somebody claims controversy, someone claimed controversy, that means that the test that they did is not valid because someone claimed controversy.
I mean, just like it would be interesting to me if it was legitimate, it should be interesting to you if it's illegitimate.
No, I don't like gossip or controversy about people's whatever lifestyles or whatever. No, I don't worry about that.
Okay.
So are you saying controversy, therefore the test is invalid?
No, it was something about it was fake. It wasn't.
So you don't know what was fake about the test, but you just saying.
No, I don't. No, I just remember there was something up about it. I don't remember exactly what it was.
So you're just gonna hand wave it and say, "Hey, controversy, therefore it's invalid." And also the laser test that they did over 16 kilometers, and they had another one over 40 kilometers. Controversy, therefore invalid.
So first of all, laser tests. I mean, we all know that lasers are affected by refraction, right? And then in those laser tests, they never actually show how they leveled the laser.
So
whether or not we know the laser beam is parallel with the water, we don't know. I think
you don't know. You're gonna claim you don't know that. Who is we? When you say we, you mean those guys didn't know that? The actual researchers doing this test,
that would be something you want to show, right? That would be something you want to show, that the laser beam is parallel with the ground,
from
right?
these field experts that have been doing this for decades, and you're saying, hey, they don't know better, therefore their tests are invalid.
Wouldn't that be something you want to show? Like, that'd be something pretty important.
You show the claim that they did something wrong. Are you claiming they did something wrong?
That would be something you'd want to show, right? Whether or not the laser was level with the water.
So you're saying these people don't know anything about level? They didn't take this into account.
What I'm saying is what they
had
did
no
was
idea.
they pointed
When they set up their meetings to get together and do these tests over multiple years, because these 11 tests took them months and months, right? And when they set all of this up to be able to accomplish all of these tests, you're saying that they missed level. They didn't think about it. They just escaped their mind.
No, it's because what they did was they had to point the laser down at the horizon so that they can be able to see it. It's not. They never tried to hit a target on the other side.
They actually hit three targets.
They couldn't hit a target.
They actually set up 3 points,
and they never hit any of those targets. No, they didn't. That's a lie.
No, they didn't. They didn't hit the targets.
No, they didn't.
Oh, okay. All right. So I was wrong then, right? Because you don't know which tests these are, but you're pretty sure they missed.
Which one are you talking about? I'm talking about the one from FE Core.
The FE Core one was inconclusive.
Okay, whatever. Eficore, whatever. You've seen Eficore. You're saying it's not valid for you. Okay, whatever. What about these other people that did the laser test? They also invented these other researchers. The same team that I'm showing you with the radio antenna. I mean, there's so many laser tests. Is Eficore the only people that have done laser tests? I don't think so.
Yeah, but
right?
none of them none of them have ever hit a target. Matter of fact, there's one guy there's one guy I know, not personally, but that comes into these discussions that he stopped being a flat earther because of these laser tests, because he was actually there when they conducted it, and they could never get the laser down past, I think, the 3rd floor of the hotel.
So these laser tests never hit their targets?
No, they couldn't. They couldn't. Once they dropped down below the third floor of the hotel, they couldn't see the light anymore.
Wow.
At that distance, the beam would be. How big do you think a beam would be at that distance? You wouldn't be able to hit a target, right? Because the beam would be too wide.
You wouldn't be able to hit a target because the beam is too wide?
Yes,
really?
Beam divergence. Laser light diverges. You have to collimate it, I believe.
Okay. So the laser doesn't hit the target. Therefore,
not a point. Not at a point.
Okay, so then they're wrong. Then, right? It's globe. Earth is a globe.
I'm just saying, laser tests are not a good way to do it. There's other ways that are a lot better.
Wow, amazing.
No, there's better ways to do it.
Okay, so Eficore did improve the globe, right?
No, they didn't prove flat Earth. It's an inconclusive test.
Wait, flat Earth? What the hell is that? A description?
Okay.
I mean the laser.
I know you don't like that connotation, but I mean that's technically that's what it is. You don't believe the Earth is a globe.
Technically,
if there's no curvature, right? If there's no curvature, that means what?
Technically, what you're fighting, you're like an anti-flat earther, so you're fighting a term.
Yeah, I know that. I know that's the new term.
I don't like this term. I don't like this term, and I'm gonna debunk it because this term doesn't apply to my experience, right? You see hills, you see valleys, and that's not flat. Therefore, flat Earth is wrong.
Yeah, because the Earth isn't flat. That's why it's wrong.
And it's not a globe. It's not a cartoon. That's my whole point. It's not a cartoon.
No, it's not. No, it's not a cartoon. Of course, you're
exactly
right.
Exactly. It's not a globe. It's not a disc flying through space. You got it.
It's not a cartoon, no, but it is a globe. We can argue about that.
A globe? You believe the Earth is a globe? Like you believe the Earth is that globe that the teacher points towards when you're like in 1st grade or kindergarten? You believe that's the Earth?
Now we're divulging into childhood now.
But you believe the Earth is a globe? Isn't that a globe?
Well, you believe it's not a globe, right? That's why we're arguing here.
Well, if it was a globe, it will be demonstrated by the test. But the test falsified the globe. At least the globe that you claim,
inconclusive
right?
tests. Inconclusive tests. Yes, inconclusive tests that don't really show anything. And there's better tests out there to do.
Okay. So let's see this one. This one was done in Titicaca, Peru, from Peru to Bolivia. This is 38 kilometers.
He's not going to accept it, James. Yeah, I just have a question. Earth is life.
How do you know it was what's up?
True or false? You're full of excuses. True or false?
No, false. So go ahead. Can you tell me how did they get that distance?
Known distances between the two provinces, right? They know how big the lake is.
Okay.
They know the distances between point A to point B. They can measure. They can travel in the lake from one shore to the next shore, and they have They have systems, GPS to check on that, right? So they can double check, triple check, quadruple check the distances. And
I
yeah, that's the
absolutely agree with
distance.
you. I absolutely agree with you. Where do those distance come? Where do those
Yes,
distance?
I was going to say, can we use those same techniques to determine distances south of the equator?
Wait, we're talking about Lake Titicaca that is south of the equator. So yeah, that's what we're talking
I mean,
about.
if you want to do that, yeah.
So there you go.
What about distances across the ocean in the south? Can we figure those out too?
There you go, from Lake Titicaca, from Juli, Peru to Copacabana, Bolivia. The laser was 2 meters above the water level. They shoot from point A to point B, 33.78 kilometers. And yeah, the laser hit the target from point A to point B.
Wait, how far was that again?
33 kilometers.
33 kilometers. At what? So you said the laser hit a target?
The laser was 2 meters above the water level, and it was from point A to point B.
And you said they hit a target. How big was the beam at 33 miles?
I don't know how big it was.
You might want to look up laser beam divergence. I think at 33 miles, that beam would be pretty big.
Yeah.
So if you're saying the beam hit,
so no wall
target.
of water between the laser and the
Now,
target, right?
Did they hit? Well, how high was the target off the ground?
2 meters.
And you said how big was the target?
How big was the target?
Yeah, how big was the target?
I don't know how big was the target.
Okay. So we don't know exactly if the laser actually hit the target.
Well,
I think at 33 miles.
They claim it did, right? They claim it did.
Okay.
Either
way, we don't know.
You don't know. They know.
Yeah, but do you know?
I mean, I'm going like exactly like you're saying, right? People tell you the Earth is a globe. These people are saying they did the laser test and it connected from point A to point B. Yeah, I believe them.
Well, what I'm saying is at 33 miles, you're not going to hit a target, right? For one.
Why? Because you say so?
Two, and then the beam is going to be way too big to even hit a target.
So they lied. That's your argument.
I mean, hell, if the shoe fits.
Like, we've got to accept that. By now.
Go ahead, Eggshells.
We've got to accept by now. Surely flat earthers are accepting that they lied by now. They said they were going to release their footage like when something important happens in like 2018. Wasn't it? Or 2017 they said they were going to release. I forget, but it's been years.
Who are you talking about?
The FE, are we not talking about FE core?
I think he's talking about a different laser.
You're talking about that.
Oh, so we're talking about FE core's laser test with their super accurate laser aiming device where they shot at a target across a lake.
Was FE core 33 kilometers? 33 kilometers?
I think they had 4 different distances.
I would encourage the audience to look into this themselves rather than listen to writing on eggshells about it. The FE core test. Look it up.
Yeah, we've all looked into it, trust me. Extensively.
And watch Sly Sparkane's video, because he has a voice chat with some of the guys from FE core and they admit this, so you just take it from their mouths. Sly Sparkane has a long series on it. Take it from them.
Yeah, a lot of damage control. Just check it out yourself, folks.
Yes, we've already done that extensively. So thank you.
Did they use the super accurate laser aiming device? No.
You mean the salad?
Yep, the salad.
We're talking about the interview he had. The interview he had with someone from FE core, right?
Yeah.
Mm-hmm.
Let me try and find it. I'm on my phone, but I'll try and find the link. But it's like a 4-part series.
I couldn't help it. I just got so tickled over the salad.
Yes. Yeah, it's called FE Core Can't Laser.
Yeah. I'm trying to look up beam divergence.
Well, that was what the they also had a collimator, but I forget. I think it's something like the laser broke and they couldn't fit the collimator to the new laser, or the collimator broke. I forget which.
Yeah.
So, what's an estimate of like an initial diameter of a laser beam?
Oh, 3 mil.
Like a 3. Let's see, 3. And we'll put a distance. Well, kilometers. What did you say? 33 kilometers? Wait, hold on.
Something like that.
Let's see.
I think that's what it said.
3 distance.
Yeah, the calculator I found, you had to know the power of the laser too.
Yeah.
Yeah, the new claim that they've got, so that like we're up to date with it, is that a beam has a bright spot in the middle, and because they could see a bright spot, they thought, although they couldn't make it hit the target, they were like, "Oh, that's more accurate than actually hitting the target."
Yeah.
Put one of the videos in the chat. That's where he's having yeah, that's the one in which I think he cuts out segments of a call he has with them, and then there is a longer one where you can have the uncut call.
Wait, where are you posting it at? Livestream
VC.
1?
Hang on, I put in Livestream VC. It's just wrong place.
Oh.
You know how they do that for VC text now?
Oh, yeah.
There we go.
Let's see it.
Yes, collimators are used, Regis, to stop that beam divergence. The point being, they make a big song and dance about having this salad and having this collimator, and on the day they don't use either, and they didn't make either of those things clear in their results. They're still in their PDF
You have to
website.
color it before people even get a chance to look at it. That's right. So, folks, just look into it yourself. Don't listen to us.
We've looked into it, man. That's why we're having
We
this
have.
discussion.
That's what we're saying.
Jesus.
I wasn't talking to you, man.
I know you're trying to
I've
address.
looked into it pretty
I was
extensively
talking
as
to
well.
those folks who know that they have critical thinking skills and don't kowtow to the gullible bullshit.
Right. But you're not refuting anything I'm saying. Like, these are serious points against the FE core case,
I'm just
right?
asking for the audience to go look for themselves instead of
Yes.
trust other people.
Yeah,
Like
yes.
yourself.
We're giving them avenues to go in either direction, right? They can look at it from all directions, right? Not just from the flat Earth point
Would
of
it be
view.
acceptable to you that someone of sound mind and body said, you know, that proves to me it's flat? Would that be acceptable in the world for you?
No, because if we know that they're being dishonest, then we have to look at that as well.
Yeah. Okay, as you were, gentlemen, ladies, ladies.
So the thing, but for that person that was speaking was right. Anybody listening should check this for yourself. But check, did they make it clear and did they use the salad? Did they use the collimator? Did they hit the target?
Still
Is the
coloring
picture
it.
they-
You're still trying to color it. So
No,
yeah.
I'm asking
Those are
questions.
questions you
No,
should be
you are,
asking.
and that's okay. It's just I know the audience isn't stupid, so they're not buying.
Those are questions you should be asking, though.
No, the experiment happened. You like it or you don't, and there you go. So people can look at it themselves. But keep trying to perform damage control on it. It's not obvious or anything.
So you want us to look at it. So you want us to look at it, right, and just outright just believe it because they did it. Is that what you're saying?
Sounds similar to what he's implying.
Yeah. FE core is pretty much dissolved at this point.
Yeah.
I think the reason why Sly Sparkane has this video is because he was being skeptical when he watched their video. I think that'd be a good way to do it.
Yeah, be skeptical of both sides, definitely. But you want to know what the claims are that this thing's bunkum, and then go and investigate those claims.
Right.
could well easily be that I turn out to be wrong and all these globers are wrong. They did use the collimator, they did use the salad, they did follow their design as they set it up, and they did hit the target. By their own admission, they didn't release any of their footage or photos of that. Yep. For some reason, they're standing next to a target and they don't film it. That's not just what they said.
I think there was an issue where with their location, and I think he pointed out the location was incorrect because of the location of the moon in one of the shots.
Right. There's certainly one I remember from Sly's video on the ranging shot that I don't know if they already openly said this, but often people share a photo of a laser hitting a target as sort of proof, and then Sly's shows that video. I was like, that's only from a couple of 100 meters away. That was a previous day for testing. I don't know if that's what you're talking about.
I mean, just being able to see the laser isn't enough. You have to actually hit a target.
Well, I mean, if you set out in your experimental design, we want to see if we can see a laser from across a lake, then at least you're following your experimental design. And then we can debate whether the design was good. But they set up a good design that we probably all agree on, and then failed to meet that objective and still called it a win.
Right.
Like saying, hey, Australia's won the World Cup. Well, not in terms of goals and stuff, but, you know, we had a nice time and that's winning.
I think because they say, oh, because they could see it, therefore, you know, it's flat. And I made a little demonstration when I was on Jose's one time that you could have a curved surface, right? And you could shine the laser, on the crest of that surface, of that curved surface, and you could see the light on the other side without actually seeing the source of the light.
Right. Well, just the sort of it bouncing off the top of the
water.
Oh, right.
Yeah, that's why I always ask. Okay, did they level it? Like, is the beam parallel with the water, which it would have to be, right, in a test like this. But I mean, even that wouldn't work because of beam divergence.
Yeah, like, well, I think you can just hit a target without having to make your laser horizontal if you say there should be a hump in the way.
Yeah, but again, I think. Oh shit! Hold on, I'm getting a message. But yeah, if I get a chance, I'm going to try and put that in a video, just showing that you can see a reflection of a laser off of water, and not see the source of the light, just by shining it, you know, on the horizon. And I think a lot of these laser tests, that's literally what's going on. Is they're pointing the laser down at the water, so it's like a flickering off the horizon, and on the other side, they're actually seeing it. So I wanted to get back to the other guy who was talking about distances. If we can measure distance over water in the south. Because that's always a good topic.
I think so.
Johannesburg to Perth, Johannesburg to Sydney, Sydney to
Like,
Santiago. All of those are very interesting distances.
yeah. I was on yesterday, and let me see which flight would that be? QF65, Perth to Johannesburg. That's QF65. Then there's another one, 27, QF27, Sydney to Santiago, and it's in the air. It's flying right now.
Plane full of NASA shills.
I know. It's in flight right now, on its way to Santiago. That'd be a pretty far distance on flat Earth. And whether or not you want to claim that there's some sort of jet streams, those jet streams would have to be pretty fast.
And they would have the reverse to explain the trip back.
Yeah. It's kind of a topic no one really wants to touch anymore. I've actually found a channel that down in Australia at the airport. They do plane spotting, where some guys will be at the airport filming all the aircraft taking off. And if you get it at the right time, you can literally watch this plane take off from Australia, going to to Johannesburg.
There you go. Yeah. So watch that, and then link it up with Skyscanner. Pay $5 to get somebody to go and video it landing and see if it's the same plane.
Yeah, that would be a good. The only thing is, no one in Johannesburg is doing that. There's a lot of airports that actually do that, where they have someone who just go there and film all the airplanes taking off. And there's one in Sydney specifically. I'll drop a link to the channel. Give me a second. Yeah. Yeah, you could find the flight on like Flight Tracker, Flight Radar 24. Find out when it's taken off, or a past flight that took off from Australia. Around, I think they filmed like maybe about 3 hours at a time. And if it's within those 3 hours, you can literally watch that plane take off. Yeah. Sure. So I'll drop it in the VC, and then I'll drop it in text.
I believe that flight, that QF27, if I'm not mistaken, it flies close enough to Antarctica to see the ice from the air.
Yeah, it does.
But yeah, that's what Dr. Bob said. He said he used to catch it.
Said Dr. Bob used to catch it?
Yeah, I think it was somebody like Dr. Bob said they caught that Australia South America flight.
There's a few in this discussion that have taken that flight. One of them is a flat earther.
Hang on, a flat earther has taken that flight.
Yeah, I think his name is Globus. He's actually taken that flight. I think that was before he was a flat earther, though. That's what I was told.
Wait, are you saying that people get on airplanes, therefore globe?
Yeah, they get on airplanes that go a distance that would be impossible on flat Earth.
Or like in a cartoon flat Earth?
Yeah, like a cartoon in your head. Yep.
So in a cartoon in your head, therefore globe.
Yep, just like a cartoon, like Bugs Bunny. Yep.
All right, so yeah, good for you. You believe in cartoons, and
I do.
therefore globe.
I believe in cartoons, don't you? I see them all the time.
You believe you live in a cartoon, therefore globe.
You know, Bugs Bunny, Mickey Mouse.
Yeah, like the ones that gave you the globe, right? That's why you believe in it.
Doesn't this raise any questions with you though?
What raise questions? That a flat earther go in an airplane and flow to Australia or to South America? Wow, amazing.
No. You don't remember back in the day, years ago? Hold on. Yeah, people used to say these flights didn't exist.
Yeah, I've still heard that recently. The flights don't exist. They'll go to the gate and nobody will be getting on.
Who claims this? Who claims this?
I've heard people say that.
So you're talking to those people right now? That's what you're talking to?
We were having a discussion about what have been previous explanations or excuses from flat Earth.
So you're saying that because someone in the past said a flight doesn't exist, therefore globe.
And obviously, if I wanted to say that, I'd just use my math and say that. But Gemsy, is it your position that the flights do exist or don't exist, or what do you think's going on?
Shit. Whatever flights people get in an airplane, go to an airport, get in an airplane, travel to their destination. That doesn't need a globe.
Okay.
Yeah,
so of the flights we're talking about, do you agree that they are taking off, landing and flying where we're told that the distances are correct?
Whichever person is getting in an airplane and reaching their destination, that flight is definitely taking place.
Okay, great. But what about the distance? Do you believe the distance is correct?
The distance between the airport to the other airport? Yeah, it should be correct.
Great. I'm glad you agree with that. Now, let's look at the distance that those two airports are apart from each other on flat Earth.
On what flat Earth? In a cartoon?
Yeah, the one that you guys claim.
That I claim.
Which one do you go by? Which one do you go by?
By reality. I get in an airplane and it travels to another airport. That's the one I claim.
Okay. Which one is that? Which map do you claim? Do you go by? If it's not the globe,
why would I claim a map?
If it's not the globe, then which one are you going to use?
The globe is not a map.
Well, the thing is, Jimsy,
is a globe
once
a map?
Once you get south of the equator, the lines of latitude, the concentric rings get increasingly smaller as you go south. But on a flat Earth, that wouldn't be possible. The lines of latitude would have to be increasingly longer on a flat Earth. So that proposes some interesting challenges for flat Earth to come up with explanations why it's 6,000 miles from Sydney to Santiago rather than 12,000 miles as it would have to be on a flat Earth.
Yeah, the claim distances that you're making up on an imaginary flat Earth, and therefore that's wrong because you imagined it, and that's not reality.
The thing is that those distances, they do match the globe model.
How they gonna match a model, a globe model, if the airplane itself is not the airplane itself is not designed for any globe. The pilot himself operating the aircraft never take into account any globe, and the guy at the ground trying to shoot down the airplane in a case of war never takes account any globe into the equation to shoot down the airplane. So why would you believe there's a globe under the airplane?
Okay, we're not talking about taking any curvature or anything into account. We're simply talking about the distance that the aircraft has traveled.
Yeah,
and
the distance between
the time
point
it
A to
takes to get
point
there.
B in reality is what it is, right?
All
But
right.
that doesn't mean globe.
Okay, so right, I just
Whatever
took a
distance it
flight.
is.
Hold on, I took a flight from Dallas to South Korea, right, and it took about 14 hours.
Yeah, you went to an airport, got in an
Yes.
airplane. The airplane went up, and then it traveled towards the destination, and then
Exactly.
you landed,
Exactly.
and you got off the airplane. Bravo.
Exactly.
Good.
Okay.
Well
now,
done. The way it was designed never took into account any movement of the ground nor any
I don't
curvature.
think that's not what we're talking about. That's not what we're talking about. We're
you're claiming a globe.
specifically talking about distance and time, right?
Yeah,
I took
distance.
that flight. Now there are flights in the southern hemisphere that are roughly the same distance and take about the same amount of time. Now, if you put both of those distances on a flat Earth map, one of them is considerably longer.
So you trying to use an airplane to determine distances, huh?
I mean, you could.
Well,
It's a rough estimation.
Yeah, they fly at a certain speed for a certain amount of time. You can kind of estimate the distance.
Yes.
Okay, so you measure distances with airplanes. Okay.
You can.
I didn't know that. I didn't know people did that, but that's good to know
You
now.
can.
People measure distances with airplanes.
Right? You used to measure distances in the amount of days it took you to get there.
And an airplane is a measuring device. Globe
measuring device. If you play
about it. You could use a car to find out distance. It's speed multiplied by time. You know
to measure the distance.
Yeah.
Yeah, I'm currently going 76 miles an hour. If I stayed that same speed for 1 hour, I could pretty much bet that I drove 76 miles.
Really? Are you gonna go on a straight line in the car 100% all of the time? You're gonna go that distance that you're gonna travel. That distance that you're gonna travel at the end from point A to point B is gonna be accurate because you made it to point B in a straight line in the vehicle.
No,
when
it's
you
just
never travel
distance travel. It's just distance traveled, right? And so in a straight line, it'd be the same thing.
So the distance travel and the distance between point A and point B are different, aren't they?
No, okay. So let's say I'm walking around. I walk around my house, right? And it takes me, I don't know, 3 minutes to walk around my house.
Is that how you drive around your house?
Now the distance it takes me to go that is not going to change, right? Now if I open my door and walk through my house and get get to the back or get to the back to the front, I mean the distance doesn't change.
The distance traveled is different from the distance from point A to point B, isn't it?
I guess you could say that, but either way, if you can still estimate how far you traveled.
But that wouldn't give you the exact distance from point A to point B because you could take a left or right.
No, because you'd have to go in a straight line. I agree.
Exactly.
Well, yeah, but so airplanes, they mostly travel in a straight line.
Okay, from the airport, they go up, they adjust their direction, and then they head towards that direction.
Yeah, and they most of the time, 90 I would say 95% of the time, they're traveling in a straight line.
Unless they're doing like a stop at a different airport, right? They do a stop from a different airport to another. They adjust.
Yeah, that's if they're making stops. Yeah.
Yeah. And if there's a direct flight from one airport to the other airport, the best way will be going on a straight line. Sure.
Well, the transoceanic flights do pretty much fly in a straight line. They don't deviate really.
That's great. That's good. That's I guess the most effective way if you want to like go straight to the point, right? Straight towards the direction that you're trying to go. That makes sense.
Yeah. So they're pretty good indicators.
So I best we falsified that map that most flat earthers like to use.
Falsified a cartoon? Why would ever
the
take
map?
The
You know the map that flat earthers like to use, or the depiction of flat Earth.
No, can you post it?
Oh God, give me. I will post it.
Yeah, post it because.
Well, I would agree with him. You calling it sort of like imaginary because the models are sort of what you imagine them to be like, and then you draw them out from your imagination. So I guess it's kind of imaginary. But how else would you suggest that we represent reality and what we understand to be without drawing it out on a piece of paper?
So that map, you're gonna use it to travel the world. That imaginary map, you're gonna use it to travel.
You could, yeah.
Okay. Wow. Amazing.
Right. So can you see that I posted?
You claiming people use this to travel?
No. Didn't say that.
So what is the point of this whatever
the point
projection?
is the point is, right, is that on the flat Earth, do you see how far away Johannesburg and Sydney are?
On a flat Earth, like you thinking about this cartoon, this flat Earth cartoon?
Yes, the one that most flat earthers like to use. Yes.
I told you that reality is not a cartoon. Didn't I tell you that?
This map is incorrect?
Me claiming this cartoon is not a representation of reality. It's not a representation of reality. Go ahead.
Okay,
so I love what you did with the distances from point A to B, not the same as you traveled. That was great. Somebody's been paying attention.
Yeah, I agree with it.
They're saying that if you get in an airplane from South America to Australia, therefore globe, because it doesn't work on this cartoon that he posted, which is kind of funny.
But you know where it does work? It does work on a globe.
On another cartoon. On another cartoon.
It does work on a globe though. So
in the other cartoon, in this cartoon, it doesn't work.
Jamesy, you don't get it. There's cartoons for every single thing you got to say, partner. We're fucked.
Yeah. Kind of funny.
B-ball, you got a flat Earth map, bro? Let's see it.
Yeah, this is the one you guys post. But then when you guys y'all will post it saying this and this and that and memes and stuff, but then when we show how it doesn't work, and when I do demonstrations like this, then it becomes a straw man, and now we don't have a map model.
Okay, so I claim that this map is a representation of travel distances from South America or whatever data. I think the point, the blue point that you put it there.
Then. No, listen, you should call us out on our bullshit and don't let us do this flip flop with maps, right? Fucking A. How about nobody claim a map ever? Flat Earthers don't claim a map, right? Anybody out there claiming a map, stop it. And there we go.
What? Aren't we trying to discern the map?
If you actually have a map, let's see it.
Well, I mean, I would think at least like Indonesia is to the west of Malaysia. I think that that part of Asia is to the east of India, and India is to the east of Africa, and Africa is to the east of America. Would we disagree with that like basic layout?
So we do agree that this cartoon he presented is not reality, right? We know, everybody here knows that.
Yes, we know that.
So you're representing that for debunking the cartoon? I mean, yeah, debunk.
So we know. Okay, so we agree that this is ridiculous, right?
Yeah. There's no way if someone is presenting cartoons as reality, it's definitely ridiculous.
Right. There's no way that on this flat Earth, these two flights can take roughly the same amount of time and the same amount of distance.
Now you're presenting another cartoon, which is definitely ridiculous.
This map right here, the one I'm presenting, this is the one that it actually matches because these distances are what they say they are, and
so you're going to keep going after things that nobody believes in whole. Listen,
in the time. Hold on, I'm not done. You're cutting me off. They fly the distance and the time that it would take on this model.
That's wonderful. We don't claim a model.
Okay.
So what? So you're saying that people reach a destination. The other map is incorrect, right? Therefore, your cartoon is correct because someone got on an airplane and reached their destination. Wow, amazing.
Yes, which matches this model that I posted. Yes.
Washes the model of a globe that is nowhere to be found in reality. I mean, that doesn't add up.
But yet it matches it. And you can say whatever you want, but it matches this model right here.
You're claiming the distance, but the airplane itself is constructed never to take into account the globe. The pilot never takes into account the globe. The operator of the aircraft never uses the globe for anything. And you're saying, you're here sitting, hey, cartoons, therefore airplanes work on a cartoon, therefore a globe.
Again, no one. That's a different issue. You want to talk about how
that's your issue.
pilot,
you're claiming a cartoon, bro.
You want to say how the pilot doesn't take curvature into account. I don't care what argument you want to try and make about that. We're talking about the distances involved between the two airports. On the proposed flat Earth map, they would have to be farther apart.
The proposed flat Earth map that you're imagining and you're proposing, and the proposed globe cartoon that you're proposing and claiming or whatever. And people travel using these cartoons.
Yeah, full of excuses, cartoons for everything. I'll check you guys later.
See you, man.
It's not an excuse. It matches this model. Whether you want to claim it doesn't, I mean, that's on you. But we see the distances on. We take Google Earth. You measure the distance, then you look at the flight time, right, and the speed they're going, and it usually matches this model.
People travel from point A to point B in reality, and they accomplish it, no problem. They never take into account any globe ever to accomplish that.
It's not about taking into account. It's the distances they're taking into account.
Exactly, that's the point.
The distances.
That there is no globe taken into account for anything.
On a
Therefore,
globe,
no globe needed to make your claim.
On a globe of our size, right, of the size that's been measured, this distance matches the flight time and the posted distance that the flight that the airplane traveled. It doesn't match anything else.
So that cartoon that you posted,
do you have anything to combat? Do you have anything?
I can grab this cartoon and travel towards the airport that I want to go to.
Yes. Do you have anything to rebut that?
To rebut your cartoon? No, I don't have another cartoon to rebut your cartoon now.
Okay, so this cartoon actually matches reality then, right?
No, cartoons are not reality. Incorrect.
Okay, well, for one, the distance is what matters.
Yeah, people travel over distances, yes.
Yeah, exactly. And they'd have to travel farther on flat Earth.
That doesn't mean globe.
That means this map matches reality. That's what that means.
That means people travel over distances, correct.
Mm-hmm.
But
over the globe, which matches reality.
The globe doesn't match reality. You will have to throw all of your experiences, all of your senses, all of the technology developed in the whole world to claim a globe. So the globe is
according to who?
The globe is
the
globe is nonsense. Nonsense.
According to who?
According to you. Not nonsense. It's not nonsense, though.
It is nonsense because you will have to go to your experience, what your senses are telling you, your observations, the way airplanes are designed.
My observations tell me that the surface of water is curved. That's what my observations tell me. Do you have any observations that tell you different?
You've seen the curve with your eyes?
Yeah, I have. Now, left to right, no, but front to back, yes.
So it's a slope.
I have seen left to right. What?
I imagine. I think that when you look out of the airplane window, you see a curve, right?
No, you don't really. I've never seen that. No.
Oh, so you've never seen the curve? Okay.
No,
I agree.
Not there. No, you wouldn't see it'd be really hard to see.
Where have you experienced the curve? Where?
The observations that I've taken in Hawaii.
And from where?
From Barber's Point to Waikiki.
And you observed the curve?
Yes, I've observed the effects of curvature.
Oh, the effects of curvature.
Mm-hmm.
How is that?
That obstruction thing,
It's a thing you spent a bit of time on before, like the FA call. We've got to be able to accept that from them. We've got to be able to accept it from either side, I would think.
So you basically confirm your bias. I don't see something, therefore globe.
No, it's I see buildings, right? But I don't see the entire building.
You don't see the entire building, therefore globe.
His line of sight hits the building at like 150 feet up the building.
And the building is tilting with the globe's curvature, therefore globe.
I don't think you'd be able to measure the tilting, but I guess there'd be some. Yeah, sure.
But you wouldn't be able to measure it, just like the curvature.
That's
No
almost
tilting,
like
no
saying.
curvature. Hey,
That's almost
no,
like saying
no
you got one.
curvature, no tilting, no movement of the ground, therefore curving, spinning globe.
No, you see water obstructing the building, right? Therefore, there's something in the way.
There is something in the way, huh? Therefore globe. Therefore
yeah,
globe.
therefore a curved surface. Yeah.
Yeah. There's nothing else. The only thing that could be there is the curvature of the globe.
Well, I mean, matches what I would suspect the curved surface would do.
Yeah, confirmation bias.
Just like when you look at a sunset and the sun goes below the horizon, just like when you look at the moon goes below the horizon. Same thing.
There couldn't be anything else happening. Therefore, globe.
No. I mean, if you want to invent something that would match, I mean, you could try. I haven't seen anybody do anything yet.
Therefore, the cartoon that you never experienced, never seen for yourself, never measured, no test can give you this cartoon. But since you imagine it's a globe, therefore globe.
No, I don't have to imagine. I can go out and see it for myself. I can see its effects of curvature.
Like you just imagine the effects, therefore globe.
No, I don't have to imagine the effects. I can see the effects with my eyes that I've filmed with my camera.
Okay.
Like anything you're trying to say now, with like, you're just confirming your bias, opens you up to go, well, that's the same on the other side. Except I'm guessing that this life releases results. Did you Earth is Life, or are you secretly? Did you keep your results, or have you released them to the public?
What results?
Of your observation at Waikiki.
Oh, I post them all the time. I'm waiting for him to ask me to post them.
Yeah, so we've got two people. Well, Jeremy said you just went out and confirmed your bias, but if that's the excuse, then nobody can ever measure anything. Right. So, but we've got two groups of people, FE Core and you. One did what they said they would and released their results, and another didn't and won't show us.
He himself said that he sees the effects, therefore globe. He said it himself.
Sure, that's what any of the existing tests. That's what the black swan is doing, looking for an effect and seeing if it sees it.
Okay. So for one, what you're trying to do, you're trying to straw man me, right? So I can take what I've seen, right, the effects that I've seen with my own eyes. Then I can look at other people's observations, what they've seen, and I can compare that to sunsets. I can compare that to what the moon does, and I can put all those things together, and none of them equal flat Earth.
No, none of them equal the cartoon that you imagine about flat Earth.
I think you love talking about cartoons. What is your favorite cartoon?
That is your whole argument. Cartoons.
Well, that's
what do you have to present?
The rest of us can do.
Yeah, what do you have to present to go against what I'm saying? My bad, eggshells. Go ahead.
No, I'm just saying that you're making cogent points, and Gemsy wants to keep saying cartoon and try to sort of reduce it to a soundbite rather than engaging the substance of the discussion.
Yeah, pretty much. So, and I'm seeing these pictures in the chat. So, for one, the one with the Legos, that table is literally, you can literally see that table is not perfectly flat. That's
the
Legos of the Earth.
The Legos on the table, those Legos are lined up in a curve. It's an illusion.
Exactly. Also, that hallway, that concrete in that hallway, it's not perfectly flat. How do we know that's perfectly flat?
You don't know because you're on a globe, right? In your mind, you think that table is actually curving with the curvature of the Earth.
You can tell because the half of the car is blocked. What are you talking about?
Yeah, there's nothing else that can cause that besides the curvature of the Earth.
No, the table is uneven. Either there's a part of the table that's higher than the other, or the table is actually curved.
Yeah. Therefore, globe.
Therefore, curved table.
Yeah. You got it, bro.
So I could literally line up some Legos on a table and show that on a flat table there should be no reason that the end of it will be cut off, unless you're putting your camera below the edge of the table, or the table isn't perfectly flat.
So this observation is only possible because the table is curving.
Yes.
Yeah, of course. We all make curving tables for a reason.
Right.
What about my picture where the sun is halfway set?
That's a good one.
We know it's not perspective. Perspective makes things smaller, and also the bottom of the sun is closer to my eye than the top of the sun, and so therefore it must be some other reason that the bottom of the sun is not visible.
What could it be? What could be the only reason? The only one?
Something physical is blocking the view to the bottom of the sun.
I mean, the sunset is probably the most prominent and perfect example of obstruction due to curvature.
And historically, it's what has convinced many people that the Earth is not flat. Now, in the really ancient days, the people would say that the Earth was flat and the sun was going beneath the Earth. We know that's not true now because of time zones, because when the sun sets for me here in California, people in Japan and Hawaii can still see it high in the sky. But ancient people didn't understand that, 3,000 years ago, they didn't know about time zones.
They didn't know better.
Now we know better.
I mean, that's a pretty obvious one, right? The sun going below the horizon. I mean, how else would that happen? And then if you have let's say you have a boat that's like on the horizon, then that means your eyes, the boat, and the sun are all in line.
Well, that's a good point. Like if there's a boat right in the middle of the sun in that picture.
Yeah, I think I have one. Let me see if I can find it. Here's a good one.
I've gotten some weird excuses for this one, but what's his name? Tony brought this up at one point, and I thought it was a pretty good argument. But if you take the angular resolution of something like Mount Everest, and just like the Mount Conagu image, like you can see the silhouette because the sun's behind it. If the sun is behind something, or if the sun is visible on the horizon, and there's an object intersecting it, that should be there, but you don't see it because it's too far away for whatever reason. If it's an object that's big enough to be to have a big enough angular size to see, and the sun is visible, and it should be and it's on the horizon, then surely it should be silhouetting that object. So there's many places that should see large objects like Mount Everest on certain days throughout the year.
Just like this light's leg, right? It's behind the curvature and the lady. Those legs are behind the curvature.
Yeah. How do you know that whatever they're walking on is perfectly flat? How do you know there's not like a hill right there?
Yeah, this is definitely the phenomena that we see here is because of the curvature of the Earth.
No, it's because of the curvature of the road.
The road is curved. It's a hill.
The road is curving. Yeah.
Yes,
okay,
yes.
Okay.
It's a pretty clear picture, though. There's no atmospheric refraction going on there. That's good.
Yeah, there's no
miraging at all.
No miraging is the curvature of the Earth.
Coach, were you there for my debate a couple hours ago?
Yeah,
I brought up this sunset thing. Yeah, any comments? I was curious what you thought of that debate.
Where did you debate?
Who's in here?
Earth Awakenings here with Waterworld or Jim.
The guy who wants to debate me. The guy who wants to debate me on next Saturday. Goodness.
Maybe.
The guy who says we are all working for the devil.
Yes.
What's happening in this one? What's happening in this one?
The sun is going below the horizon, and there's something in front of the sun.
What is that mountain in front of the sun? What is it?
I don't know. Is it
part
looks
of
like
the
an
earth?
island or something?
Okay, so what is that light below the mountain? Why do we see that light in front of the mountain?
Probably because there's some sort of miraging going on.
Okay. Okay. So it's not that the sun is in front of the mountain. That's why we see light in front of the mountain.
No, there's like probably a mirage going on.
So the sun is behind the mountain?
Yes, the sun is behind the mountain.
Okay, okay. Cool.
Well, if the sun was in front of the mountain, you'd run into it, I guess.
Yeah.
It certainly builds strength for the case that the sun is local.
Well,
what is happening on this one?
Miraging.
What is happening with? So the vehicles are going behind the curvature of the Earth.
No, the heat off the surface of the road is creating that illusion or that mirage.
Okay. So is this one? Is this car and this one is it going behind the curvature?
No, it's not going behind the curvature. The car is not going behind the curvature.
So what is that?
I like you're continuing to show these effects, right? But we know what's going on in these images, right?
So what is that light that is that light that is below the sun that is going down?
It's just a reflection. It's a mirage.
Oh, it's just it is a reflection, huh?
The thing is, you don't always see that when you look at sunsets.
You know what do happen to cars? What does happen to cars? As they go away from you, they get smaller.
Yeah, they get smaller.
Yeah, that doesn't happen to the sun.
The sun doesn't get smaller ever.
The sun's the same size at sunset as it is at noon.
Yeah, it's half a degree all the time.
But please do show us a picture of it going into some clouds and becoming unresolvable.
And what's happening on this one is that
it got smaller. You see that? Which we don't see in reality. That's what happened.
Yeah. It's going behind the curvature of the Earth?
No. Someone put a Fresnel lens in front of the sun to try and mimic the atmosphere. And even with doing that, he still debunked himself because it shows that the sun is still getting smaller in this observation. So that doesn't work either.
But it is pretty cool premise and execution, I think.
I give
Fresnel
him that.
lens.
It's a good effort.
Well, you can't get that working at 360 degrees around you. You can only get that working in one direction if you're using a lens.
Right. So you're batting 1,000, man. What you got next?
I think Jesse wanted to add something.
Oh, I was just going to say that Skiba's demonstration is very cute, but if another observer was standing a couple feet to the left or the right, it wouldn't work for him. It would be all weird and distorted.
Exactly.
Hey,
yeah, I didn't mean there are problems with
Go
it.
ahead,
I just
go
meant
ahead,
like
go ahead,
it's a
Jess.
pretty cool test.
So they might have
Code-
heard that. You might have to say it again next, Joseph.
No, good. Not that interesting.
Well, I was only trying.
Koso, I'd be interested to hear what you thought of the debate.
Yeah, I was gonna say I heard the debate. I don't know if I heard that part though, so you might have to reiterate your that argument.
I just meant in general, like what you heard.
Oh, in general, I mean, I thought it was fine. I mean, you and Waterworld have a unique debate though, right? Because you have I heard of Waterworld also do a debate, like a biblical, another biblical cosmology sort of debate.
Right.
It was with another flat earther, but yeah, with you and him, I think you guys just kind of you guys have a unique debate. I think the points you made though were sound, and I think that he underestimated you because he was surprised even that you knew the reason why seasons existed. So I was like, he was impressed. He was impressed that you that you knew that. So I don't think he had very good arguments at all. So I just you came with the stuff.
I'm gonna have to listen to that.
Well, thanks. Yeah, no, it was fun.
Unfortunately, yeah, it'd be interesting if somebody would actually go over to the, the actual, because I mean, you brought tests and that kind of stuff, and a lot of times that stuff's not gone over, scrutinized by the other side as much as it should be. Like usually they just write it off. Yeah.
Right. I think I think that's true. They do.
Call it cartoons, that kind of thing.
Mm-hmm.
Cartoons or
everything's got to be a cartoon.
No, but there was another part that he did a classic argument, and actually that was one part I thought you answered fairly well, because he said something about using the sky to measure the ground, and then you brought up how we're talking about, I forget what the example was, but you said like talking about things like how the sun looks like in the sky or eclipses and this kind of stuff, or the shadows made on the ground, and so it's like you have to kind of talk about the stuff in the sky. I forgot the example that you gave because it was actually much better than any of the ones I just used.
Oh, but I said if you're in a train, it makes sense to look outside the window to see if the train is moving.
Right.
Yeah.
Yes, I've used one like that before. If I want to know what my car's doing, I use the windscreen.
I like that one too.
Speedo might give me some information, but the windscreen will give me more.
Well, the funny part is that, when you break it down to like the assumption of the observation. So it's like if you take the base observation that we see the sky moving, and at that point you have to decide if it's the sky moving or if it's the Earth moving. And then they say the base assumption the axiom should be that the Earth is still and the sky is moving. Well, in any other example, like if you put yourself in any other example, like you're on a ship that's moving steadily, or a train that's moving steadily, and you look and you see that everything out the window everything is moving past you, right? Then it would actually be the false assumption to assume that you were stationary and everything else was moving around you, and almost every other example. So
well, for me, it's easier to imagine that the Earth is a rotating sphere than it is to imagine the entire universe is somehow moving.
Yeah, that's a good point. Me too.
that does involve accepting the distances and shit. But that's why any of those quotes that people bring up of like Einstein and Hubble, or people saying that you can't test whether it's us or the Earth moving.
Quote unquote people.
Say what? Oh yeah, but the
people. Let's call him people.
Yeah, I didn't want to say exactly. I didn't want to say name specific, but either way. So Einstein, when he brings it up, he obviously accepts the distances, and once you accept the distances and the other aspects of those measurements, like I said, like distances, for example, you already have problems trying to explain Neptune's orbit, because there's no way it can be orbiting around the Earth at its distance. It'd be going faster than the speed of light.
But what if space-time is also orbiting the Earth? At that distance, I mean, it isn't like the speed of light thing about like traversing the space-time faster than speed of light? The thing you can't do?
You're a trip.
Well, that's what I thought it was, at least.
Wait, Neptune is far enough to be the speed of light?
Yeah, I think I did a math not too long ago, and I was trying to see if Saturn would be, and I'm pretty sure I found Neptune.
Yeah, you need a circle with a circumference of one light day, I guess.
Right. Let me do it again just to make sure.
Yeah, that seems like it could be pretty big.
Well,
but Neptune's pretty far, so you might be right.
Does that thing work? Like, if the fabric of space-time of the whole universe is also rotating around the Earth?
I was trying to imagine that when you said that, because it's true that the only reason why space can be moving faster, like space-time can be moving faster, and so, technically there's that contradiction. It's, distant objects can be moving further away from you at the speed of light. It's like a space is expanding everywhere. I'm trying to imagine like a rotating space-time.
Yes, that's the thing. I mean, we were basically rotating the frame of reference. So, in respect to that frame of reference that is rotating, there is nothing faster than the speed of light.
I don't know.
I mean, know that there's this thing like things can drag space with it, right?
Yeah, that's true. But
so if the whole universe is rotating around the Earth, it's also dragging the whole space-time around the Earth. So as long as it drags space-time with it, it's not crossing it faster than the speed of light.
You guys all know.
When did the idea of space is fake and you can't go out there and it's just all lights, when did that come around? Was that like OG flat Earth stuff, or was it after these arguments got presented that it started being like, you can't look at the sky anymore?
I'm not the right person.
Well, I think once you accept the stuff in the sky are real things, there's just too much evidence. Too much evidence.
Yeah, that's why I'm asking. Like, if the original, back in, wasn't it like 2012 when it first started taking off? If those OG flat earthers were also space deniers.
I mean, gravity's always been contended. I remember what's his name, Math Powerland, the first person I heard, who was around back then. He used to say like gravity's just a theory and stuff like that. I'm not sure about space. Have you seen Math Powerland's that video that he does like a stand-up routine? That was like the classic. That was the first video I ever saw, and I saw it way before I got into this.
Yeah, I think I saw that.
He's sitting up there and he's claiming to be an NASA artist. He's not, but he's showing pictures like those classic pictures of like frying pans and stuff like that, and he's teasing people and claiming it's stuff in space, and then saying that they could just fake that stuff just by zooming in. You would never know.
Did you see when he accused Eric Dubay and Mark Sargent of stealing his intellectual property?
Yeah, that's whenever
I was ranting.
So I was gonna go down a rabbit hole. I had a conspiracy theory that he was the real psyop was that faking the flat Earth through Math Powerland, and then Math Powerland kind of was confirming it by accusing those two people of being shills. It would seem like he's only making that claim because he was he was a shill put forth, presenting the flat Earth and then they kind of follow him. But all three of them have kind of shitty arguments. They all seem inauthentic.
Yeah.
I feel like
being flat earthers, it was all a joke, and you guys fell for it.
Well, that's what somebody was originally saying to me about Math Powerland. They're like, he's not an actual flat earther; it was just a comedy thing.
Yeah, somebody took it and ran with it. And that's why we're here now.
Coach, I posted the thing about the size of a light day circle.
Oh yeah, that's right. I was like, wasn't I supposed to be doing something? Yeah.
No, I did it already. It's in the chat.
Can't remember what I was doing. And I remember when I did that, I had done it real quickly, so I could have gotten it wrong.
Yeah. So one light day is 173 AU. A circle of a circumference of 173 AU would have a radius of 27.5 AU, and Neptune's orbit is about 30. So Neptune's orbit is too far.
Oh yeah, right, exactly. Yeah. So once they discovered Neptune's orbit, which was it in the early 1800s or whenever it was. I think it was early 1800s, late 1700s. But yeah, they Earth was stationary.
Yeah, well, the thing that was mentioned that them relativity like allows for Mach's principle to work.
Yeah,
was that idea that if everything is rotating and it's dragging space-time with it, then space-time is rotating around the Earth, so that should all work the same.
Okay, so I understood it as, and actually there's many interpretations of Mach's principle. That's what I forgot that I was going to bring up. Was I was going to ask you guys if you know Mach's principle, but the way I understood Mach's principle, or the argument that seemed compelling to most of the people after relativity had been suggested, was the idea of the same thing that gravity's doing, basically. So it's not. I don't know if it's the space time that was spinning around. I think it was the effects of curved space time, like the same gravitational attraction that would apply to those same distant objects. If the entire universe were spinning around, then it would be causing the same. It would cause the same gravitational effects onto the Earth, and it would make it seem like the Earth was spinning around, basically. But it seems absurd. It almost seems absurd to even suggest.
Well, yeah, think that fourth dimension is hard to kind of incorporate in the analysis, but if you think of time, everyone's traveling through time at the exact same rate, because time is just progress of existence for everything. But time slows down around mass. So that means your path will deviate from a straight line, but you'll still be inertial. You won't be feeling any. There will be enough forces acting on the actual geodesics have curved due to the warping of space-time. So in order for you to be not on the curve, that will invoke a force. So if you suddenly stop on the Earth, then everything is accelerating in that frame because you're not following space-time anymore. You've altered your path. You're not following that geodesic path anymore. You've gone a different direction, and that change of direction is the same thing as how acceleration works, with just change of direction rather than a speed change. It's hard to put it in words. I've been challenged with the last few days to try to figure out some analogy or some way of explaining it, so that someone that doesn't really understand the fourth dimension can actually understand what space-time is doing and conceptualize it.
I started making an animation the other day, but I ended up getting confused halfway through making it.
Well, it was a good. I actually, because it made people think. It made me think actually about it. But the problem was when you told me they were all accelerating in it. Then you guys say, well, what causes that acceleration? Then it goes back to space time.
Well, that was a different. I never showed the one I was making was a 3D one, but I never shared it or anything. No, but that one that I was showing was strictly supposed to show what relativity does, not even general relativity.
Yeah, but the object itself was accelerating. The object that was stationary had the object accelerating to it, and the other object that was accelerating to the sun as well was accelerating. So that's not really what happens. Is what we see, and the effect is this curving of space-time, curving of time, and that curving of space-time is directly related to the slowing of time near the mass, and that's what causes the curve.
Yeah, well, the curved path, whatever. That's what I was started to make that I never shared. I made like a 2-dimensional space, and then made the 3rd dimension time, and was showing an object moving through the 2 dimensions of space, or no, moving through time constantly. And then as it's moving through time constantly, its path through space becomes warped because of the distance or the difference of, like, let's say it's a 3-dimensional object, like 2 points on that 3-dimensional object, they're going to have 2 different rates of time. They're going to experience 2 different rates of time depending on which side is closer to the massive object. And so right. that inequivalent movement through time gives you the effect of being attracted to that object. I started making that, and I guess I don't know. I did something that messed it up, and it confused the whole point, so I just gave up on it.
Well, the other thing about, if you look at the equation of space-time, it actually replaces the acceleration. So basically says, I think it was a video that talked about it too, that you have to accelerate just to remain stationary. The acceleration has to happen, otherwise you can't be stationary or inertial.
What do you mean by that? Hey, also, go ahead. Sorry.
The part of the equation for space-time curvature, and then you have time dilation, and so those two components is equivalent to. It can be substituted for F equals ma, or gravity, force of gravity equals m times g.
Okay, I was going to ask you guys if anybody's familiar with the Mixon-Gale experiment, Gale Pearson.
I was going to ask you guys for
but I
help.
don't know.
You said Bacon?
Do what, Bacon?
Yeah, I was going to ask for some help. My girlfriend sent me a physics question that she was trying to solve, and then I solved and sent her back, and it turned out my answer was wrong. So I know less physics than I thought I did. So maybe you guys can help me out here. If you're interested, it's okay. Let me Google some words here, because my vocabulary sucks. Right. So there's a swing. Is that how you call this thing I draw?
Yeah.
Yeah. So there's a boy that is swinging there, and he goes all the way up. Like he goes as high as 90 degrees, and he weighs 24 kilograms. And the question is, what's the force on the ropes? What's the highest force on the ropes when he's swinging?
At the bottom?
Yes.
Oh, how much?
Yeah, how much? I got 240 newtons, but apparently that's wrong.
What's the length of the rope?
It
doesn't say. Apparently it's irrelevant.
No, you need to know the length of the rope, because that tells you the period. The period will tell you how far he traveled. Then you can figure out what the force would be based on the change of angular, the change in angular angular velocity.
But
would it be two G's?
Yeah, a longer rope would be. I don't know. I think the length of the rope cancels out in the equations. I don't think it's relevant.
Yeah, you think you're right. Yeah, I think you're right, because it's pi r squared.
Yeah, when I did it canceled out, but I still think I got the wrong answer.
And you want to know the greatest force, the greatest force acting on the rope?
Yeah, the question is the father of this kid wants to build this swing, and then he wants to calculate what's the maximum force that's going to be exerting the ropes, and he wants to buy a rope in which the force that snaps it is 25% greater than what physics tells the boys.
Actually, it does. It depends on what's the mass of what's the gal, the person.
It's 24 kilograms.
Oh, that's the guy. That's the guy's weight. Okay, so you have 24 kilograms.
Yeah.
And if the 24 kilograms was on a longer rope, period would be different. Would there be offsetting math there for the longer rope?
And he asks to use the gravitational acceleration as 10 meters per second squared instead of 9.8. Right. As all engineers do, I guess.
How did you get 240? You got 240 newtons because you just used
10.
You just used his weight at the bottom then.
Yeah. No, I used the formulas for. I assume that when he's in the 90-degree position, like in the highest point, that's when he's kinetic energy is 0 and his potential gravitational energy is the maximum. So I calculated what's the gravitational potential energy at that height using d as the length of the rope. Like it just use the variable, and I did the formula for the kinetic energy when he's in the bottom to get the speed, and then when I used like the formula for centrifugal force because he's making like a circular path,
Yeah.
And what would be the centripetal force needed to keep him in the circular path? Then the d canceled out, and I got it should be the mass times gravity times 2.
No, but I thought you said 200. I thought you said 240 newtons. You said
240 total, and then you have to split in 2, I guess, because each rope is gonna do half the work, right?
Oh, I see what you're saying.
Because there are 2 ropes, yeah.
You're saying, okay, I see what you're saying. You said you did, you said you did 2, so you got 480.
480, yeah.
Okay, so it's basically twice his weight, but then split in half because he's using 2 ropes. That's what you got it. This is what I'm saying, because he did all that stuff, but that's basically just twice his weight, then, right?
Yeah, it's just the force when he's not swinging, which sounds wrong, right?
So the answer, what was the answer?
It was 300 newtons. Because the question isn't how much force he makes, is because the father wants to buy a rope in which you need 25% more force to snap it. So because I got 240, I added 25%, which is 60, and that gave me 300. So I thought the answer was 300, and it says wrong. It says the answer is 450 newtons.
Per rope?
For the rope, yeah.
Each one or the total?
Each one.
Total would be 800. Total is going to be 800. If the answer is 450, then total would be 800. Yeah.
900
times 2, 900.
No, because the 25% more. Well, yeah. So I guess 900, but yeah. But if you take out the 25% more, then
I think you already included in 25%.
Well, yeah, no. That's what I'm saying. Yeah, go ahead.
I'll pose the question.
Yeah, because if you're saying the answer is 25% more, then I just took 25% more off, and then 400, and then 400 times 2.
I hope you guys know Portuguese. Just kidding. Let me translate that.
Yeah, how are we supposed to read this, man?
Yeah, well, didn't expect. I'm translating. Just a sec. Okay, I hope Google Translator did it right. Let me check. Yeah, I translated that. Oh, yeah, I forgot the question. So the question is, what's the breaking tension. What's the breaking tension of the chosen rope or cord? Oh, you guys use the word cord for rope? Does that work?
Fine, yeah.
Cord, fine, yeah.
I didn't know that. Cord. Because we say cord. Yeah, I remember my first physics exam in college. The first answer I got wrong was exactly about circular motion.
Yeah, they're tricky.
Mm-hmm. Remember the 4 points distances experiment?
Yeah.
I did a small web page to quickly calculate the difference between flat and sphere for any distances.
Oh, okay. Okay. Yeah.
You input 5 distances and you leave out one of the diagonals.
Right.
And it calculates it. I just posted it. You can switch between flat and spherical surface. And then for the spherical surface, you can input a radius. And then you can compare
I see,
both.
yeah.
And
I've done something like this before, but I forgot how I. What did I do? I think I just had to solve it by hand every time.
Right. Yeah, that does that automatically.
All right, there you go.
So was the acceleration of the guy on the swing twice the weight at the bottom? Is that right?
I don't know because I got the answer wrong. So
Well, it's not twice his weight because it would be it's supposed to be what 240 and it's 360 according to this thing. So or 180. Hold on.
That's a very, very old memory. I was just thinking that it would be twice.
Well, that's what
twice
Bacon
gravity.
That's what Bacon had originally provided, and it was more than that for some reason. 50% more than that. Is that right, Bacon? Because you guessed 300. Because 300, like I said, would be twice his weight. Well, twice his weight plus 25%.
Yeah, exactly. Yeah, divided by 2 because it's 1 for each rope.
I already divided it by 2.
Okay.
Because twice his weight would be 480.
Right. So if the answer is, well, let me see. I forgot what the answer is.
Answer is 450.
Yeah, I think it is.
Who knows?
Yeah, it says here it's 450. It's D. D is 450. So 450 for each rope, I guess, which would mean the total force plus 25% is 900. If I divide 900 by 1.25, I get 720. So 720 newtons should be how much force.
Oh, well, that's correct. That'll give you the 450.
Yeah, I'm backward.
Oh, you're reverse doing okay, yeah.
Yeah, so I gotta end up with 720. That should be the force that the kid's making when he's in the bottom.
So I'm reading New Perspectives things he's posted about the Great Circle route.
I'm not sure if I want to read that. Okay, let's do it.
The first sentence alone is crazy. I don't know what does it mean. It says the black ball is moving inertially straight and uniform. What does that mean?
Where does it say that?
It's the very first sentence that we posted. I'll check it out. I'll be right back. I'm gonna read this one.
Whenever I look at an article that he posts and I start reading it, it makes no sense, and I find a little closer, and I find out it's that Brenner guy, because all the guy does is post nonsensical garbage. It's really
Yeah, but you said you debated this guy?
Yeah, on offline, off the server. He is completely wackadoodle. And I was like, I kept on saying, you went to engineering school. You're a mechanical engineer. How do you know you don't know the basic? I mean, just basic first year.
He's a mechanical engineer.
He's a degree mechanical engineer,
but
from a foreign country. Yeah, and the things you're saying makes absolutely no sense. There's nothing that makes any sense. There's no coherent thought in your description. And then he starts going back to the Ken Wheeler description of things when it comes into magnetism, accelerated dielectric. What was it? Coherent dielectric acceleration equals magnetism. Oh, now you're a Ken Wheeler disciple. I mean, everything he says was just garbage, complete utter garbage.
Maybe he's a train conductor. Don't they call them engineers?
Yeah, probably.
Oh, this question is from the national exam in Brazil. It's the exam everyone takes to get into universities. That was the first question of this year's exam. And that's for people that just left high school. That's not an easy question.
I mean, I still don't understand the justification.
For people who just left high school.
I don't understand the justification for the weight increase, because it's technically what, twice?
Well, just think about it. If you want to rotate around something, you want to have your distance that fixed, the faster you rotate, the bigger is your centripetal acceleration. So bigger is the force required for you to have that circular motion. So if the kid isn't swinging, it's just there sitting, then the force is just his weight. But as soon as he starts swinging, that requires more force on the ropes.
Yeah, but it's not going to be dependent on the length of the rope.
Apparently not.
Kosho, oh my God, I'm reading the first page of that. He's one of these clowns that thinks that if you're on the Earth and a certain latitude, here's your tangential velocity, then you should add that to the plane speed and get to places that much faster. This is where the flaw in logic is so apparent, deep, and large that it's unimaginable this person even went to school, especially this day and age. And he actually spent the time to type something out and do graphics on the fundamental concept, the foundation of his logic that is so flawed. It's like the guy has IQ of 50, or he's a fifth grader. You want to say, hey, just forget about this, and he should say, oh shoot, God, I wasn't thinking, was I? It's like that kind of obvious mistake. This is the guy that New Perspective is quoting constantly. Such a clown.
Oh, so the guy the New Perspective is quoting is the one that has an engineer.
Yeah, New Perspective doesn't come up with this stuff by himself. He latches on the coattails of this knucklehead called Michael Brenner, who's a complete knucklehead, and he posts these of his writings, which are endless and meaningless and completely riddled with illogical conclusions and misnomers and ignorance.
Can I give you some advice, Enik?
Absolutely.
When you're debating someone, I feel like there's a lot of information you want to give the person, but you don't usually give them in a way they can parse it. I think it would help if you try to make them get to the conclusion that you already have, instead of just trying to give them the conclusion yourself.
I tried doing that, then it seems like they say I'm too long-winded and I'm on a monologue.
Bacon has wisdom beyond his years.
So Bacon, when I do that and I try to let them make the conclusion, I ask them the questions that if they answer along the way, they would make their own conclusion. Then I get accused of being too long-winded and I'm monologuing, and then it takes much time. So I got to find a balance of just enough information for them to make that conclusion themselves, but also give enough information so they can make the conclusion themselves.
You want me to give you even better? No,
if you're monologuing, then I think you're doing it wrong. Like, you have to do that with simple questions.
Well, they are, but they're quick. But there's so many along. Like, for example, the whole discussion about bending, warping of space time, and Jeremy was talking about, oh well, then both sides of the Earth antipodal are going to accelerate upward. It means the Earth is going to get bigger. And I broke it down why that's not the case, and the bending of warping of time and progression through time and all this. And no matter what happens, they can't put the puzzle pieces together. Not that it's easy to conceptualize, but I've tried to be as brief as possible. And with the more brevity, the worse it gets. So,
well, I have even more pertinent advice, because I think I value your content, Zanuck, your input and stuff like that. But some people can get fed up, and I don't like it when that happens, because then they're thinking about muting you or something. And my suggestion is, if you're ever in a argument with somebody or debate or whatever, and you're both talking over each other, if you, like 9 times out of 10, just give it to them, so that you can point out that they're constantly interrupting you, but not while they're still talking, then people like the mods and stuff like that will probably give you credence, instead of seeing you as the trouble, you know what I mean?
Yeah, like when that's happening, just like mute yourself and count to like 215, just like mute, and at least for just like maybe 2 full minutes, just don't say a thing, and let other people go, and let that person go and that person go. Like, that alone would just give some breathing room,
Sure.
Because you'll get into this thing where you just go and go and go, and it just like never stops, and then people get more and more frustrated, and then there's more of a likelihood to want to mute, and then your point's not getting across, and then the interruptions. Like, a little bit of breathing room in there, I think, would be helpful.
Sure.
I like it. I think in Zanuck, I agree with Kosho. I value your content and what you have to say. But it's like when you drive a nail and you drive that nail flush, and then you keep striking the nail, you eventually knock the nail loose and all the wood splinters out, and it's kind of gets missed. If you just drive that nail flush and stop, you probably get further with it.
I've tried that technique too. In fact, last night I did that a few times, and it didn't quite work. Just got to the point, little bit, 1 or 2 sentences of support, stop, and missed the confusions were. And then of course 3 people jumped in, piled on. I was being interrupted. I'm telling, don't interrupt me, and then I'm interrupting them, and then of course I'm like the guy in the football game that gets hit, and then he throws the punch back, and he's the one who gets caught by the ref. Flag's thrown, he's ejected. So I gotta just take probably Gio's advice of just, no matter what's happening, always just back out, let them continue to talk over me, and eventually they'll notice that is them that's talking over me, and I can make my point even with more brevity.
Yeah.
Because we're fair here to the point to where, like, you'll get your full chance best we can. I mean, I think, to the point to where it's not going to just be where you're just going to be like muted. No one, just like, you're not going to be shut down in that way. But like, if there's the interruptions and the craziness happen, then, there might more likely you have to be muted just for temporary. So it's like, yeah, if you like what I just said, I jokingly said count to 215. I don't know why I said 215. My point was, if you just like literally like in the chaos of it, just muted for a bit. Cause I think people also feel like it ends up being the Zanuck show and you're talking nonstop. If you just like took a break a bit and like just literally muted for like 2 to 3 full minutes, go get a cup of coffee or just do something and then come back, you'll have your full point. You'll have your time to be able to respond. Whereas like you said, when that doesn't happen and then you're going and then someone feels like there's an interruption and then you're interrupting, saying that they interrupted you, whatever happens. And then it's like the airplane's going down,
Yep. I get it.
Coffee might be a bit extreme. Counterproductive as well. But
maybe some chamomile tea.
No, but I mean, because I don't even mean taking yourself into conversation. I just mean something I've noticed is like when I get interrupted, for instance, sometimes it's aggravating, and whatever. But if you simply allow them to do that and then just point it out that they're doing it when it's your turn to talk, then that does more to identify them as a problem than both of you. You know what I mean?
I think there's also probably sometimes improvements that could happen with moderation. Sometimes it's tough when the conversation's really heated. Like it almost takes like the quality of like a judge, somebody who, I just mean a judge, like somebody who can like, ideally, I'm just using that kind of archetypal idea, who can do the right thing. What that person interrupted. Okay, that actually do the right thing with the moderation to make sure then whoever gets the mic deserves the mic. And I don't doubt sometimes we might drop the ball on that if there's not mods that are right active, and then there are interruptions happening. There is someone that went on a turn. There is someone that is trying to start a shit show, whatever it might be, to where like. Because, it's important that the right thing is done in that moment. Otherwise people are going to feel slighted and it's unfair and, that kind of stuff. So
the problem isn't it? Because on paper that makes sense, but isn't it a lot harder and more nuanced than because a lot of times it's not black and white in a conversation. Like it's hard to tell when the interruption was accepted, like if it's like for instance, like if it's an accepted one, like if somebody interrupts but it's accepted, then it's not really even an interruption really. And so it's like only the blatant ones are easy to mod, but there's a lot of gray areas where it's difficult to tell who's causing problems.
Yeah, no, I agree. And then I think it's best not to be like excessively muting people in general, kind of let it flow and let little, because sometimes there's little interruptions that are okay. So I don't know. It does sort of depend. Like this morning, I remember, well, it was sort of morning for me, not too early morning, kind of mid-morning. But I don't know. Did you hear when Noah and Jeremy were? That was so cringe. I was listening to it, but I couldn't get to my mic.
Yeah, that was hard.
It was so rough. I wasn't really at my mic, but like somebody needed to step in and fix that because it was just like, yes, Jeremy has a problem with his mic and it's delayed. And Noah was probably interrupting a bit and doing long pauses, but it was just this like I really wanted to hear what they were saying because they were talking about like time and the time and the creator and all these different. It was very interesting, and I really wanted to like hear what was being said. But like every time Jeremy talked, Noah would go, and then it's like instead of Jeremy kind of just taking the reins and kind of getting solving that problem, he would just okay, you go ahead. I don't know. It was just so like. It was just wild.
I think it's because too many people, because people were fucking around with him a little bit. Because people say that there's a delay, and I honestly don't think that's the problem. Almost all the time, like it is the problem sometimes, but most of the time it's just because people are interrupting, and because of that, I think he's giving the benefit of the doubt to people, and probably thinking that it really is his problem with his headphones or something like that. And also Noah is a habitual interrupter. Like
it was something that was really bothering me was that Noah would say something and then make like a 2-second pause, and then Jeremy was trying to respond, and then he would just move on and speak over Jeremy for like some time, and then Jeremy would give up, and then Noah would stop, and then Jeremy would again try, and then Noah would keep speaking again, and it was very, very frustrating to hear both of them interrupting each other all the time.
Yeah, Grim does that too.
Yeah. Well, I was saying to Jeremy, and that I think what would have been the answer there is like to go to that 30-second thing. Not to say that we have to time it, but I just remember one night it was like Zanuck and Flat Earth Data, and that's when I first kind of came up with that. I mean, it's not like a huge invention or anything. It's just an idea of a way to do it where it was all the over talking, the chaos. And I said, all right, guys, how about you each get 30 seconds? No one can interrupt that person's 30-second period, no matter what. So if like right now, let's say if it's my 30 seconds, no one can interrupt me. And if anyone does, they get muted, and it's to be expected. They'll be instantly, just temporarily muted. Obviously not a long-term thing, just temporary. And then I get my full 30 seconds. Whenever I'm done, whenever like 2 full seconds have passed, then that's it. My mic time is done. and then maybe let's say 2 people jump in. Well, you got to decide which one goes, and let's say it's Kosho and Bacon, and then okay, Kosho is the one that is, Bacon pulls back, Kosho goes. He gets his full 30 seconds, and anyone who interrupts him gets muted. It's a little more rigid that way because obviously you can't really have as much of flowing conversations. But I remember that night with Zanuck and Data, it was amazing. Like because we were doing it with the actual timer, and neither of them were interrupting at all. They both were trying to be under 30 seconds. Data was like, oh, my record is 24 seconds. I'm going to try to get to 23 or whatever. He was literally trying to even do better. And it was the best conversation I've ever heard those two guys. To this day, it's the best conversation I've ever heard Zanuck and Data have. They actually went back and forth. There was no interruptions. It was perfect. So like in that thing that was happening with Jeremy and Noah, because there's like a fine line between an open flow conversation where, okay, you talk, the other person talks, and it's fine. There's a fine line between that and then when all the when emotions get involved and all the interruptions happen. So if we just flip to that 30-second type mode, we don't even have to time it. I'm not saying we have to actually do the timing, but just that concept of, okay, one person has the mic. If anyone else interrupts during that person's time period, they're going to be temporarily muted. And then when they're done, they pass the mic and it goes to the next person. So in that case with Jeremy and Noah, I talked to Jeremy later about that. I was like, dude, that's what you should have done there. Like you wouldn't have had to do the 30-second timing, but at least go into that mode where it's like, okay, Noah, you get say your whole piece. And when you're done, you have to not speak. You have to let Jeremy say his full piece so you can actually pass it back and forth, because otherwise when emotions are involved and you're trying just to do the free flowing thing, sometimes doesn't seem like it can happen. So it needs a little bit more structure so the conversation can actually carry on.
All right. Actually, I was thinking about it while you're saying that. Like I see what you mean about it being kind of too rigid. I think that if you did that sort of, if you brought it up, enough times or whatever, when you're in that mode or whatever, you could just make it so it could be understood that like when someone's talking, the muting is just more strict than normally. It wouldn't be like an absolute thing because you could play it by ear and could see that maybe the person who was speaking allowed for the interruption because it was a pertinent question or something, whatever. But it's just more strict than normal. And then when it comes time to like the 30-second thing, that would just be more strictly managed. So if you went above 30 seconds, you'd be basically told that you're going more than 30 seconds. But like I said, it wouldn't be like have to be absolute, just like more strict than normal. And then also when it comes to the next person responding, the muting or the modding would be less strict than during the 30 seconds, because obviously multiple people are going to want to talk, and so you're going to get multiple people talking at the same time. So you just would make it a less strict muting thing. But yeah, if you did that, I think just the fact that there's more strict muting creates that atmosphere that people are just kind of being more careful not to do it. I think it works out. I just don't know how you would keep enforcing it. You'd have to have somebody constantly there enforcing it. That'd be the only problem.
Yeah, I think that the answer to that question is related to pendulums. That there's a specific equation for the tension of a pendulum depending on the angle that it's swinging. And I think that's how you get the answer for that.
Wait, what?
The physics question.
Yeah, I know, but there's a specific. You're saying. Oh, right. There's a.
Yeah, if the pendulum is swinging by 0 degrees, then the force is just the weight, right? But if there's an angle of swing, that angle is going to give you bigger tension on the rope.
Okay. So it doesn't matter about the length of the rope. It just matters about the angle of the starting position. Okay.
Yes, that's the physics of pendulums. And I don't know any formulas of the physics of pendulums. So I wouldn't know how to solve that if I was doing the exam. But I think I'll learn now. Have you ever worked with that kind of formula?
Yeah, well, I whenever Flat Earth Data, he used to bring up this he would bring up this problem, and I forget it next.
Sorry for changing the subject, though.
So what?
Sorry for.
Well, that was it. Yeah, I was trying to figure out what. Yeah, because Kosho said that thing about the muting, and then I was trying to figure out where you were going with that. But actually, I was sort of thinking how a conversation is like a pendulum. It swings back and forth. Like one person says something, the other person says something, and it's like if you have a room with a bunch of people in it, ideally, it's like you want to hear both sides. And then it's like when multiple people start talking, it's like multiple pendulums are swinging in different directions, and then they're clashing and stuff. I was just thinking how. And then that 30-second idea, like what Kosho was mentioning, like, yeah, it is more structured so that can, there's positives and negatives to it, but it's like the idea of like only letting one pendulum swing or one person speak at a time so we can actually, hear all the things that are being said. Anyways, I know you weren't really relating it to that, but I was like relating it to.
Yeah, at first I was trying to, I thought that's what we were talking about too, but it's funny. Hey, what'd you say? Oh, right, the data, the flat Earth data problem. He brought up a pendulum. I forget how the problem goes, but he was just saying that like you can measure gravity by using a meter and a kilogram. I think it is. Like if you have a kilogram mass and a meter rope, the period will always be 1 second or something like that.
Bigger gravity is going to make the period smaller. Smaller gravity is going to make the period bigger, right?
Yeah, I forget exactly what the problem was, but yeah, when I was doing that, I was having to figure out all these different formulas for pendulums. But I bet you that if you just took like the centrifugal and centripetal formula and you rearranged it and stuff like that and played around with it, you'd probably end up with that same the formulas for the pendulums or whatever.
It's kind of what I try to do, but maybe I started with the wrong assumption. I use the formula for centrifugal force to get the speed in which the buoy would be in the bottom. No, actually, I used gravitational potential energy and kinetic energy, those two formulas, to get the speed in which the buoy would be in the bottom, but that might be wrong. I think I got the speed wrong. And then for using the speed, I got the centrifugal force. And I think that makes sense. I think that part is probably right. I think I got my mistake was in the first part. But I don't know. I still don't know how to solve it. I mean, I know that's not the easiest question of physics, but it sounds like it should be easy enough for me to solve.
It's pretty straightforward. You're just trying to find the force at the bottom?
Yeah. Well, I think the force on the bottom is going to be the highest one, isn't it?
Yeah, of course.
Yeah. Because it's when the buoy is the fastest.
Right. You can then use this. So it starts with the simple formula, which there's the time, the period, and we all know the period doesn't matter how long it depends on how long the length is. That's the variable, the length. Doesn't matter what the mass is, and we can figure out what the g forces are on that mass at the bottom based on the angle you start with. So you're saying 90 degrees. What's going to be? So we can go if we have to go back and figure out how long it is, and then we can put it through the centripetal force equation.
Let's use one. I mean, if you need a distance, let's choose whatever distance that makes the math easier.
All right.
I think the distance doesn't matter.
No, well, it does. It makes the period. Well, there like you said, there is some there is some canceling. Yes.
Yeah.
Because you have the circle is now going to be the radius is going to be much for every increase in radius length because it's radius squared. Velocity. No, sorry, not radius squared. It's not radius squared. That's why it cancels out. It's the mass times the velocity squared divided by the radius. That's the force.
Okay, so here was what my reasoning was. I started by getting the gravitational potential energy when the buoy is at 90 degrees. So that would be mass times height times gravity, right? Times g. So 24 times 10 times the length of the rope that we don't know. So 240, let's say L, 240 L would be the amount of energy that the buoy has, right? Is that a correct assumption? Maybe.
Oh, you're going from an energy perspective. You're going from the energy angle. Okay.
Right.
In a different direction.
So he starts with 240 joules.
Joules.
Times L, which we don't know. And then when he's at the bottom, he would have that same energy, but it would be all kinetic energy, right?
Right. Exactly. It doesn't matter how long it took him to get to that bottom spot. The fact is, he got there, and that's a given. It's a given rate of change. Not rate of change. Change of kinetic energy. Same whether it gets dropped or it goes on a pendulum.
Okay, so the kinetic energy should be 240 L.
Oh yeah, now you're onto something. So now we're going to find out the greatest rate of change of kinetic energy would be the power, and then the first derivative of power would be the torque, would be the force.
I wasn't going for derivatives, but yeah, I'm describing how I got to the wrong answer. So I'm trying to see where my
mistake. You got me
mistake.
curious. These simple ones are always the hardest ones, because you haven't done it in a long time. Let's see if I can figure it out.
Well, kinetic energy is like mass times v squared over 2, right?
1/2 mv squared.
Yeah, same thing.
Yeah.
Okay.
So let's go through and try to figure this out.
So yeah, so m cuts out, so we can remove the m and remove the m from the 240, and that becomes just 10L. So v squared over 2 is 10L, which means the v squared is 20L, whatever L is. So when he's in the bottom, the speed should be the square root of 20L, right? Does that sound correct?
Kind of.
I'll share what I'm doing. I think just saying it
I'm looking at it from a
doesn't
different
help. So that's what I get. I send on Livestream one text. Yeah, so far that's the speed. I didn't square it. I took the square root of it because I know I'm gonna have to square that later. So I want to save some square roots. Then I can use the centripetal force formula, which is mass times v squared over radius, which is L. Yeah, that's wrong. I don't know. It can be right. Never mind, just boring everyone.
I got new perspective is so clueless.
I thought his question was good. I was saying we were just having a chat about it. I think it's a legit question because, yeah, my first impression as well would be if you're standing on the moon. I feel like the Earth feels to me like it should take up half the sky.
No, all these things are focal length dependent. If you were to look at a moon or take a picture of the moon right now, it would look like a star. It would be a little dot because most cameras have a little bit of wide angle lens to it. In fact, I remember we taking a picture, man, the moon was so big, it looked so big. And I was at a concert on top of a mountain. It was a great picture. And I said, oh, just put the moon across my shoulder. And he took the picture and I get the picture back on my phone. It's like a freaking star. It doesn't give me anything of the drama because the angular size is not preserved in that picture because of the wide angle lens that all these phones naturally have. So when it will be relative. So if you have an object that's, you have a moon and you have a sun in the background and they're exactly the same size, what does that tell you if we do know how far the distances are between them and from us? It all makes sense. Nothing is surprising. It seems to be surprising to people that just don't take all these things like angular size and distances into account.
Well, I did a rough calculation, and
you're still going on that?
No. For the angular size of the Earth from the Moon, it should be around 2 degrees if I got it right. Because
yeah.
That's
what I got too.
Yeah, exactly.
I mean, the Moon is half a degree, and the Earth is around 4 times as big as the Moon.
Correct.
So it should be 2 degrees.
Yeah, and the problem is they can't understand the pictures where the moon is so big that they have it on a mountaintop and people are on a mountaintop and they're huge in reference to the moon. Some
big focal length.
10% size of the moon because the person taking the picture is so far away and he's zoomed in, so that the angular size of these people are close to a good percentage of the moon's angular size. And no, it's just someday that it got really big. One of those big, rare, big moon days. No, that's not how it works.
It's barely 31 arc minutes.
Yeah,
it's barely past half degree.
And that's why you see transits of the moon of the airplanes when they're 200 miles away near the horizon, and you see the ISS, which is 200 miles away, roughly the same size, maybe a little bigger, up in the sky, straight up or near straight up. They're both 250 miles away. Oh, but the plane's only 30,000 feet. 5 miles. How could it be so big? Because it's not right above your head. The distance to you, that moon, that airplane is 200 miles away, and it's transiting the moon because it's near the horizon.
We were talking about the Selenian eclipse a couple of days ago, and they posted a video of the Selenian eclipse, and the moon was like setting before setting was a bit higher in the sky than before setting, and they said that from the video they can tell that the moon is very high in the sky, at least 45 degrees.
Yeah,
but you could only fit 8 moons between the moon and the horizon, so that's just 4 degrees. That's how wrong their intuitions are when they're trying to judge like the angular size of something.
Well, I was gonna say you can see something. You can see directly the Earth's angular size in the sky. Well, not directly, indirectly actually, during the eclipse, because if you're measuring the
that's
shadow
right.
that the moon's going through, it's going to be relatively close to the same angular size as the moon, as Earth would appear from Earth. There's a slight difference because of the way the shadow's angled, but it's fairly close to the.
Yeah, it looks around 4 times as big as the moon is.
Right.
So yeah, that sounds right. It makes sense. No, actually, it doesn't. Yeah, it looks smaller than 4 times.
It's slightly the shadow because of the angles of the shadow. That was the assumption. That was one of the assumptions that made Aristarchus get.
The umbra gets smaller, right, with distance.
Right.
So if it was if it was exactly parallel, then it should be 4 times the size of the moon, right?
Right, but it's angled in. So.
Yeah. Well, actually, the Earth isn't 4 times. It's also a little bit less than that. It's between 3 and 4 times. 3.6 times.
So I wasn't talking with new perspective. It was epoch. But despite the numbers, did you guys have the same feeling? Like that should look huge.
At first, but then, like I said, because I've heard it questioned so many times, but I remember the first time I thought about it, though, the first thing I could think of was like what makes a picture. Because my girlfriend used to take pictures of the moon all the time, and it's like what Xanax says, like if you're taking a picture of the moon, it certainly depends on the zoom that you're using, because you could be zoomed directly into the moon, or you could be not zoomed in at all, and taking it on your phone or something, and it's going to appear completely different. So that would totally depend on. I mean, any picture that you have of the moon, of the Earth from the moon, is totally going to depend on how zoomed into the Earth they were.
Mm-hmm.
Unless you have like a something like a structure to compare it with. So really, the only one that you could compare it to is like when the. No, I don't even think that's a real picture. I was going to say, but isn't there a picture where there's an astronaut and there's the Earth in the background? I don't think that's a real picture. I can't remember. I think there might be, but yeah, something like that you could draw conclusions from, because there's an actual something that you can compare the size to.
Oh, it probably is going to feel like it's huge if you're actually in the moon looking towards the Earth. Because the moon, at least when it's close to the horizon, it feels like it's huge. And imagine like something that it's 3.6 times bigger than that.
Yeah, I mean, they say that the Earth being 4 times larger than the moon. So from the moon, the Earth should look 4 times larger than the moon looks in our sky.
Mm-hmm.
So if this whole model existed or whatever, if you were on the moon, the Earth would be, let's just say you're on the face of the moon or whatever, you're right in the middle of the face of it from what we see. The moon, the Earth should be directly at your zenith, like your high noon, and it should be 4 times the size of the moon as what the moon appears to us.
So 2 degrees, 2 angular. Yeah.
Yeah. Oh, it's 3.6. So a little bit less than that.
And you guys I don't know if you guys, how many of you believe in the moon landing, but do you not think it's not beyond strange that the one thing you would do if you're on the moon, the first thing is you would just literally be pointing your camera at the Earth? Think about that. The Earth is at your high noon. It's right up there, this glorious Earth. You would point your camera all around. Look at it. Look at the Earth. And there's not one shot of that.
Yeah, I would take a photo of the Earth.
What are you talking about? They took one with the flag. They lined it up pretty at a pretty steep angle. You got a picture of the Earth and the flag and the lunar and the astronaut all in one shot.
No, that one is admitted that's a cropped thing.
Not that one. We're not talking about that one.
No.
We're not talking about that one. This one. Here, I'll put it here. It's in here. Not the lunar lander project, just the astronaut and the flag. This is the real one, because that's pointed up. The one that's not real is the one that was doctored. Now I find out it's doctored by flat earthers or loon conspirators, where this was the actual picture, and then they added the moon afterward to make this. And I guess that never was ever. I thought it was my imagination. I just remember it being in Life magazine or something. But this is the one. Where is it? They added it in. I can't find it.
Yeah, the Earth looks way too small in that.
Well, why?
Never about angular size.
Yeah, what do you think is the angular size of the Earth in that picture?
Yeah, the Earth, it does look tiny.
And why is it only half lit? If you were on the face of the moon, the whole Earth should be lit.
Not necessarily.
Why? I mean, the Earth, the bright part of the Earth would be pointing towards the sun. So if you look to the picture and the direction of the shadows, it matches the shadows of the Earth. So the sun is in the same direction for both the astronaut.
We see that on Earth too, Gio. You can actually get a day where it looks like this. Look at the moon in the daytime when the sun is, rising, and the moon is over toward the eastern direction, and you'll have the things lit up on the ground just like this.
The shadow on the astronaut and the shadow on the Earth, they're in the same direction. So the light is pointing towards the same direction of where the sun will be. Just like when you hold a ball against the sun and then you compare that to the moon, you see like the same, the bright part and the shadow are like the same for any sphere that you hold when you compare that to the moon.
I don't have that fake picture, but the last picture with the Buzz Aldrin or whoever's taking the trip down from the limb, they put a Earth low in the sky there, so it fits in that picture, and that was added. And I thought that was actually done on purpose without explanation, but it turns out it was actually developed by moon conspirators that stuck it in there. That was never published by NASA or anybody. We just talked about this yesterday. Here's one for you guys. This is a live picture yesterday, I think, right? Is this when you guys were talking about, Gio?
You sure that's a real one?
That was real.
God, that looks fake.
Why?
Oh my lord!
How can that be so?
That's toasty.
Looks real with the angles on the shadow.
I just say it.
Oh man, these guys just slam dunking.
We'll give it away.
Just slam dunking on the folks that believe this stuff.
What gave it away?
What a hustle they're doing. Just a multi-billion-dollar hustle and just cranking people's minds. It's crazy.
Is that fake?
There's no stars.
Yeah.
Because sure, you can see the moon and stars at the same time. I mean, the moon doesn't even look that bright.
Exactly.
So the exposure is quite small. I mean, if you don't see the moon as a white blob, you're not going to see any star.
Exactly.
It's like that game NBA Jam. Remember that? Where the guy would be on fire and he would jump from half court and the ball would be on fire and then he would slam dunk it.
You know, what's interesting is if you watch the live feed, I was scrolling through it. You can see when they turn the lights on. There's a moment or two where they have to adjust the exposure, and you can see the effects of that.
You know why that one's fake, Zenny?
Why?
Because you don't have the same moon spots that we see, so that moon's fake. You forgot to add the moon's oceans or whatever.
That would, if that was the case, that would tell you that it was fake. If you could see the same.
Yeah. Yeah, because I mean that's the other side of the moon, right?
Right. That's funny, actually. I mean, this would be a hard one to fake because you would have to use a picture of the moon that nobody has that available to them.
Which one is on the back side of the moon?
It's like on the oblique side, the oblique back side of it. Yeah.
Yeah, I was kidding because we don't see the same shapes on the surface of the moon on that picture, and say, well, that shows it's fake because we know the moon doesn't look like that. It has some like dark spots there.
On the backside, we're seeing a lot of the backside in this picture, obviously, or angularly.
Yeah.
So you're saying this one's fake?
No, I was just kidding.
Oh yeah. So what percentage of it is what we never see. Well, you look at the angle of the shadows, you can see how much of it, part of that moon we never see, never faces us. It's behind it.
You know what kind of mistake they could make in that picture? They could easily make a mistake in that picture. Would make the moon brighter, because the moon isn't isn't a like it looks bright to us because we seen that during the night. But if you look to moon rocks, they are quite dark.
Right.
So if you can see the Earth, like you can see the blue of the Earth, and it's the contrast is fine on the Earth, then the moon should look dark. It shouldn't look like something
exactly. And
light gray.
A lot of the clouds and things are white; that are very reflective. That makes the Earth look brighter.
Yeah, and you can even there are other photographs in which you see both the moon and the Earth from satellites, and on those photographs, the moon always looks like too dark, because we're used to seeing that during the night, where we the brightest thing we can compare to is like the very dark sky. But if that picture, they could easily make the moon too bright, and it wouldn't match the rocks that they brought from the Apollo missions.
Right. They actually have a lot of data. Like, people say they don't provide a lot of stuff for the for this mission. They actually do quite a bit. Like there's a website where you can get a simulation of its exact position, and you can take a view from every camera. Like all the cameras that are on it, you can take a different view from all the cameras, which is pretty cool. And then they only had their telemetry data before, like live feed of that, but now they have live feed of the footage from it, and it's streaming almost constantly. So it's got a lot of stuff.
Have there been any sort of they didn't give us blur angle, or they didn't show us X about Artemis yet?
Yes, absolutely, all of that. They for a while SC was going on about its speed, because there's just no mechanism to slow it down as it's approaching the moon, and so they were going on about how, but its speed went from thousands and thousands of miles per hour to less than, I don't know what it was. It was like less than 100 miles per hour as it approached. Or no, I forget what the minimum was. It was probably like 200-300. I think it was like 200 or 300 miles per hour. But anyway, so they were going on about that for a while. But then also all the cameras that are on it, while we weren't getting any footage, but we obviously are. So. If that's this is real footage. That's going to be a classic picture. That's what's cool about this live feed. Like, whereas from the moon missions, they had to take pictures all the time, you're going to be able to get a lot of cool images just from the live feed. That's one of those iconic images, the one that was posted. That's cool as hell.
Oh, how does glare work?
What do you mean?
It's something that happens like in the camera, or is the air around the thing lighting up? I don't know. I don't understand how glare works. Like why does light seems to expand? Like how exactly that happens for a camera to see this gradient coming out of the, like if I'm pointing my camera to my light bulb, right? I can adjust the exposure, and I can see the glare expanding. But if I cover the light bulb, shouldn't the air around the light bulb create the same glare? Well, where does the glare come from? Does it come from the air around the bulb? Does it come from, I don't know. I don't understand how it works.
I think
Guys,
I think Xanik would be the right person to ask.
I feel like it's a.
What was that again, Bacon?
Well, let's eggshells give his try.
So, I want to have a guess at it. I'm guessing it will be a variety of effects. One of them certainly being like in a thing in atmosphere, it's scattering, right? Like it's hitting particles which are then lit up. And I think that's also anything then it passes through. So glass or anything like that, if it's got any crap on the lens, that's some of what I think glare is.
Yo, the question was about what glare is. How does glare work? Like, how can something that looks bright make the surroundings of it also get bright when you take a picture of it? If the light isn't coming from the surroundings, it's coming directly from the... I'm just asking the question for Zenik because he didn't know what the question was.
I'm sorry, I missed it.
You heard it now? Or you...
I didn't hear it. Sorry. I was...
Right. What the glare... Like, when you take a picture of something bright and there's glare around it?
Right.
Why there's a glare around it? If the light is not coming from the surrounding, it's coming from the light source. Why does the surroundings light up in a picture?
It's a function of the lens, I believe. The material the lens is made out of.
Sure.
How the light diffracts and refracts in the lens.
Oh, so it's spreading because of the diffraction?
Because you can filter it out with different types of lenses, right?
Well, but if it's spreading because of diffraction, then the whole picture should look blurred because light from all directions would also be spreading when they enter the camera, right?
No, it's the same reason you have these flares you'd see on the sun if you had too high of a sensitivity of a film. Just lower the sensitivity of the film, and then suddenly you get a very clear image, and there's no blurring. So it's just about that's a good question. You know what? I gotta think about that. What really is causing the glare? Yeah,
I'm trying to think of an experiment. Like if I cover, let's say I'm taking a picture of the sun there, and there's a lot of glare. So I cover the sun with a coin, and I take a picture at exactly the distance in which the coin completely covers the sun. Am I gonna get the same glare around the sun? Is the glare completely gonna disappear? Is it gonna get smaller? Is it gonna be the same? I don't know. I'd like to know that.
I think the light is diffracting in the lens and spreading out. That's my idea. That's my thought.
Right. So
could be wrong.
If that's true, then when I cover the sun, the glare should completely disappear, right?
And it does.
Does it?
With respect to the film or respect to the photosensor.
But solar filter can get rid of the glare.
Oh yeah, I know that, but
how does it solar filter work?
It just makes everything darker.
But how? There's actually a function of that filter that actually it's analogous to polarization. It's taking the light and not allowing it to diffract in the lens itself.
But it also makes it darker, right? Because I can use a solar filter to look at the sun with my tiny telescope, and it doesn't burn my eye. So I don't think it's just getting rid of diffraction. I think it's also making it darker, right? It's also changing its color. There's one of the filters that makes. Sorry?
Yeah, some filters change the color.
Yeah.
But I'd imagine there's a filter that wouldn't change the color. That just gets rid of the glare. Polarization is like I said, is a good analogy. How does polarization work? Why does polarization get rid of the glare? It's the same function. It's a function of the lens. Still sticking with that. Like I said, I could be wrong, but I think that's the answer.
Yeah, I gotta look it up. I'm not sure if you were here, Koshu, but we were talking about trying to start a fire with moonlight. So, how big of a magnifying glass do you think it would be required to start a fire with the moonlight?
Well, to make it as bright as the sun, you're going to need something 2.5 million times.
No. we talked about that subject. We kind of know the answer. I want to see if Koshu wants to give it a try. Assuming he's here.
Sorry.
Yeah, I think he left. Never mind.
Or he's lurking. Koshu doesn't go far, if I know Koshu very well.
Maybe eggshells.
Is that what am I right now?
What was that? Chiang Mai. Let me see what that is.
Yo, what we saying?
Oh, is that percentage?
Yo, what's up?
You're still alive?
Yeah, still alive, but I'm barely breathing.
Your voice sounds older.
How you doing?
I'm doing okay. Are you really a percentage? You don't sound
That's
like
not
a
percentage.
It's not?
I think he has a different mic or something. Maybe
It's a different mic, yeah.
It doesn't sound like percentage to me.
Well,
but I've only heard him say 4 words. Tell us how you've been, percentage.
I've been good. How you been?
I mean, he got the moderating roles here, so he's not someone that just joined.
Right.
So I think he's actually percentage. But it doesn't sound like percentage.
It is what it is.
Okay, let me see if you're really percentage. What would I need to do for the Foucault's pendulum to actually prove that the Earth is rotating? I know your answer
You
to
know
that.
what you need to do. You need to have an actual experiment, which you haven't done.
That's him.
It's him.
There he is. You take the pendulum.
Weird mic.
You take the pendulum itself to a different location, different latitude. There you go.
Yeah, that's percentage for sure now. Yeah, sorry for being overly skeptical.
You didn't sound right. I was like, that ain't percentage. That's what I said when I first heard it.
Yeah, sound like a 50-year-old black guy first thing.
Well, I'm not that old.
Yeah, I think it's just the mic. There are some people who sound very different microphones.
But you weren't wrong, though. I am older.
Fair point. I remember thinking you were a troll, because someone said you were like a confirmed troll.
Yeah, people say what they want.
Yeah, but that changed pretty quickly. I think you were one of the most reasonable flat earthers I know, to be honest.
I appreciate that.
One of the ones that I don't think gets leveled at them the accusation of you just don't understand it.
That's a hell of a background noise there.
I don't know what the heck that was.
I'll turn off my mic. I'm wandering around.
Yeah, well, I was having some discussions. I don't remember exactly what the subject was, but I was like, "Oh, I miss." Like I remember it reminded me of you, and I was like, "Well, I think I could have an amazing conversation if I was talking to Percentage instead." I think he would be able to get it because like I was
That's a
trying to.
great compliment. Thank you, man.
Sorry.
Do you remember what conversation you were having? Like what the topic was about?
No, but it will come up again at some point. So, so why were you away? Like, did you?
Yeah, I've been busy.
Yeah, that's good, I guess.
Traveling a bit, yeah, living life. You know how it is.
Right.
What's new though? What happened with that moon landing? Or like moon mission or whatever?
Oh, it's still on the way. Still a couple of years until we put people there, right?
I wonder what the predominant opinion regarding that is with the flat Earth community.
Fake.
That summarizes it pretty well.
That easy, huh?
Yeah. Well, I've seen some fake stuff too. Someone posted here a live stream video of something orbiting the moon, allegedly the Artemis mission, but it was a fake one.
Fake mission?
Yeah, it was a fake live stream.
The fake video.
Yeah.
Yeah.
There was many inconsistencies there. Well, the first one was that it was very close to the moon, while the other, like the official live stream, was very far from it.
And who released the videos?
It was just like I don't know,
random.
Yeah.
That's weird, man.
Yeah, and
gotta call that out when you see it. When people release fake shit, you gotta fucking address that.
Yeah, and there were some things that were making that footage really impossible to be an actual footage. For example, the thing was going around the moon in just like an hour, and it was almost the whole time in a bright part of the moon. I mean, the moon can be 100% lit up, right?
Mm-hmm.
It can only be half lit up, but the thing orbiting the moon never got to the dark part. It seemed that the sunlight was moving with it around the moon, which means that the moon would be making like a full rotation in just an hour, which is completely wrong.
How do you know it was an hour? Was there like like a clock on screen?
It was like, yeah, but it was very fast. Like in just a couple minutes, you could see a crater that was at the horizon, getting like below the camera. So yeah, it wouldn't take more than an hour for the whole thing to make like a full rotation.
I was thinking maybe it was very, very slowly orbiting satellite, and that just orbits once throughout the day, and then they just sped it up in time lapse, and that's why it looked like it was.
He had a timestamp.
Yeah, the timestamp kills it.
Yeah. And I don't think, I mean, if someone was that close to the moon, you would have to orbit quite faster, otherwise you would fall. Because if you're, the closer you are to, the smaller the radius, the faster you have to be to orbit it, right?
No, but it depends on also the angle,
the radius.
angle of the propulsion, right? If they're propelling upwards at an angle, slight angle, then they could be like counteracting the gravity and going around.
No, that's not how it works. There's no angle.
Why not?
Because it's
Well,
a free fall.
that would consume a huge amount of fuel to
It
try
would,
to.
yeah, it would be unsustainable, but
Yeah, so they usually just use like their velocity, so they speed up, so that when they get close to the moon, it's fast enough so it can orbit it instead of trying to use fuel to not fall towards the moon.
I think
yeah,
you still need to burn retrograde to get captured by the moon, but yeah, you won't keep burning.
Yeah,
you're just using a little bit of fuel to slow the craft down to go into orbit, so you don't just ricochet off of it and fly off into space.
Yeah.
why even like Photoshop a fake video like that? I don't even understand it.
Well, there was like
Too much time on the
4 million views or something, so maybe that pays out.
Oh shit. Okay, now I totally understand it. That many views?
No. Sorry, I think it was. I gotta go check the video again. I try to remember the number from the top of my head. But don't think it was 4 million views. There was a 4 somewhere. But yeah, I think 4 million is too much. Let me see if I can find it.
I wonder how much money 4 million views gets you on one video.
All right, I found it. Let me see. No, it's yeah. I think it was 14,000 likes it had, because now it's 15,000.
Mm.
I think that's yeah. Oh yeah, how many views? It doesn't show here.
Yeah, they removed that for I don't know why, man.
So here's
YouTube's
the live
greedy.
stream. If you want to take a look. It's a good fake, but it has many problems. Oh, I think I'm gonna go to bed. So see ya.
Yo, good night, man.
Likewise.
See ya.
Yo, I'm off too. I'll catch you guys later. JG in the chat, what's up?
Is anyone still here?
Is somebody on here right now? Hear anybody, but I see people are in the chat. I wanted to allude to something. I just watched Kai and Austin debate Jen and Mark. And I want to say that Jen looked like she might be the best one that they've ever debated for the flat earth. She was honest. So I wanted to point that one out. I don't hear anybody else, but since this is a live stream, I want to put on the record that if anybody investigated further into the people that they debated, if you go to Jen's after debate live stream, whoever that guy is that she streams with is pretty harsh on her, and I think that she is the only Glober that has ever brought any kind of like valid evidence to any kind of what we would consider the container for our gas pressure on Earth. So I wanna put that on the record that she was the only one who ever brought a valid argument to it. No one else has, even though it was debunkable. I'm just saying she was trying her like best, and when you see how she reacted in the debate where she conceded to things where other people usually don't concede and they argue and they're nasty or have fallacies and what have you. I just wanted to bring up that point that I investigated that what the feedback that she got from the guy that she streams with is pretty harsh on her, and look into his to that. Just go look at that and tell me what you see. If you see what I see, if you have eyes to see, I want you to see what I see. So that's all I'm saying. I'm done. I want that to be on the record. That's all.
Yeah, interesting. So wait, which debate was that?
I just had a sigh of relief that somebody was listening. Okay. It was the one where Kai and Austin debated Jen and Mark.
Was it from a while ago or?
It was, yeah, actually it was almost a year ago, December 11th of last year.
Oh, okay.
Yeah, I'm sorry. I'm so late to the game. I'm still catching up. I've learned so much from watching their debates and Austin's debates than any other debates that I've ever seen. So, but I love it when Kai and Austin debate together. It's just so cute. They're just perfect together. So I just I came on here last night while I guess Austin was on, and I talked to him. I was the one that wants to do some music with Kai.
Cool. Sounds good. That'd be cool.
Yeah, I have a YouTube channel, but I don't have a lot of stuff on there, content. I just, the most recent thing was from this year. I entered a contest. You can listen to it. It's under the name that I'm under here, and you can look up my name on YouTube. I bet it'll be the first video of the day, because I don't think that I don't have like an algorithm for or against me, so that's all I'm saying. Anyways, I watched their debate tonight, and I'm so mad because I did a little bit of more in-depth investigating after the debate, because sometimes I'll go and I'll look at who they debated and what they have their own channels, so you can go look into how they reacted to the debate, and it's interesting. You have to really like kind of sift through the bullshit because she live streams with this guy that I can't say everything because I know this is live streamed on YouTube too, so I'm not trying to. I just I want to at least make people go look into it a little bit, and they can find out for themselves. But the guy that she has live streaming with her, that she kind of puts on a pedestal, like it's with Drude. So it's the day after. It's not the day of the debate, but a little, like maybe a little bit before halfway through the stream, they are discussing it, and he's putting her down. He's telling her that she did horrible in the debate, that she made herself look like a joke, and she's literally so far. Let me go ahead and say this. So far that I've watched, that's been honest in the opposing debate. And even Kai and Austin were saying that they liked her. They're like, we love your honesty. You have been the best person that we've ever debated because you're actually honest in a debate instead of just trying to like throw out fallacies. So, and I saw that too. I'm like, this girl may be a flat earther after this. Maybe, I don't know. But I haven't researched that far into it. Just wanted to come on here and put that there because somebody needs to say it, because if no one else has looked into it, somebody should go and see how that girl's being mistreated and told that she did made herself look like a laughing stock when she didn't. I know people on the internet can be cruel, but anybody with an intelligent brain can watch that debate and see that she wasn't some idiot. She was intelligent, but she also was honest. And honesty to me goes above intelligence, or it is a form of intelligence. Sorry, what's that?
Yeah, no, I got you. I'm listening. I think someone just had some background noise in their mic.
Yeah, I wanted to put this on the record because I did the digging and research into, like, not research, well, maybe, yeah, just a little bit of digging into that one after I watched it. I was like, I'm curious to see how she reacted after that, because if anything, she's either a flat earther or she felt pretty good about it or whatever. But I was very shocked to see what was going on in the background, and with eyes to see and ears to hear. I know you guys hear that kind of language and lingo a lot, but for me, it's really important to hear that from people because it means something. So if you can just go and just dig into that girl a little bit and see the reaction that was given, and the feedback that was given to her by who she live streams with, and she fixates on him. Like, her live streams are fixated on this Drude guy. And Drude, I mean like Droood. I don't know how many O's. This guy's a joke, is what he is, and he's also got an agenda, and he's using her platform to support the agenda, and that's my opinion. So that's all I'm going to say. Somebody needs to at least do the digging for themselves if they want to find out more. Not at all like this is relevant to everyday things, but it was just relevant to me now, and I'm kind of an open book, and I wanted to share it with somebody that thought it was compelling.
I got you. Yeah, yeah. Thanks for sharing.
Also, anybody that wants to hear a bumpkin accent.
Yeah, I probably saw that debate back when it happened. So yeah, I kind of, but yeah, I'd have to see which one it was.
I'm so sorry that I'm late to the game, but upon watching that debate, I couldn't help myself. I was like, "Who's this Jen gal?" And I wanted to go see how she reacted to the debate and seen. I just wanted to see how she reacted to it, because some people will act a certain way during the debate and then be a certain way after. So I wanted to at least see that because you know them by their fruits. And when I looked into it, she's actually, I'm not gonna, I'm never gonna slang her in any way. I'm not trying to put a bad light on her. Actually, I think that she is a good person and she truly tries to be a good person. And I think that that should be seen. And I don't have to say that because during the debate, it was stated during and at the end by Kai and Austin.
Yeah, no, I think I know which one you're talking about. Yeah, that Jen. I think they did 2 debates with her actually, and I think on the first one, she actually kind of was like giving like certain flat Earth points, and then the guy was getting frustrated because she was kind of conceding certain points because she just kind of had that sort of
Oh, well,
intuition.
she did concede. She did concede. She didn't aggravate the guy. That some people thought that she turned on him, but she was correct when he was being argumentative and being kind of nasty during the debate instead of he was just acting like they were dumb. Like, clearly Austin and Kai are not dumb. They are very, very smart, intelligent, and are more um, knowledgeable in the field that they're debating and helps them debate their own debating points, is all I'm saying. That he had no reason to be nasty, and I think that she had seen that and she called it out. Now, I haven't seen the other debate though with her, so maybe she changed her gear. But also, you should see after that debate what happened to her, and if it is different. Somebody was telling her how much of a joke she made herself out to be, instead of telling her that it was good that she was honest.
Hello, Harry.
G'day. You probably won't want to hear from me though. I'm standing out on the street, so noise cancelling is going to be going berserk.
All right. Hello. Anyway.
It sounds all right. Doesn't sound too bad. I've heard worse.
Noise cancellation is pretty good on Discord.
Yeah.
I think it's I got some earbuds.
No worries for me either. I don't know how much longer I'll be here. I just wanted to put that out there.
What's up, Ruhif? What's new?
Not much, playing poker. Went go-karting today. It's fun as well.
Yeah, that's something I haven't done in a while.
Yeah, let me stick. I uploaded a little video. I uploaded a little video. 1 second. There you go, in the chat. And I'll post another thing in the chat to show you who's the king. Yeah, boy. Fucking smashed everyone.
Is that your name, Glenn?
Yes. Didn't you know that? Thought you knew
No,
that.
no. I just assumed that one or the other part of your first or second name related to rooted. There you go.
No.
Wow, you are good. There's a fair bit of daylight between you and that 1 minute club.
Yeah. Fucking smashed him.
I went with my current girlfriend. I went go-karting on like my first or second date. God, she smoked me so badly. So much better than me.
Yeah, watch the video. It's only like 3 minutes. So I posted the last few minutes of the race. But this dude just it was a kid. It was a fucking 14-year-old kid or something. Just stopped in front of me. Fucked.
I'm watching it. When does this happen?
Oh, pretty late. Yeah, pretty late. 2 minutes 20 something. Yeah.
Oh, so he's finished his racing, I'm guessing?
He just stopped. Just stopped. Yeah.
What a muppet.
Yeah. And then I didn't have the right phone cradle for my phone. I got an iPhone 11. They didn't have a fucking iPhone 11 cradle. So you'll see at the end, my fucking phone falls out onto the track. Oh shit! Hang on. Oh, good.
As a warning, I've gone through now 2 Samsung S21 Ultras, and people complain about the same thing with the iPhone. They've started making physical motorized lenses in the new phones to make the photos better, and they are all rattling their lenses loose. So I've gone through 2 phones and now happened to both of them from mounting to the handlebars.
Yeah, exactly. Too much vibration. Yeah. Same with this shit, right?
Yeah.
Pretty.
It just fell off.
Pretty bad. Yeah.
Oh yeah, he just stops right at the apex of the turn.
Yeah. Oh fuck, dude.
Yeah, that's a cool video, Roy. I like that. You know what lap that was when you hit the record? Yeah.
Oh no. It was probably when I had no kids to overtake. So it was probably half kids and half adults on the track. I'm keen to get like an all adults race because then they pump the power up.
Do they? What do they have these throttles down or something?
Yeah, it's all electronically controlled. So they're all battery operated. Yeah. I think they run
it's an electric open.
Yeah.
It wasn't playing any sound.
Oh, all right. Yeah. It's awesome. And you got a little, the Mario boost. It's got a boost button on your on the steering wheel. Fantastic.
Fun. That's really fun.
That's cool. You know how in the Mario games you have to go through those little things, little power ups.
Yeah.
They should have something like that where like they shine like a light down on the ground, and then you got to drive over that part, and you get one of those power ups.
That'd be cool. They could do that. Like these things are pretty awesomely controlled.
That would be cool to have like the entire track could be like LEDs, like a screen basically. Then you could like shoot missiles or something, get power ups and shoot things. That would be pretty cool.
Yeah.
Yeah, it gets
Actually,
stuck
question.
in bits as well.
There was a bit. Let me turn it down one sec. There was a bit where I reckon I had the line, and this guy cut me off, and then I got a warning for bumping. I'll just find the bit. Where is it?
Is it like you thought you had the line, so you definitely bumped him?
Well, we definitely bumped, but I mean, whose fault it was? I thought I had the line into the corner, so and he just got to find it though. Hold on.
Adult or kid?
I don't know. Probably a kid. Like I was overtaking all the kids. That was the point, right? All the kids are in the way.
Just because I'm also wondering if I'm the guy doing flags, I'm like, this isn't Formula One. You don't have the line, but if you're an adult, you see a kid, you don't smash into them.
Yeah.
You can tell Rupert wants to go and do MMA with toddlers.
Yes. That must be early in that week. Yeah, it's fucking top stuff. It's over at Entertainment Quarter, Harry.
Oh yeah, nice.
That's the top level of the car park. They've just converted it to this massive. It's like a 400 and something meter track. It's huge.
Yeah, that is awesome. Also because I like the idea of electric because the thing, I don't know if this is more the case with electric, but I think you can dial in the power better so that you get the carts being equal. Whereas
Yes.
I feel like with petrol carts, there's always a fast one, there's always a slow one, there's one that conks out if you go too slow.
Yeah. My uncle used to reach around and change the throttle, like actually open up the throttle manually. Like it was pretty bad.
I just pulled my bike apart. It's in pieces at a mechanic, and I went to see what was wrong with it. I had a list of 10 things, and I was like, I need to sort this out. Oh my god! The more I pulled it apart, the more I'm like, I have fucked this bike up. And one of the things that made me remember think of what you're saying is, I was riding along before, and I had to open the throttle to do an overtake, and then got done with the overtake, and he's like, why won't the bike slow down? The throttle got stuck open.
Oh shit!
And then happened 2-3 times. So I then forcibly closed it really hard one time. Heard this snapping sound, so I snapped a bit of my car because it was rubbing against the tank. So the little wheel that turns as you open the throttle, that was touching the tank. And then I've had one of my accidents at some stage, just bent my frame and snapped it in my top box. So there's so many things to fix. It's awesome.
Thank you. What's the time? 7:34. Almost time to feed the dogs, Gio.
I was actually going to ask you before you go feed them. Who are your top 3 people that you would want to debate?
Debate against?
Yeah.
Oh, I don't know. Someone that has an honest go at the celestial navigation. Don't know. Do you have any suggestions?
Brian sounds like he's had an honest go at the navigation.
Yeah. Oh, I debated Brian the other day. Yeah. I don't know. Someone that will make predictions for what they should see on a flat Earth that are different to what you should see on a globe. So if you can find someone that will make predictions, that'd be great.
You've been seeking that for a while. I remember back.
No one. Flat Earth is going to go nowhere, right? Unless people start doing it. You just I don't want to say that actually.
But it stopped doing it for a clear reason, right?
Yeah, I know.
Stop doing what?
Making predictions.
Yeah, you can make predictions all day. If the Earth is flat, I will see this far. See this far, Earth is flat. I guess you could do those all day. Long distance observations. If Earth is an extended plane, I would expect to see this in these atmospheric conditions. Oh, we see that. You could do that all day long.
Yeah, that'd be great.
Yep.
Cool. Yeah.
Yeah. You can do those endlessly.
Let's do that.
If Earth is a globe, I would expect to see curvature or, blockage at this area. Don't see blockage at this area. Earth not a globe.
Sure. Let's do that.
Yeah, that kind of stuff.
Yeah, you could do those all day. They've been being done for almost a decade now.
Yeah.
Have they though? What's a good example of it? 'Cause people keep saying that, and then we end up getting into the examples, and they are,
bad
at FE cause level, fraudulent at Jeranism's level, inconclusive.
Well, my last debate was on FE Core's laser test. It wasn't a debate; it was more a presentation. Let me find it. Give me a minute. Who did I send it to? Sent it to. There it is. Oops. Copy link. All right. Livestream1.text.txt. There you go. The actual presentation only goes for the first, I think, 13 minutes or something.
Just trying to decide if I go back to my room and get stoned or I go to the gym.
Excuse me.
That will dictate when I watch your video.
How about get stoned and go to the gym?
Oh my God, have you ever done that?
No.
It's awful. Oh my God, it's so bad. I mean, mainly like if you think about it, because you really experience stuff when you're stoned. So what you're really experiencing is every second of doing this uncomfortable, painful exercise feels like an hour. I'll be there like sweating and bored already, and it's like you actually haven't walked into the gym yet, Harry.
No, some people like it. Some people like using cannabis and like doing exercise or running or lifting weights and stuff. Some people get into it.
I like doing it if it's balance or skill-based exercises. So I have quite a few times on this trip, like I'll get stoned and then just stand on my bike trying to balance, static balance. So just like put the stand up and balance on the two wheels while staying still. That's like a fair bit of exercise, but it takes a lot of concentration. But if you want to enhance concentration, fine. Because I just want to get the gym done.
What's your favorite thing to do when you're stoned? Nothing?
Come here. Come here and debate the shape of the earth. That riding, I really like motorbike riding.
Don't ride when you're stoned. Jeez.
Oh, off-road, it is delicious.
Off-road. Okay.
On-road, it's a little bit.
KFC when they're stoned and they're talking and they're making an order and they forgot to wind the window down? Yeah. Fucking classic. It's an old ad, though, a long time ago. I've got to say, just listening to music is good when you're stoned. Especially watching a jazz video and all the intricacies of the like top level jazz players. It has to be recorded, like filmed really well though, so the cameraman can catch all of the nuances.
You will. It's not.
That's my uwu. My daughter's going uwu out there. So. Uwu. The bones.
My daughters found out about the birds and the bees the other day. Our dogs were knotted together.
Oh no!
Oh, they sometimes get stuck, huh?
Yeah, and they called up, and I was in Bunnings, and it was like I was on loudspeaker. Milo can't get his penis out of Molly. Fucking hell! Oh god.
Okay. I guess I should go to the gym. Let's do it. Stop being
I guess I should go feed the dogs a minute. Soon. I'm in a fucking tournament.
Right, is there
I can't quit.
Is there a particular part of that? Is that an hour and a half video you posted?
Yeah, but my presentation's in the first 13 minutes.
Oh, cool. Okay.
So, yeah, feel free to watch the rest if you want. Ignore, like, at the end of the presentation, Brian comes in just fucking blowing up. That ends within a minute or two. So, yeah, get past that.
Right. I love that on either side where somebody's been like, particularly if they've been unable to speak, because it's like only the chosen speakers, or they've been like unable to get to their mic, and they've had to listen for longer. So as a result, when they do finally come in, they come in so super hot.
Yep, exactly. That's what Brian did. Yeah, Brian's good though. I like him. Oh, do I
Yeah, I like Brian.
Yeah. I'm going to call with my pair of fives. Actually, no, I'm not. I'm not going to. Oh, definitely not now. Perfect. Not. Oh, fuck. Oh, sorry. I didn't call. He had a pair of kings. I had a pair of fives. On the flop was something king five.
Oh.
Eight king five or something. I was like, jeez.
Ruhif, you know how electrical diagrams, they explain how the current flows, and you've got all of the different components of an electrical circuit, yeah? And it's quite clear to see how everything interacts.
Yeah, okay. Yep.
Is there anything like that in the heliocentric model explaining the way that gravity works on all of the planets in the solar system, including the sun and the moon and the earth?
Holy shit, he just hit quads on the flop. Holy shit. I'm still in
I had this conversation earlier on, I never got an answer.
Yeah, is there an electrical diagram for gravity? I have no idea.
No, is there a diagram that explains, like, laid out in graphic form to show you how everything interacts, and a visual representation of the shape and the form of gravity and the direction and the pull and the forces involved?
You don't mean an electrical circuit diagram. You mean like field lines?
Yeah, he does.
You mean like field lines?
No, I think he means an electrical circuit diagram. Which do you mean?
And I
was
no
using
idea
it
what the
as an
question means.
analogy. I was using it as an analogy just to show, is there some type of a diagram that we can see that explains how everything works in our solar system relative to gravity?
I don't understand the question.
Two places I can think of, like one is Kerbal Space Program has a mod called like Realism Upgrade or Our Solar
system or something, which changes Kerbin and all of the Kerbal planets to Earth and our planets. And at least on the other one, it gives you like diameters, masses, and distances.
Yeah. But do you want like the value of gravity or something? The value of gravity.
Yeah, the value of gravity is going to be constant, isn't it?
No, on each like how surface much of each planet.
Yeah, and that's exactly what it does. It'll like tell you like, here's how much gravity, so you know whether you're going to be like bouncing around or like hitting down, and you're going to need loads of delta V to get out of there. Something like that, I think, is the best I can think of.
Yeah, I'm not sure what you mean though.
But yeah, the scales is the hardest thing I think to show one to the other, because you just sort of end up going like many orders of magnitude more than the last one. So one takes up.
Even maybe a CGI version of the solar system.
Yeah, wouldn't surprise me if you could get a fly-through model like that. There's I remember there's one which was like the scale of
it's fundamental to the heliocentric model. You think that this would be freely available for everyone to learn.
But just take somebody making it and then you finding it. But yeah, I remember one that was like our universe to scale. So it's not giving values of gravity and stuff, but you can zoom down to a quark or something. I forget the smallest one, and then you can zoom up to the known universe. And that gives you scales as you go past. So it's like, this is the Earth. You know, this is Earth's distance from the sun or something like that. And you can keep zooming in and out. So it wouldn't surprise me if somebody by now has built something like that. But yeah, Kerbal's a good way to go about it because it calculates all that.
Yeah, you'd think that like someone like NASA would have a program that they could delve into, and it would, they could punch in some numbers, and it would pretty much set them on like a simulator style visual sort of a representation of what they're going to be expecting to see, and how all the forces are going to be acting, and because they've got pinpoint accuracy when they're supposedly leaving the Earth's atmosphere, and it's like having a 100-mile gun range and trying to get a bullseye when you're flying a rocket to Mars. It's like a giant remote control toy. There's no one on board there. It's not like, because like when you're shooting a gun, you have a scope and you can see your target.
Hey, Carlos, we interrupt this regularly scheduled programming for an announcement.
We have to feed the dogs.
We've got to feed the dogs. Of course you do. He always runs away from the difficult questions. He doesn't even actually have any dogs.
Why don't you say, my lovely wife, I don't need dinner tonight. Can you give it to the dogs?
Occasionally I feed, yeah. Occasionally they get some good stuff. Anyway, we are going to feed the dogs. Enjoy.
A bunch of people wandering around Chiang Mai with impressive cameras today. I think there's something happening.
Where are you?
Chiang Mai, Thailand.
Oh, beautiful. I used to go, there's a bar there called Riverside. There's also a cafe there in Chiang Mai called Wai Coffee.
Wai Coffee, nice.
Wai, yeah, it's opened by a famous rock star.
Wai Bistro? Wai Coffee, I see.
Wai, yeah.
Yeah, right. So that's out of the old city. That's a fair way from me. But Wai Bistro is the same name.
Yeah, that might be it. They do food as well. Yeah, so it's like it's got lots of plants and in the sort of a outdoor sort of a what do you call it, a patio. It's a very modern looking cafe. Best coffee in Chiang Mai.
Right, I see. Yep. Cool. I do like my good coffee, so I might go check out this bistro tomorrow morning.
And if you want some entertainment, Riverside. All of the waitresses. All of the
Go on.
waitresses are actually men. But it's difficult to tell for some people.
Okay, I'll go check it out. Oh, I never have massages. Can somebody help me out with this? I just had a massage and I'm itchy everywhere now. Like my head's
They
itchy,
probably
arms itchy, legs itchy.
are you probably allergic to coconut oil?
She didn't use any oil. I was just wearing like, they just gave me these like pants and a shirt to wear.
Like a
Quite cool. Have
doctor's.
you seen this one? While you're here, I'm actually walking right back past the place that gave me the massage as we speak. And it is a women's massage centre that rehabilitates women from prison. So they're ex-prisoners who have been trained in massage and that's their job.
Jesus, they'd have a lot of
Look at photos. I go past.
they'd have a lot of dross in their chi that they're trying to get rid of onto their clients.
Maybe. I mean, anytime I watch those prison docos about women's stories, I'm always like, that's not that bad. You know? It's like, what are you in for? Like prostitution. Okay.
Go to the main strip. There's a guy that does sliders. His name is Bruce. He's been there for years. He's got like a little it's in the main part of Shanghai in the tourist spot there. He makes hamburger sliders. He's my mate. He's Thai, but he goes back to America for 6 months
Oh, nice.
every year to do fishing, making lots of money, coming back. Every year he comes back and he buys a house.
Yeah, there's a lot of rich belong there. Or like, I met a guy the other night who was only barely squeaking by, so there's a lot of that too.
Hello again. Sawadee.
Are you still there writing? Riding.
What up, Snack?
Yo. Before you ask, it's too early for saxophones.
What's up, brother?
I said before you even ask, it's too early for saxophones.
Yeah, it's too early for guitar where I'm at.
You play quiet.
What's that?
You get all quiet, playing quiet.
Yeah. Yeah, I just love these, like, I started fucking with the capo and, like, just C and F, and it's just, like, I just can't get away from it.
I sent you a link for some software that it's just as fine as if you don't buy it, but
No, you know what? I saw it. I
checked it out. Yeah,
That looks interesting because you can just use your voice.
it's like it's good for like the like putting beats down because like it's really good for like
Right, that's some
basically
Michael Jackson
like
shit.
like because I'm not any good at beatboxing, but like I've got rhythm, I've got a mouth. Anyway, so you can say whatever you want, you know what I mean? But just like it's just nice to like lay like just drum like bass and kick down, you know.
Yeah, no, I agree. I mean, it's
I
easy.
don't
It's easier than
but,
trying to learn how to play the drums sometimes.
but you don't want to try and put like trap hi-hats on it. That won't work. Or maybe like real slow you could do it. But I mean, it's pretty responsive, you know. But the pitch is like all over the place, you know.
Yeah, I could see. I haven't even. Yeah, did you download it or?
Yeah, I bought it.
Nice.
It was on sale.
Nice.
It's kind of good. I don't know. Like I could just use a keyboard, you know. It's just about as good. But it's like it's nice to like find out what pitch you're actually singing. A lot of times I just have it in my head. You know what I mean? It's like a tune or something. So it's nice to just like find it. Some just sketch it down real quick, where you get like notes out at the end. That's not just like on like an audio memo, you know.
That's kind of
Like,
cool.
hey,
You can find your pitch too. That's interesting. Like where
yeah.
you're comfortable, like what you're actually comfortable with versus what you. That's interesting.
This is a little frustrating because like I know like I'm hitting the right note, but like the thing is not recognizing like I'm hitting B flat. I'm like B flat, B flat, B flat. You know, it's like
It's a little
Yeah, I find it
frustrating.
weird. Like, it's so tough, like when you play like a cover song or something like that, and it's just not in your key, or at least singing wise, anyway. You know what I mean? You feel like, but if you play it in any other key, it kind of doesn't really work. I used to have an idea, and like the idea of like playing a set, of the idea of like what keys you should play in. You know what I mean? Like in an order. Like let's say like you have a song in A. You know what I mean? And like,
Okay, I got you.
like what are like what are the effects of that? I don't think it's
Move
any
around the
effect
circle
to
shifts with
some
your
extent.
set
Like what
list.
frequency? What frequency are you at? You know what I mean? Like what frequency, and then the way to like maybe orchestrate through those frequencies. Because I used to play you play with like reggae singers, right? And like all their, or like some, you know the deal, bro. Certain singers are like everything is in A or F sharp minor. You know what I mean? Like their whole set is like built in one fucking key almost, because that's their key. Certain singers and shit. Whereas I always thought you could like somehow manipulate what tone, because like, if you tried to play like Whole Lot of Love from like Led Zeppelin in a different key or something, it's just not gonna. I mean, it will. Nobody really notices if there's no context. But in the
That
same
whole
way,
like
let's say,
ramp like that, but like that won't
well,
spank
just
it
like
the same if you
any
choose,
like iconic song. Like I remember listening to a guy did "Hey Joe," and instead of doing it in like where it dropped, it goes to E at the end or whatever. Like he like played it in a different key or something like that, and it just didn't. I just figured, you figure it out. You're like, what's wrong? And you're like, oh, it's in a different key. Like, they can get away with it, but that iconic sound that like reminds you of the song is because it's in a certain key. That's what I like. It doesn't really, like, you could play any song in any key, but there's something to that.
Really.
Like you wind up like for like I'm loving this guy Tyler Childers. What he sing, he
Well,
does
I
a
mean,
lot of.
you could transpose any song to any key, but
No,
whatever
of course, of
whatever
course.
that song, I know, like whatever that song's really written in is really what that song is.
Yeah, that's where the vibe is, or like I don't know why. It used to just matter to me, like the idea of like when I was trying to like, and nobody followed what the fuck I was saying at the time. You know what I mean? But I was like really just trying to figure that out. Like, okay, what if you, what are the effects of certain frequencies, i.e., key?
Right.
And as like an artist, like, do you have one key? Do you stay in that key? Like, because I'm saying I've played with these like African reggae singers, and everything was like A. You know what I mean? Or F sharp minor. Like it was specifically designed to be in this key for this singer. Or do you like dance around? You know what I mean? Play one song in A, play a song, spell out a word. Like I don't know. You know what I mean? Like abracadabra. You know what I mean? DAC.
Yeah. Well, I mean, if you look at like, yeah, maybe. I mean, I don't know. My head's telling me to like think about like parts of like church mass and stuff like that because they're using different things. That's not on the same key, is it? That's the original rock show.
What I always found interesting was the concept of like I remember this one piano player told me about it. I've talked about it before, I think, with you. And like he was like a church piano player. You'd never expect he was like such a thug, and he was like a church piano player. Fucking dude was so interesting. But he fucking black dude. He was talking to me about how like there was this theory where like they played an A flat, because you have A flat and E flat, and that middle tone is C, and they were saying that the pianos were not tuned to give you proper C or something. And so they would play an A flat so that your mind would generate the proper C.
Wow. Yeah, wow, that's really funny. That's very interesting concept.
And if you check like a lot of fucking like a lot of old whatever, like I don't know, hymnals and shit.
Yeah, because
There'll
they
be
didn't have a
there'll be
equal
an A
temperament.
flat or a weird signature like that. It's cool. Like how they
That's before equal temperament pianos.
I wonder, what do you mean by that? Explain that.
Yeah, I don't know.
Well, no, what do you mean by like equal
I
temperament?
think it's I think it's just like a period where they were like, oh, we're building pianos wrong.
Oh, interesting.
Because they couldn't keep them in tune. If you like tune every C to its own C, then it won't work together. But if they base it on like one middle
Oh,
C,
I see what you mean. Like kind of like when they decided on 440.
well, it's kind of like also like it's going to stress the least. I think. I don't know, man.
Yeah, interesting. Well, yeah, I could see that too. Like people are manufacturing pianos.
It's just meaning basically like that pianos would be out of tune, or they would sound out of tune. Is I guess what I'm leading to.
Or even like you got me thinking along the lines of like, you know, almost like tuned to A versus tuned to C versus tuned to, you know what I mean? Like, and then that, I wonder if that didn't have anything to do with it.
Like I think if you like accurately tune a piano, it won't sound right. Like if you like each note, I don't know. Like maybe I'm wrong. You get like anyway. Tunings.
Well, I wonder because they have the effects of those like two strings in some places.
Well, there's something like very specific about light, right?
You're getting like a resonance, like or like a, you're getting like a resonant. I wonder if that's what you know. I wonder if they they complement what you're talking about with like the alternate string. For some notes on the piano, they'll have like 2 or 3 strings. You know?
I guess it's just that like we were talking about like moving a song from one key to another, and it just doesn't sound the same. But it's like they're very specific wavelengths, and so it's like if you had like a black light, you're like, oh wow, black lights are crazy. They do this kind of thing, and if you have like degrees off of that, well, the black light's not as punchy, or it doesn't fluoresce things at all. You know what I'm saying? So that frequency, that wavelength is maybe very specific, and the harmonies in there, that can produce like sort of ghost notes and shit, like all kinds of things that you hear in your head, but they aren't really
Yeah,
there.
for real though, right? That shit is crazy. Sound is crazy, dude. Sound, like, you know what it is? Like music and shit like that makes me. It just or I don't know. It's just such a ethereal thing that we participate in a corporeal world. It's just so weird, so eerie and fucking awesome. Like I love, or like you ever do like the? I love just like playing an E string and just doing the ohm, like finding the key and like creating that fucking sound. I don't know, man. Or like when I get on a loop pedal, you can really trip yourself because it's like you can create all these weird fucking sounds. It's so cool.
Yeah, didn't you upload a video, Issa, of you playing with your G string?
That's not on YouTube.
Oh right.
That's not, I don't know how you found that video, but that's hilarious.
What a hard work. How are you, man?
Doing well, brother. How you doing, man? Fucking A,
Yeah,
dude. I
good,
can't
good.
believe. You know what, man? I was thinking you earlier. I saw you and I popped in or whatever, and I was like, this motherfucker's been traveling for so fucking long, dude. Oh, God bless you, dude. I hope you get. You know what I mean? Oh, I just feel for you, man. I fucking couldn't travel that long. I don't think. I've done it for like 7 months in my life, but it's brutal, man. Fucking respect.
Yeah, it is a bit of a grind.
Oh,
from time to time, but at other times it's just awesome. I just look around. I'm like, oh my god, I'm doing it. I've been wanting to do this for years.
yeah. That's so cool. I mean, you're doing it in a place I could never even imagine. I've never been there, but I'm terrified of that shit because there's like bugs crawling under everything or something. You know, like, oh god, the tropics
What?
scare me a little. Well, like
I mean, a
you're
little. I can kind of understand that. I was
all
walking
right, fair enough. Come on, now.
down this.
But you're
Like
from you're from
I'm
Australia anyway. They got like 5 foot tall
exactly.
spiders and shit. I hear you.
But yeah, I was walking down the street. I'm in a city at the moment, Chiang Mai. It's like a big old city.
No,
I'm walking
wait a
down the
minute.
street.
Like the Shanghai?
No, Chiang Mai.
Oh, Chiang Mai. I was like, okay, cool.
Um,
Chiang
and
Mai. Where's that?
I'm walking down the street talking in one. It's in Thailand. Beautiful old walled city. Look at it on Google, and you get an idea of. It's like a ancient city. They built these giant walls and a moat that goes around it. They've still got some of the walls and some of the moat.
Oh shit.
But yeah, I was walking, having a chat in one of these rooms. I'm like, what is that? Because some bird had been like pecking at something on the pavement. Like, what is that? Walk up, and it's like a little green snake in its city.
Oh yeah. Oh yeah. That's fucking dude. Have you seen any like monkeys and shit like that?
Yeah, man. Yeah, so
Ooh, see, that's fucking scary as fuck to me. I'd be like, I mean, I don't know how you do it, but I'd love to have a fucking sidearm riding through that motherfucker. God bless you, dude, man. I don't know, because I know they're all weird about that out that way. I think I don't know. I don't know, but yeah, that's
I don't know
fucking
what the gun
wild.
laws are like, but certainly you don't see anybody carrying.
Right? I
That is
think
American.
it's probably illegal as hell, but everyone's got one. You know, I wonder.
I see hunters with them, but that's about it.
Hmm.
Certainly, no. The only people with pistols anywhere, pretty much except America, is cops.
Right. Yeah.
don't
No, I just think going through the wild,
Yeah.
traveling like you are. I hope you get something fucking nice. But like, yeah, that's wild, man. You ever been to any like Muay Thai fights? Have you ever been? You know those, Muay Thai, right?
Yeah, I know. If that was for me, yeah. I went to a Muay Thai fight the other day. It was awesome.
Yeah, that's what I'm saying. That's so fucking cool, dude. I've never been, man. That's so fucking cool.
Yeah, it was such a good fight that we ended up having this big debate afterwards whether they'd like put it on as an exhibition fight, like a little bit like WWE or something.
Right. I think
Because it looked legit, but
well,
it was
like,
it was such a good fight.
Yeah, it's cool, man. It's interesting. Those dudes fight like fucking like 2 times a day, fucking a couple times a week. Like they don't fucking kill each other, from what I gather. Like, you know what I mean? Until it's time to. I mean, they are fucking brutal as fuck. But at the same time, yeah, they have like an honor system to what they're doing, man.
Yeah.
Yeah, that's so fucking cool. Like the fucking I don't know the name of the horn, but that one, everyone's fucking. That's so fucking dope, dude. I would love to see it. I've seen kickboxing fights and Muay Thai fights here in the States, but not fucking, not there, man. Like fucking, hey, that's awesome. Did you get footage?
Yeah.
Dude, I would just say, like, dude, that's some. I don't know if I haven't been keeping up too much lately, but I don't know if you put it in one of your videos, but you must.
I will. I'll probably try and edit it down to a short though.
Right. So cool.
Yeah.
That's awesome, man.
Anyway, what was the vibration talk before I butted in?
Well, we were talking about pianos and how like pianos. Snack brought up like temperament of pianos because I was talking about this gospel player. Like, there's a piano player I used to know, and he was saying how a lot of music, or a lot of like older, like black hymnal music, used to be written in A flat, so is that the mind would fill the gap to create proper C, because the C would be the third of the A flat chord major. So like and it was just interesting because then Snack was bringing up how there was a certain time where they didn't have like a uniform temperament for pianos, so that's why they may have attempted to compensate it. And before that, we were getting into this idea of how like a certain song, like let's say like a famous song that you're into. If you were to go see a cover band and they played it in a different key, like you know, like would you recognize the difference, kind of a thing? And I was saying that we were just talking about the effects of like different keys and how that would affect you. You know, like and just how it shows itself when you try to hear or play a song in a different key than what it's actually written in, because you don't notice it at first, but you recognize something's not right. Some, you know what I mean? Somehow.
Yeah, you're like, something's not right, but I don't know what.
Right, but they're playing all the chords right. They're playing the progression right. They're playing the song right. But there's something, and then usually, or I've always wondered, even like ever since I used to play in bands back in the day, like, and it was just always like, do you stay in one key? Because like I'd have a singer that only played an A, and that would be the relative F sharp minor, so everything was in that genre of sound, which like I didn't really particularly like, because I always thought you should move keys in a certain way, and I wondered if you couldn't pattern them, like, so this song's in A, this song's in B, then like this song's in E, or you could almost spell a word, I don't trip yourself out on that level. It's ultimately I think, I mean, you could just poo-poo it and say it's irrelevant, but I wonder what the subtleties are of it. That's kind of where we were at.
Yeah, that's quite cool. I like it.
Yeah, and like how like pianos will have, because Snack was saying if you properly tune a piano, it wouldn't sound right potentially. And
what's that? Why is that?
Well, yeah, I was trying to get to that too, but to kind of run with that idea, we were just kind of saying, like, if you notice, like, pianos will have some notes will have like a couple strings that create that. That's what the hammer hits. It'll hit like two or three, two strings or something. So I wonder if they haven't compensated for it. You know what I mean? In the way they tune those two strings. You know what I mean? Like, yeah. But I wasn't sure if they were tuned, because piano tuning is fucking wild. I don't know the proper hertz, the frequencies that they're using. You know what I mean? Like, but they have these little machines, and then some dudes can do them just by ear, which is fucking crazy.
Yeah, that is pretty nuts. I remember did a production back at school, and they wanted a piano on the stage, and but we had to clear out the stage, like bump out, so that the next show could bump in, and then we'd have to bump back in after them. So we're like sharing the stage with them night apart. The guy came to tune the piano, and we're like, awesome, thanks. That's like half of our production budget. And then somebody mentioned like, oh yeah, we're going to be moving it. He's like, well, you need to tune it every time you move it. I was like, my God, you're cute, man.
Yeah, because every time, all that wood shifts, it moves the fucking knobs. Yeah. It's crazy. I had a piano. It's weird because sometimes I don't know. I had a piano and it was like so old. It hadn't been tuned in so long that like they tuned it to A. Like they tune pianos oddly like that too. Like when they come, when problems like that happen. If you buy like an old piano or something like that, like you won't be, if you start trying to tune it to C, it'll fucking break. And so like, you'd have to replace all the strings and you know what I mean, all that kind of crap. So like they'll retune them, but that's wild because those guys know, they're crazy.
I do really like something about that, like super specialized skill that you meet somebody with a like insane specialization.
Yeah, there's it's a trip. I always used to like I would like have my piano tuned and the piano tuner would like play a little bit and you're like, the motherfucker could play a little bit too, Yeah, it's always like that. Yeah, I miss that, man. I gotta get I have a piano, but I don't have it with me at the moment. I mean, they're not easy traveling, are they? I gotta get a U-Haul and fucking all that shit. I want to get it. But I love that sound, man. There's nothing quite like it. Even like we get I have a digital piano, or an electric piano, whatever. And it's like, it's not the same. Yeah, so what time is it in Thailand?
It's like 5:30 p.m.
AM?
p.m.
Oh, forgive me. It's like 5:30. 5 here. I'm retarded. Yeah, that's cool.
Must be crazy late where you are.
No, well, it's early. I got up pretty early this morning to take care of some
So
shit.
late it's early.
Yeah, right. Yeah, it's funny. I used to remember I wouldn't go to sleep till fucking like 6 in the morning. Fucking stupid.
Yeah, I'm
What
trying to put that behind me. No more late nights scrolling through Facebook or arguing the flat Earth or.
Yeah, usually by 9:30 I'm fucking done. But like sometimes I just like I have like last like week or two or whatever I've had the time to just I'm up. So I'm like, fuck it, I'll check it out. I'll argue with somebody. Let's go argue.
There's something addictive about it, isn't there?
Oh, fucking right, dude. Well, you know what I think it is, bro? Is that you're talking to people that have studied the same shit you're into. So it's
Yeah.
like, and with such a unique thread of ideas, and it encompasses a lot because I've always thought that anyone who got into the flat earth discussion or like you got on Discord or whatever it may be, I was like, dude, you're like one of the smartest motherfuckers around because you could ask anybody, do you have a Discord account? They won't know what the fuck you mean. You know what I mean? Do you know what this is? Do you know what that? They don't. No, nobody knows the shit. They're not
Yeah.
interesting. They're fucking boring.
Sorry.
Yeah, go on.
Discord's kind of dead.
They're good. They figured it out. Some other people turned up at this guest house, and they couldn't figure out their door. Good now. So you were saying like you go people in Discord, you find these people who are interested in this topic and they know a lot.
Well, they know a lot about other things. Like because when I first got into the discussion of the shape of the Earth, it's quite an interesting little story actually. But to just boil it down,
Boring.
What's that?
Nothing. Just nothing.
Who is that? I forget. Who is that? Oh,
I'm riding on eggshells.
Oh, okay. You're a friend of. Okay, forgive me. Yeah, how you doing, brother?
All good, bro.
Right on.
Sorry for interrupting you. Continue, please.
Oh no, you're perfectly welcome to interrupt me. That's what we do here.
Yeah, I know about it.
It's just.
But it was a bit
barrage
disrespectful. You just said, "Oh, it's an interesting story," and I was like, "Boring."
Oh yeah, no, you're good. Yeah, no, I had when I come into the flat Earth, I came in like guns blazing, eggs, like fucking, you know what I mean? Like, cause my whole theory was like, if you say flat Earth is stupid, like fuck you, get flat Earth out of your mouth.
Flat Earth
Like
is
that used to
stupid.
be my whole shit back in the day. I was all argumentative and ready to go to war, and fucking, I would offer people to come to the gym in New York and come fight me if they wanted to come fight me. Nobody ever came. You know what I mean? What's that?
That's funny.
Oh, dude, I had so many trolls, and like, dude, there's like so many like sock accounts, people attacking me. The first day I went on fucking line, my computer went fucking red. I got hacked. I switched on to another account, fucking went back on. Didn't know anything about VPNs. I was like, "Fuck you, come find me," and like, oh, dude, I just went to war with these people. I mean, Snack, can I get an amen?
That's funny.
You know what I mean?
Did
And so,
you
like, what was crazy, dude,
Did
is
you,
so
did
like,
you ever have any real fights or meet up? Did it like spill over
nope,
into real world stuff?
no, because nobody would come.
Right.
You know what I mean? And I was like, we'll do a YouTube video. We'll put it on YouTube. You know what I mean? Come down to my gym. Fucking help my coach ref it. You know what I mean? Like, you'd be all right. You'd be safe. Don't worry about it. Or we can meet down. Or we can meet right in the city, bro. We'd pick your spot right anywhere in New York City. Come fucking see me, dude. That's where I was at. And
once or twice.
And but right? Am I wrong? Snack? Come on, I offered it up. I was like, I'll pay for your flight and everything. I was like, come. I was like, let's do it. This is content. So like but anyway, I was all guns blazing, and then it was interesting because I came across like Snack, And Snack it's kind of crazy because Snack was part of a crew that was running this Flat Earth discussion free chan.
Oh,
And
right.
and so what's crazy is that I know Snack in my real life before I ever went online or any of it, dude. So I've known
Oh, that's
Snack.
interesting.
Right. So he through a couple other people, they came and like kind of like sought me out. I went onto a couple of channels that they were fucking with, and then it was Cathexis and fucking Hitch. You've never talked to those guys, but they're fucking awesome dudes. And they fucking came and got me, and they were just like, "How do you know it's flat?" Da 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 da. Like hit me with the globe, like, you know what I mean? Like just like boom, 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 and
Yeah.
like made me question all the shit that I was like so sure of. Do you know what I
Hang
mean,
on.
bro?
Okay, so you were originally like offering to have fist fights with people as a Glober against flat earthers.
No. As a flat earther
No, the
against
opposite.
Globers. As a flat
Okay,
earther
so,
against Globers.
sorry, I thought you meant like you were still a Glober or joined the argument,
No.
wanted to find people
When
and
no. When I came in,
That came later.
I came flat earth and like swinging.
Yeah,
You know what I mean?
right.
Like, fuck you, get flat earth out of your mouth if you think it's stupid. Blah, 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 blah,
That's
blah. You're a
pretty
fucking, you're a
Stupid.
fucking, I mean, dude, I would just be relentless because just be like a dick about it. Like, you fucking loser, fucking, just fucking go in on people, dude. And I'd rip them a new one and fucking, I don't know. And then I think I was pretty eloquent about it too, dude. We used to fuck these dudes up. And like me and Cathexis used to challenge them. Like, we would go in and do like, it was like good cop, bad cop shit. What's that?
What?
Hello.
Cathexis.
Yeah, who is that?
Another faggot.
Oh, Cathexis. Another faggot. Yeah, he's one of the best, actually. Another faggot. Yeah, no, we used to go in and just like debate like flat Earth math and all these different guys and like have a good time with it. But I became friends with all these people, and I was always friendly with the ballers, like, you know what I mean? Because I was, I don't know, I was a dick, but I was approachable. You know what I mean? So like, I fucking like I am, and what do you call it? We all had back and forths, and then like
Texas versus like Jump Panda was pretty good.
yeah, and and that's what actually, well, yeah. Like when I first rolled up into Free Chan, it was like I literally had to like look up words these guys were talking about because their debates were so intense and all this crazy shit, and you were just like, damn, like, you know what I mean? Like, because Cathexis has always been a flat Earth apologist, not a flat earther, and he used to argue for flat Earth against the Globers.
Hang on. He was like, was he open about that? So he'd argue for the flat Earth despite being like, was he open about being a Glober but still just steel manning it, or what?
No, he was totally ambiguous about it.
Right.
And that's what killed everybody.
Right.
That's why they hated
Similar
him
to
so
Pin
much.
Cleanser,
That's why they
actually.
hated him so much, because he would show the fallacy of flat Earth while simultaneously making an argument for flat Earth and destroying the globe in the process, like, or destroying the theoretics of the globe. Like, I mean, I remember Neg. Neg has ate shit on my channel more fucking times. Like, a lot of people ate shit on my channel because Cathexis just fucking would wreck them, and on Free Chan. And that's where Free Chan, but Free Chan was like cowboy territory. Like it was like almost Glober themed. Like you really didn't know where anybody, dude, back on Flat Earth, nobody would say they were the Flat Earther. That's the other thing.
Oh, what? Okay. So there's actually a lot of noise in the environment.
Yeah, I mean, yeah.
Because when I
Flat
first read
earthers
about
have
it,
different fantasies about different things, so they don't all agree on the same stupid shit.
Fair
right?
enough.
But I've heard this before I got into it, which is that it's like like any fan group or nerd convention kind of thing of like just mostly dudes who are like really weird critical thinkers, probably leaking out of message boards and stuff like that. And that was some of the idea that they were writing about, where they're like, you can never tell what side people are on, but you're quite confident some of them are just
doing an extreme exercise in critical thinking,
Right.
and they
And
don't
well,
actually think the Earth's flat, but they're making you challenge why you're so confident about it. And like I'm not lacking in
Yeah,
confidence
because
about it.
you have the burden of proof.
Yeah, I mean, you don't have to prove anything to anybody. Like this burden of proof stuff, as a slight aside, is missing an operator. I don't have to have the burden of proof. Is like, according to who? Like, if you told your wife, "No, I didn't cheat on you," that's fine. But
That's
if you
not
offer an alternate,
analogous.
if you offer, well, I mean, what I'm saying is, it's up
It's
to
not
the
analogous, is
person.
what you're saying.
It's up to the. What I'm saying is, it's up to the person speaking and the person listening to agree on who holds what kind of burden of proof, and you regularly won't agree. I don't understand why you get to be in charge of what should
No,
make
no,
me
no, no.
satisfied by your
You
position.
have the
You know,
assertion that goes against everything. It goes against.
he's not a flat earther,
The,
bro. He's not a flat earther, Stone.
are you sure?
Yeah, I'm
Yeah,
pretty sure.
sounds like
Actually,
it.
I'd like to think Eggshell is, but he isn't, bro. Don't worry, man.
Oh, you're not on.
You're
Okay.
you're attacking him for the wrong. Yeah, you know he's all good, man. He's on your team,
I
bro.
didn't realize
No,
that
I'm
was
not
Lewis
He's
Blue.
attacking.
spinning.
You'll
Yeah,
know when I'm
Funny.
attacking.
yeah. He's spinning in that gay fucking fake space you fucking think you're in, dude. Same gay space.
Rocket ship.
Gay space. So space has a
But anyway, go on.
Gender.
Issa,
Yeah,
is there
that
any
was.
way that you could be wrong?
Say again.
Is there any way that you could be wrong, Issa?
Yeah, of course. Of course, man. You know, is there any way you could be wrong?
Of course.
Right. That's why we're here. And like we were saying, that's what makes this. That's why I was saying, even like, despite
I mean,
people's
there's a
shitty
very
attitudes, there's some of the most
minuscule
intelligent
chance
people.
that the Earth is that there's a big conspiracy to cover up the shape of the Earth.
Well, here's the way I slice it. There is a very small chance that the Earth is flat, but there is an incredibly fucking tiny chance that the Earth is flat in the way that most flat earthers describe it. Having a dome, being a set size, density and buoyancy, the path of light, the gyro compass, all of these things. Like, it's an incredibly minuscule chance they've got it right. Simply mathematically, they have too many beliefs for them to all be true. They've got to be wrong about a lot of them. But could it be flat? Sure. Particularly if you think about different ways. Like, could we all be running on a flat computer chip? Like, we are just in ones and zeros. We don't realize that. Maybe. Like, where's the curvature in a 1 or a 0?
Well, it's so weird to me.
Different.
Like, people are more apt to accept that notion of reality than the alternative, like, let's say, like flat Earth. Like, they're more willing to accept that they're in a computer simulation than they are, like, let's say, on a.
There's
on a
more
flat Earth,
evidence
which
for a
is interesting.
computer simulation.
I mean, fair enough. If you want to look at it that way, I mean, but you know,
it just makes me.
Well, considering there's no evidence for a flat Earth, so.
Well, it looks flat, and I don't feel like I'm spinning. That's the whole fucking thing right there, bro. The problem that the globe has.
Well,
to
gosh,
fight.
there you go.
Yeah, I mean, despite your
all the evidence, fuck, there
despite
you
all,
go.
despite all the. How about this? How about this? Despite all the evidence, in your opinion, you've got an uphill climb to go against someone's real perception of the world, which is that they don't feel that they're spinning. The sun, the moon, and the stars go across.
You're not spinning. It moves it rotates one time a day.
So, like, yeah, we've all heard these all before. Issa, do you think there is a minimum rate of rotation that a human could sense? Like a sort of, be it acceleration, change of vector, or just rotating in space, or adding all three? Do you think those numbers could get sufficiently low? I'm not talking about 0, but sufficiently low that a human couldn't feel it? Or do you think they could feel it even if it was like you're going at 2 kilometers an hour, 2 kilometers a century or something?
You know,
like,
I no, I understand. And I would have to say that there potentially is. Do you know what I mean? There potentially is. You're right. Like, how could I, you know what I mean? But at the same time, it's like, you know, we're so acutely prepared to deal with our environment around us, right? Like, exactly. It's like I can sense, and now granted, like, I get, you know, we could both make this argument too. This is what I was kind of getting to earlier, how the boys came to me and said, "Hey, these arguments can be made on both sides of the fence." Blah 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 blah. You know what I mean? Like this is why the philosophy of it. That's why what I think flat Earth is it's this discussion that when you've either got people who accept a third party's information about stuff, which is really where the battle is, I think, of flat Earth, because
sure,
this is the discussion of this. One second. The discussion of the shape of the Earth is a fucking stalemate.
No.
Yeah, no, it's obviously flat, and it's not obviously a globe, so it's not a stalemate.
Well, and I happen to feel that way. You know what I mean? But I give credence to the other argument because I feel as though we're in the arena together, and I want to show respect. However, to me, it's
If
utterly
you could,
fucking, it's utterly
provide some
gay and
type of
fucking fake.
evidence, that would be
It's utterly
great.
gay and
Just
fake to me.
one
But like,
piece of evidence for a flat Earth.
Yeah,
well, I don't.
everything you experience. This is actually what Cathexis used to say. In fact, he wasn't a baller. I think that was a little bit misunderstood, and by
We're
writing
all
because I don't.
ballers, dumbass.
He wasn't a baller. No, we're all flat earthers because it's obviously stationary and it's level. It's not moving, and we never see
You can
curvature.
give me some
That's
evidence
the
for
best
that.
evidence.
You
That's
can
the
give me
best
some
evidence you're ever going to
actual
get.
evidence for it.
Every single person in the world that ever lived experiences the world as a stationary plane. That's the best evidence you're going to get for either side, bro. We
No,
all
it's
experience
really not.
Can I please, rather than just yes it is, no it isn't, yes it is, no it
That's
isn't, guys, that's dull.
yeah,
I want to go. I want to go.
Try to
Yeah, I want
explain
to go.
something to one of these.
No, I want to open it up to the room. I want to open it up to the room. I want to open it up to the room, but I just want to like redirect. What do we think if we say I don't feel like I'm spinning? Could you like hazard a guess at a number? If I put you on a merry-go-round and I spun you around like you know that guy does it with a motorbike? He like leans over his motorbike to put it in contact with the spinny thing. You know the playground thing? It's like a disc of metal that you stand on and it spins around. And I put the motorbike tire on it and spin it up real fast. We know we're going to feel that, right? You see the guy and he goes flying off it. How slow would that move? So,
Well,
no.
when you put that tire on there, how fast is that thing spinning?
Yeah.
What's the highest it can spin?
Lippy, on the perspective.
No.
Check it out. The answer is this though, like eggs.
No, let me finish.
The answer
is this what's the slowest it could go before you're like, I can't tell if I'm spinning or not?
Hold on, eggs. Like here's the thing: is that we're so sensitive. I don't think that if there was, personally, I think if there was any sense of motion, we would feel it. I think that now. I think. Hold on one second. Now, granted, that said, there may be a specific speed or a specific motion. I just don't think it's 15 degrees per hour or whatever the calculations would be on the speed on that. Like, I just don't. I think we would innately feel it. And the thing is that we have evidence to suggest that. I mean, like just looking from our senses, right?
When you say
That the
innately
stars,
feel
the
it,
sun, and moon, that's what's moving across the sky. The
and
sun.
I'm assuming your creator gave you the ability to sense things, and some of this is an affront to say, "Hey, your creator didn't give you this sense." Would you agree that's like some of the crux of this argument?
Well,
do you have the sense to know that spin?
It's not a
wait.
crux.
Hold on.
It's not a crux, but it's just like but I could see where you're alluding to. I could see how those arguments could be made from the flat Earth creationist kind of perspective, but that's not.
Can I clarify something though?
To me, the two propositions are this: that we evolved this way or we were created this way. But your suggestion relies on us either evolved or being created in such a way that we were on something spinning. That's what we're hypothesizing and testing. And you say, I think that something that was born on something spinning would be constantly aware of that. And I'm like, why would a creator do that? Like, it's almost cruel. What would it feel like to know you were going 1,000 kilometers an hour hurtling through space?
Here's the thing, though, eggs. It's like this is the problem. This is the real issue: is that what the globe proposes with all its orbital mechanics and the rest of it is fucking.
Oh, do you understand orbital mechanics?
Hold on.
No.
Hold on. It's stupid on its face, and the idea that you would think that I wouldn't sense it.
So you don't understand orbital mechanics, but you think it's stupid.
Well, I think orbital mechanics is a thing. What I'm talking about is the idea that I'm on a planet, like, exhibiting orbital mechanics, doing orbital mechanics. That's my issue. It's not orbital mechanics. It's the idea.
You don't think you're orbiting because...
But follow with me, Issa. Follow with me, Issa. Why would you have that sense? Why would you be consciously aware
No, but why
that
would I
you're
consider the
spinning.
notion? Hold on, but why would I consider the notion I'm spinning when I completely don't feel any? There's no impulse in me to suggest that I am spinning. There's not
Because we
one.
figured it out before
You
you.
figured
You
it out.
realize there were people before you, right? Thousands of years before
Oh,
you,
brilliant.
and they
That's a really
also
good
had
thing to
these
point out.
questions,
That's a
and they
great
figured
counterpoint.
them out.
Oh my God,
That's a
we never
good one.
thought of that, Issa. He totally got us. We never thought about people before us.
I maybe you
This
did.
discussion never would have
Maybe you
happened.
did. You can't
Hold on,
figure
bring
out
it
the
to back.
shape of the
Bring it back
fucking
to
planet,
X.
man. I
You're
mean,
just
I don't know
angry.
if
You're
you know
just
about
angry,
people
buddy. You
living
need to go
before
for a
you.
walk. You need to go for a
Wait,
Can
I
I
walk.
just
try
want
and
to make sure, can I clarify
can
something
I
with
try and
eggs.
go
You were
for it?
trying to give an example earlier about the merry-go-round and how slow it would have to go before you couldn't feel it, right? And
Yeah.
from
Well
that
remembered.
example,
Well
you're
said too,
right,
man. You're good.
right.
Sorry, I'm just going to give you a compliment. Well done,
Okay.
man. That was word for word. That was awesome. Fuck yeah. Oh, if you did that in one of my training rooms, I'd be like, this guy did it. Do what he did. That was
All
awesome. Go
right.
for it, man.
Well, it sounds like you were trying to get to the point that if it was only going certain amount uh, within a certain parameter of one day or however it is, right? It's kind of
Yeah.
like using the example of a clock that they always say. The Earth would be actually if you were only going one rotation of the Earth, it would be twice as slow as the hour hand of a clock, right? Are you still under the
Oh, yeah.
impression? Are you still under the impression that it's that slow? That's what 1,000 miles
Mm,
an hour would actually be?
no, what my feeling about the 1,000 miles an hour is like it could go up or down by a lot, and I wouldn't know. That we're not spinning would be unlikely, but like the particular number, I'm just like, it kind of it vaguely makes sense. Like I'm not really interrogating that.
The way I like
I'm
to explain that is that they get you with the relativity trick, or not a relativity trick, but relative trick, right? So relative to the size. So if that clock
Oh,
was
so you don't understand
literally,
relativity. Okay.
listen, if that, it's not about relativity. This is
That's
about
true.
if the clock, stop, don't interrupt me, dude. If this clock was as big as the circumference of the Earth, then the tip of that hour hand would be going 1,000 miles an hour. It wouldn't be slow. So
sure it'd
why
be
is
like a
that
disc.
example all? And why are people still acting like that? Makes sense to compare it to the size of a clock.
Sure. I mean, yeah. Let's continue your metaphor. I think it's a really good one. So let's slow down the hour hand. So we've got a 24-hour clock, right? So we've got more indents there, and then the second hand, let's spread it into a disc. And they're saying that's how fast you have to be going. I'm not arguing for or against that. I'm just saying if you slowed down that scooter so you were turning the people on the merry-go-round thing incredibly slowly, as slowly as that hour hand, or 1,000 times slower than that, or 4,000 times slower than that, or 400 trillion, or do that 10 to the power of whatever, like, is there a number that I could get to where you go, yeah, I don't actually think I'd feel that. I don't, if that was a sufficiently greased roundabout, merry-go-round thing, and I was blindfolded, or I wasn't, I could look up at the stars maybe, never mind. Is there a speed that could go that would be so slow that you couldn't feel it? Or do you think if I rotated it once every 100,000 years, you would go, I can still tell it's turning, right? We all must agree there's a
You get my
base,
point, and why that example is not really what we're talking about.
Let me just finish it. There must be a base point that we agree to, that we go, and no, we don't even need to agree. Just set it for ourselves where I go, it's probably below that. Like taking a turn in a big ship, I'm not sure I'd notice that. I might notice the leaning, but would I notice a rotation no, I've been on a bunch of ferries. I don't consciously go, it's turning now. Fall asleep, wake up, watch my movie. I can't tell it's turning. So somewhere maybe a bit slower than a ferry. Changing course.
But my point is, and you agree that if the clock were as big as the circumference they say the Earth is, that the hour hand would be going 1,000 miles an hour, and the point that it would be and going slowly isn't even relevant, right? It's still 1,000 miles an hour ground speed. It has nothing to do with 15 degrees per hour or one rotation per day. It's actually 1,000 miles per hour. So we can't agree that it would be going slow enough that we wouldn't feel it automatically with the 1,000 miles an hour. Then they have to say it's so consistent you don't feel it. That's where the real argument on your side comes in, where you're like, oh, well, if it was constant, then maybe I couldn't feel 1,000 miles an hour because of the one linear direction of an airplane. But then you get into the idea that it's a constant acceleration around for any kind of circular path, right? You got to constantly be accelerating. You have to constantly be accelerated in any kind of circular path. So it's different than linear to begin with. And on top of that, you have multiple directions, and they take all the vectors, they put them all into one vector for the maths to work out, and they treat it as though it's one motion when it's separate motions and separate speeds. So you got a lot of things to deal with, and the vector maths make you guys believe it, even if I bet like 99% of you guys don't even know the vector maths or how to calculate it.
Exactly.
But even if you could, it's just putting it all into one motion, which isn't fair because it's not one motion, and it's varying speeds that are way past what the human body and without a container could ever handle. We have to agree to that, right? You couldn't go 1,000,000 miles per hour in the open air and have your body not even have a reaction. You'd have to have a closed container for any of those motions above 1,000 miles an hour to even seem like livable, right?
So can I ask you a question? If you're going to keep saying 1,000 miles an hour, no, that's okay. I appreciate you're really good at remembering things. You structured a really good argument. Then I think there was a lot that was awesome. When you say 1,000 miles an hour, that to me is speed must be relative, and it is typically relative to the surface of the road. Right, we don't subtract things, but it doesn't always stay relative to that. Particularly, I worked filing documents for a law firm for a while, and your relative speed to the other car was constantly talked about because we were personal injury. So they'd have car crash, and we go, they're going 60, they're going 50, adding up to a total of 110. And then sometimes their physicists would dig deeper into it. You would hire them, they go, yeah, but they kind of glanced off one another, and this one, blah, 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 blah. So it's got to be relative to something. 1,000 miles an hour is, let's say you are traveling at 1,000 miles an hour, and then there's another car next to you doing the same speed. Relative to that, you're going 0, right? So all of the 1,000 miles an hour is like you just put, I think a ferry's quite good. Put it all on a really, 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 really big ferry. I was on some pretty small ferries, and I didn't feel much unless the wind got up and then there was swells. But I don't I need to be changed.
What you're relative to. The body doesn't keep track of that. The body doesn't know how big the orbit is. The body just knows it's going 66,670,000, 66,670 miles per hour. And I don't think any human body is really meant to go that fast, especially without a container, and especially if it's in another direction opposite to the one it is originally started, right?
New perspective, you said it in the first two things. You said, I don't think a body knows what it's relative to, but I think it feels 1,000 miles an hour. My point is that 1,000 miles an hour must be relative to something. Like I said, the surface of the road. What is 1,000 miles an hour relative to here? Because relative to the thing next to you or the chair you're sitting on, it's 0, right? So the chair, the room you're in, the windows, your relative speed to that right now is probably 0. Unless you're in a car, and then you're 0 to the car, but 80 to the surface outside, maybe. Right? So we need to know that speed, and you keep going 1,000 miles an hour. I would feel 1,000 miles an hour, but you preceded that by saying, I don't think my body knows where it is. It doesn't know what it's relative to. So how does it tell 1,000 miles an hour when everything around it is moving at exactly the same 1,000 miles an hour?
Hey, yo, Eggs. The thing is, that could be plausible.
Brilliant. Absolutely.
Yeah, that's totally, let's say that's plausible, right? But the thing is, the alternative to that, which is so much simpler, which makes more sense. It's more elegant.
Really?
So if you want to, because I always feel like, think, just look at yourself, Eggs. Like the amount of explaining you have to do to get this concept across. Like in the idea of, well, you're moving and it's moving and then you don't feel it and you're just like moving this mile and then you wouldn't detect if you were speeding up because listen, what I'm saying is it sounds, and I'm just saying it's this is part of the reason I don't know, I feel the way I feel is that, and it's not you the first, you're not the first to have done this, but it's it sounds like the ramblings of madmen trying to convince us that what is before us is fucking lunacy, and that. It's so simple.
What's the purpose of that?
Brother, you could figure out the purpose if you would like. I'm not in the willing.
No, because you don't got one. Because you don't have
my point is that the alternative is so much simpler and more
something
elegant.
that fits into your silly ass.
That's all that it is.
No, I think it is simple. I think it's more elegant. I think it's more imaginative. I think it's more free thinking. I just don't think it's real. Like I think it's a.
Check it out. You're the one who
doesn't believe Occam's razor applies whatsoever.
The idea across.
Because you were saying about this guy that you used to talk to back in the day where you're like, we couldn't tell where he was. It was like he was steel manning or
representing the flat Earth while not necessarily believing it. Is that how you put it? Something like that?
Well, no, it's just that, like, first off, here's the thing, and
Oh,
this
wait,
is
wait,
the,
wait.
this is the real thing. Hold on one second. None
Yeah.
of us, none of us, like, not not you, not me, or whatever, has the obligation to tell anyone else what you think about the shape of the Earth. You don't have to tell anyone who you voted for. You don't have to tell anyone. There's certain principles. So, like, in that regard, you know what I mean? Like, people early on, especially, maintained it. Like, maintained that discipline. That's all.
No, you're making no
wait,
sense. You're making no
Issa,
sense. I'm gonna cut you down because you're making no sense, mate.
Issa, you gotta let me say that just to clarify for the sake of anyone listening, Cathexis was not a baller. He did not believe it was a ball. He wouldn't say that he's a flat earther because that
New
was the way of,
perspective.
you get
Let me school you on
categorized.
something.
He was a flat earth apologist.
Hey,
that
bro.
there's enough evidence. He would say it this way. Correct
Flat
me
Earth
if I'm wrong.
apologist, that's
There's
what he
enough
said.
evidence. Enough evidence to convince someone that they live on a spinning ball, but the Earth presents itself to us as flat and stationary. Right? Is that right?
That's well said.
Yeah,
That's really well
Cathexis'
said. I like that.
line right there. And
Right.
but I will say this, but Cathexis also, he defended the notion of the Ptolemaic model of, like, the geocentric Earth also as a globe.
Yeah, but geocentric, but
You know what I mean? So, like,
Ptolemaic model was
all these points